We have a minor problem. Your system thinks my PowerPoint is broken.
And you print it as a PDF?
Well, the other alternative, I have an embedded MP4 for my demo, and that's what it seems to be unhappy about. I have the MP4 separately. I can bring it up and just play it.
Well, that might be, unfortunately, that is the form.
What's it doing when you open up?
Yeah, but, well, it says that it's broken.
So let's do this. Let's close it.
John's having an issue with his PowerPoint.
What's an open document?
Well, I've seen your professional.
Hey, John.
Hey, good to see you, Jeff. Yeah, so I did this in LibreOffice, but exported it to PowerPoint, ran it on my daughter's computer, and her PowerPoint took it just fine. But
Let's
Do you
try
have the LibreOffice?
this.
I think that's what's actually on there.
I have
LibreOffice open fine.
I have LibreOffice. If you have LibreOffice on here, that would be the native.
I believe that's the case. If not, we'll go get my laptop. It's got LibreOffice on it.
Okay. John is going between Tapper and here.
No, I can be here the whole time, so it's not a problem. It's not showing me the extensions, but one of these is probably the LibreOffice
that's
version,
okay.
and the other should be the PowerPoint.
Still not finding, still not doing it. What I'm trying to do is open it, rather than clicking it and opening it up, hoping PowerPoint will open it, but it's
Yeah,
not.
that's what I tried. So if LibreOffice is on this machine, that would be the least painful way to do it.
LibreOffice, do you see it?
That's why I wanted to get here early.
LIBRE?
Yeah.
LibreOffice.
John, what we probably can do is try to bring it up on another computer and then bring that computer
Nah, it's not here.
talk.
Okay.
Do it that way if we have to. Do you have embedded stuff in there?
Well, and I think that is the problem. I have an MP4 file that's embedded, and that's what it seems to most dislike. I have the MP4 file
Yeah, I was
separately.
trying to say, if not, could we do a PDF?
If we can, I think. No, I was able to open it. And
So,
where's,
Alan, we might have to do that. We might have to put John's stuff on your computer, and then when John comes up, we'll put that computer on the system.
but let's,
Oh, shoot, well, I'll have to go get it.
well, hang on. I don't think we'll have to do that. Let's just
There's plenty of time.
see what properties are. Okay, that's PPTX. Okay, so yeah, I have. I think we'll be okay.
We're right next to the Mars, but you can't, if you go in, if you just go straight across the highway here past the pizza place, and then that door.
Okay, I can.
And somewhere stuck off in the corner of my black backpack.
I can.
Now I'm gonna get all sweaty.
I can do the slideshow.
think so, but I always forget.
That's what I was
Well, we're gonna bring a backpack, we're gonna bring a laptop that has LibreOffice.
Okay. Because otherwise, I can do the show, and then we can just open the MP4 file. Well, actually, let's make sure this thing can even open that.
What often happens in departments is that he probably was. It's a political job. He probably was department head at some point, and they rotated. He doesn't put it on his resume. Would you? It's just volunteering you for the potential of hassle. Yeah.
Yeah, so I can play the MP4 just outside of the presentation if we have to. So we'll be okay either way.
I guess I just figured for 10 or 15 minutes, it's probably not get too parched.
See, nobody at the gym is running off with my,
Okay.
my water bottle.
Well, they just opened the doors, so.
I hear some rumbling. I think maybe the air conditioning. I hear some noise.
Great.
Now, that door there, just all these inside doors need to be shut after they're going, so. Once you get going, sir, I'll shut those doors in the back so the air conditioning doesn't get diminished. The number.
Yeah, it's just gates right now.
Okay, so I should be set to do the presentation in PowerPoint and then just switch over to do the demo.
So Alan, can you load it on your computer?
Yeah,
All right,
we can have my computers back there.
all right, we should probably do it now.
Eh, So,
This is gonna be back there with it.
do you want to copy my stuff into your presentation folder on here, or just,
But I thought we couldn't open it.
we can't, yeah, no, it opens, it just won't play my demonstration that's
Oh.
embedded.
Um,
So if I,
well, if you're gonna change computers anyway, it won't make any difference.
well, I don't need to, I mean, I can do the demo from here, and then just I can do the presentation from here, and then just open the MP4 file from here and play it. So I think everything should work fine on this machine.
Okay, so let's do that, John.
So, I'll let you,
My computer's emergency, we'll have a backup with LibreOffice on.
All right, let me put that where it belongs.
yeah. And we just need to get, there'll be two files then.
Why don't you copy those and I'll show you where to put it, John.
Okay,
I was gonna say, if I just brought my laptop case, we just install LibreOffice on that.
okay, so that's one, and I'm actually gonna put,
Just download LibreOffice and install it. Download LibreOffice and install it real quick, see if something.
okay, those,
Well, we gotta start pretty much on time.
Yeah, we do. There is some slack at the end.
okay, so I just copied,
I'll let you do it, John, but let me show you where to put it.
okay.
So there's a D stick. Where's my D stick? There it is. So you want to put it into this one here. You can use the mouse if you want.
I'm
All right, yeah, whatever.
weirdly left-handed. Okay, so
Store AI form.
okay, okay, got it.
Yeah.
Okay, so my presentation, and then that's the MP4 file.
Okay,
That'll run for about a
we're
minute.
good. Thank you.
Okay. And I have this, so if we need to go out to another machine, I can run from here.
All right, thank you, John.
There's still gonna be issues with the youth forum, starting at right at 9 o'clock. Right.
On the second day.
Well, maybe, if there was some forethought, they got those people speaker badges, which means they can get in at 8 o'clock.
Hey, Jim. You get inside? No, No, it's where the main gate is to the right.
If he sees the,
Yeah, we're just gonna have Alan go first, so don't worry about getting there right away.
if he sees the t-shirts and the sweatshirts, turn
Yeah, Bruce is actually doing something else, but Dave can go and give you the pass. It's Jim,
Is he at the main gate?
about 2 minutes. Okay, so Dave's gonna come out and give you the ticket so you can get in. All right, thanks. Yeah. Yeah, bye. Thanks, Dave. Let me give you the ticket.
And is he with Angel or is he by himself?
He's over, there's a,
How many tickets you give me?
there's a ticket booth lower on the right, near the main gate. Do you have his phone number?
I think so. Because you're right, it'll be crowded out there.
Oh, it's gonna be a suit.
But there's only one ticket for Jim.
I don't know, that's all I got.
Because he's always with Angel. How are you, fine, sir?
Hey, Stan. Hey. Good to see you.
Greetings, young man. How are you doing, sir? See you, John. You looking good?
Yeah.
Yeah, we have two versions. That version. Tomorrow, we have this version.
I got this version.
Okay, this is like 3 RCA presidents walk into a room with.
But how many does it take to change a light bulb?
Good riddance.
Testing, hello, test.
Alpha guys accusing you of stealing your backpack.
They never blinked at me.
Dave is going to give Jim his ticket. In about 1 minute.
Okay, I'm just.
But Alan's going to go first.
Let's see. Did we get the? Did we get the presentation figured out?
I'm gonna head out, in case it doesn't work, we got my laptop. All right. So, this should accomplish that.
So,
Mark says how about
oh, good. Part of the, part of my mission out here this week, I am on to marketing promotions and Ham Exposition, which is a big show up in the Northeast. Okay. Any interest in exhibiting? Got 1 million people up there that have Apple amplifiers. All the Compass guys, all. Okay, I understand.
chips there, so that might be something that we could discuss in the executive.
Okay.
You know, especially since the booth's probably not gonna be good. Like, I think it's $2,500 for like. Yeah. You know, they were good. Yeah, and I mean, I'm trying to do some more little small money things like that. The big thing is we're gonna get that.
Really? So, the NRL job I've always heard about it, I've always worked for companies, periodically worked for companies that were involved, but I'm not a quote-unquote broadcaster.
Right. You see, the thing with Hamvention, we don't work at it.
Nice bag.
Should have a brochure and a pin in there and a sticker.
I almost took a complete set of shot glasses, but I decided I'd leave those to better people like me.
No, there's cases of them under there, they're just a total giveaway, so. You sign up for membership.
I don't know if I am still.
Well, you know what they're really good for? Is for putting little small parts in on workbooks, not losing the money.
Hey, if you send me your number, I'll send you the picture I had. You know, I did, you said last night, you should send this to AJ. You said to me last night, you ought to send this to AJ, so I did. He didn't, so I don't know, did his number change over the years? And if he doesn't have my number stored, he's gonna have no idea who it came from. That process go on.
Good morning. We're going to start in about 5 minutes. There's a 5-mile Woodstock-style traffic jam trying to get to Hamvention this morning. WWV, Fort Collins, Colorado. Next tone begins at 9:15. Nope, too loud. We're going to be this far away from the mic, so. Testing, hello, test. Hello, test. Okay, we're going to go. Here we go. Good morning, everybody. Welcome to the Futures of RF Artificial Intelligence Forum. As I mentioned, there's a huge parking jam trying to get into Hamvention this morning. So you'll have people wandering in over the next 15 to 20 minutes. I'm Chip, W1YW, and myself and Dave, KB9YPD, are moderators for you over the next hour and a half. And we're glad you're here. It's a very exciting forum with some fascinating talks by a number of speakers. Our presentations here are sponsored by the Radio Club of America, and needless to say, what we did is we brought in some of the talent that we have within the club, and we also went outside to make sure that we had a good representation of people who are doing cutting-edge stuff in AI. I do want to say one last thing in that regard, and that is we tried to identify very interesting topics that were happening within ham radio on AI. We didn't want to exclude anybody, so if for some reason you felt that there should be something else that should be discussed, we are looking very much forward to bringing that forward in coming years, especially next year. So with that, I'm going to turn it over to our first speaker, who is not Jim, WA3FET, because Jim is stuck in traffic. He'll be here in a couple minutes, but we're just going to change the order of talks here so that Alan, AG4WK, is going to be talking first. So Alan, if you could. Alan will be giving two talks. He has his own talk, and then he's going to be giving a proxy presentation by Bob KC2JJM on AI and DXtra. Alan, you'll have to bring this up here. I'll let you do it. Thank you.
No, I need to know what, I need to bring my slide deck up.
You want me to bring it up?
Yeah, it'd be good.
All right. So you're assuming that I can do that. Let's see if I can.
Nice antenna array. Load them up, yeah.
And the first one is which one? That one? And Alan? Yeah, you go ahead and you can drive at this point. Okay, thank you, Alan.
And make sure I get it up on that. That's my problem.
Okay. Bruce, we may need a hand here bringing this up. Thank you, sir. There should be something down below there that will bring it up. There we go.
Okay.
Thank you, Alan.
Great, thanks, Chip. Good morning, everyone.
Morning.
I'd like to welcome everyone to this first year's Radio Club of America Forum on AI and the future of amateur radio. My name is Alan Spindell. I'm the president of the Radio Club. I'd like to thank Dave Bart and Nathan Cohen for putting this together. And I encourage everyone to come by and see us at booth 1811 to learn more about the Radio Club and what we do. We've only been doing this since 1909, so this is the world's largest, world's oldest wireless society, and we do a lot of things that not just amateur radio, but it touches the entire spectrum, pardon the pun, of the wireless industry. Myself, I'm a fellow of the Radio Club and a senior member of the Institute of Electrical Engineers, and an expert on digital signal processing and a licensed broadcast engineer. But we're going to talk a little bit about digital signal processing and take a high-level view about some of the different ways that we train machine learning networks to do digital signal processing applications. And at the end, we're going to give a little bit of an example about how we would do this, for example, to make a CW decoder using artificial intelligence. So once again, the title of this talk is We're going to discuss the strategies for training AI models for signal processing applications using a combination of both real-world and synthesized data in data-starved applications, and how these things can be applied to amateur radio. So first of all, basically in the early days of AI, there was traditional AI, and it was mainly used for analyzing data and making predictions. And folks have been using neural networks now for decades or whatever. The real innovation that we've seen with programs like ChatGPT is in their efficiency and performance. And used to be able to ask AI questions just like we ask ChatGPT, but it took like 6 hours to get a result. And so it's really these performance optimizations that have brought it into the disruptive technology that we see today. The big innovation too is in generative AI, and that's where there's some really exciting applications for amateur radio. And that's where we actually could create absolutely new content using the neural network. We can fill in gaps in TensorFlow data, like a data stream of audio or video, and but this does require much larger training data sets, and that's what we're going to talk about today. So there's basically 3 types of neural networks out there, and Dr. Cohen won't let me use the term convolutional, so we're just called out a batch network. And for those of us here who might have been involved in some punch cards or 9-track tape, that's what we call batch processing. And so that operates on blocks of data in batches, and the example would be image processing, trying to do some predictions or analysis of a still raster image. But then also, in recent years, we've been able to make neural networks work fast enough to work recurrently, where we can operate them on sequential data and determine relationships between the input and output of a black box. And through feedback and memory techniques, and the example here would be an audio processing application like we're going to talk about for amateur radio, or also, for example, like in a radar application where we'd traditionally use traditional digital signal processing techniques. But you can actually combine both of these approaches into a hybrid approach, and the example would be a self-driving car where you've got to process still video images, but you also have to listen for things like emergency vehicles and car horns. The other example that I've seen is, for example, something that's doing some predictive medical analysis where you've got to analyze x-ray data of people's chests, but also you have to analyze audio of their heartbeats. And you can combine these 2 techniques. So what are we going to do once we built our AI? How do we know that it's working? So one of the things that we can do is look at its accuracy. We could say, oh, okay, well, we're getting false positives, say 10% of the time. The other thing, and I've already discussed this, is the latency. And so for time-sensitive applications, like trying to decode CW in real time, we've got to find some ways to improve the efficiency of our algorithms for serial data processing. The other thing is the computational complexity required by our algorithms. So, for amateur radio, we're trying to do things on a shoestring using flea power. And it's just the very experimenter's nature of amateur radio. So we may be using computation devices that have low memory, that don't have much horsepower. And maybe even we may be trying to do AI on a shoestring or for a portable or low power application using an 8-bit microcontroller, for example. So the other thing that we want to look at when we're evaluating an AI routine is the energy efficiency. We may want to operate something in a field day situation or something like that using flea power or for QRP or out in the field. And those of you who knew Mike Coulter here, that's actually an generative AI image of a mad scientist amateur in his Radio Shack. That's what I told it to generate. It came out looking kind of like Mike Coulter. So why should we even use AI for these approaches? Because it's not actually as good in terms of theoretical minimums and maximums for using traditional digital signal processing technique. But it can improve on some metric over a traditional approach that's more important for a human-centric listener, say, for example. And we can optimize a system that's difficult to express in closed form, especially if there are competing or opposing requirements that we may not be able to actually satisfy all those compromises using traditional mathematical techniques. We can also address human limitations in these very complex systems. So let's get back to how we did it there in the old day. Using traditional digital signal processing techniques, and this is a definition out of a freshman textbook in electrical engineering, but that applies mathematical techniques and digital signals to extract information, enhance signal quality, and fuel-informed decision-making based on processed data. Now, that's the way we used to do it. In the future, we want to do this using AI. So, some different techniques that we can use these neural networks to do for amateur radio applications. One is pattern recognition. The other is adaptive filtering, say for example to reduce noise or enhance signals that are just in the voice band. We can detect anomalies in signals, and by doing these things we can actually predict what's happening in the future. And I'm about to give a talk from Bob Griffin, KC2JJM, on how he's using machine learning to predict good DX spots. And then, of course, we can reduce, as I mentioned before, the complexity of some of these very complicated multi-dimensional tasks and something where then we put the human back in the loop and they can make an informed decision. But here's really what we're here to talk about today, and that's AI is highly dependent upon its training. And the example that a lot of experts in AI use is that it's often difficult to transfer the importance, the why of how we're doing something, to the ultimate goal. And so the example a lot of people give is that AI may come up with all these innovative ways to transfer a load. You know, you could use a helicopter, heavy lift, you could use a ship, you know, a spacecraft or whatever, but it'll completely miss the invention of the wheel. And that has to do with this training, and that's what we're talking about here today for digital signal processing. So, once again, those of us who are raised up in the IBM punch card era, 9-track tape era, sure you're familiar with the term garbage in, garbage out, and that still applies with today's most advanced machine learning algorithms. So if you train a model with insufficient, inaccurate, or relevant data early on, it will only hinder the development of a robust model, as the training data is what the algorithm uses to create and refine its rules. Now, earlier on, there was a little picture of an AI brain that came up, and I'm misdescribing it for you guys. So I actually asked the AI to generate a picture of what it thought its brain looked like. And I'm not going to go back in the notes, but the whole thing is what it generated was that all of the nodes in the neural network and all the connections were the same size and had the same weighting of the connections between them. And what we do when we train a machine learning algorithm is we do the exact same thing that happens in our brains. We increase the weighting of the nodes and synapses, and we increase the strength of the connections between them. How many people here have tried to remember an address or a telephone number by repeating it to yourself over and over again until you had it down? Well, that's exactly what we're doing with a machine learning algorithm. We're going to feed it training data and feed it training data and strengthen these connections inside that neural network until it responds just like our brain does, because that's how it's modeled. So here's another picture. So I went back to my AI algorithm and I asked it to generate a picture of an actual neural network showing the weighting in the nodes. So some of them are bigger or redder than others. And if you notice, some connections in between the nodes are thicker and stronger. And so that's a really good explanation, a graphic explanation of how that the training data changes the weights of the nodes and the strength of the connections between them, and that's how AI makes decisions. So what about this training data that we're going to feed the AI? Well, there's two kinds, and the first kind is really obvious. That's observed data, and that's real-world data captured and digitized, filtered and smooth. You can't always just feed it data right out of that, but you can't feed a digital signal processing algorithm just raw data either. Usually it's got to be sent through a low-pass filter or smooth, or something's got to be done to it. But what we're really talking about here, and the point of my talk today, is synthetic data to train algorithms, because a lot of times there's only really you have access to a small amount of observed data, so we've got to rely on synthetic data. And I talked about, for example, medical detection, trying to, predict someone that's going to have a heart attack. Well, we can't instrument 10,000 people and then wait for one of them to have a heart attack. It's just not practical. And it'd take years to actually catch a real heart attack. So we've got to simulate that somehow to train that machine learning network to get it some idea of what the heartbeat of a human having a heart attack sounds like, so it'll know what to do when it actually hears a real one. So with observed data, it's the best data that we have due to its accuracy, but it's often, as I just mentioned, it's limited to the mean cases and lacks the edge cases, like the guy actually having a heart attack. That's got high cost or time considerations if you got to instrument 10,000 people with cardiac sensors and follow them around with data collection on a cart. Then you have to pay the intern. There's storage considerations for all that data, and it may need some significant actual preparation by human hands, literally. Now, synthetic data has a lot of advantages over all that. We can generate large volumes of data that would be problematic to replicate in a real-world scenario due to cost or time limitations. High quality training data can be generated at low cost without having to go through that hand massaging process to get it to where it won't jam up, so to speak, the machine learning algorithm. We can tailor synthetic data to mediate specific issues in the network that it may have trouble with. And we can mediate storage considerations because this data can actually just be generated on the fly. We don't have to store it and then play it back into the machine learning algorithm. But the main important thing is that we can train to specific edge cases equally along with the median issues. It just depends on how our synthetic data generator algorithm works. So to wrap this up, here's an example that actually applies to amateur radio. Say we're trying to train a machine learning network to do CW recognition. So these are some of the examples of things that we can create in our synthesized data to try to train this machine learning algorithm. One thing is we could put some key clicks in there and get it to actually generate some bad CW so it would know what that sounded like. The other thing is that we could easily mix noise in with the signal to create QRM. For example, birdies or a slightly off frequency signal that was interfering, and we could train the thing to learn to filter that out. And of course, there's always a natural noise, and that's easy to mix into an audio signal, static, fades, things like that. And of course, there's human factors. There's always that guy out there that's sending at like 3.5 words per minute, and doesn't quite have his spacing right between words and dots and dashes and stuff. Yeah, right. My CW is terrible, I'll be the first one to admit, but I am much better sender than receiver, which is why I'm working on a nice machine learning CW decoding algorithm. But, then there's guys like me that have an uneven delivery that speed up and slow down, Anyway, so that pretty much concludes what we have here on our talk on synthesized data and machine learning. We got a really late start, so I'm going to barge into Bob Griffin's talk. Yeah, that's what I was going to say. And also, the other thing is, once again, I would encourage everyone to come visit the Radio Club booth at 1811. We'll be there to Hamvention. If you do have questions, we'll have to give the room up. And so I'll be glad to talk about machine learning and all that stuff. And we'll have all the folks here in the booth. And so y'all are welcome to drop by.
We'll bring up your presentation.
Yeah, please. I have to charge you for IT work,
So we're going to bring up another presentation from this.
Okay, so
Thank you.
That's the Hamvention presentation.
oh, which one?
Which one is it?
2.0.
This one?
Uh-huh. Great, thanks.
Thank you.
Thanks, guys. Okay, so KC2JJ is a ham up in New York. He lives on Long Island, and he's a tremendous experimenter, and he's a professional software developer. And he's always in his spare time trying to make new cool applications, especially for DX work in amateur radio. His website, dxtra.com and company, actually publish these, and they're used by a number of radio manufacturers and things to integrate, and other folks to integrate into their product. So unfortunately, Bob got caught up and he couldn't make it this time, so he asked me to give his presentation. And so what Bob has done, to give you a quick overview, is to use the DX cluster servers, the spot servers, to suck all that data in, and then use that to train a machine learning network to try to predict sunspot activity, taking in solar weather data, and predict where the good DX is, which is what we all want to know. So today, please subtitles will just let Bob's words speak for themselves. We're going to present his work on using DXtra's database for HF propagation modeling. This project combines amateur radio DX spotting data with machine learning to create predictive models for radio propagation conditions. These models can help operators determine optimal bands and times for contacts, especially for DXing and in contesting. The realization of this project has been made possible by the remarkable revolution in open source software that we've witnessed in recent years. Libraries like Pandas, Redis, and PyHamTools have democratized access to powerful data processing capabilities that would have required specialized barriers to entry for complex data analytics projects in amateur radio. Even more transformative has been the emergence of AI coding assistants. These tools have fundamentally changed how we approach software development, enabling rapid prototyping, suggesting optimizations, and helping troubleshoot complex issues. Without these AI assistants, the development timeline for this project would have been significantly longer, and certain sophisticated features might have remained beyond reach. What once would have required a team of specialized developers can now be accomplished by a motivated individual with domain expertise and the right AI tools. So first of all, he gathers this DX spotting data, and I think something's zoomed out here. Well, I'll just keep going. I hope this is the too big issue. So what he does is he's able to download comma-separated value files from the DX clusters. Those of us here whose Excel guruship may have been nipped in the bud a little bit, a CSV file, or comma-separated value file, is the lowest common denominator of data interoperability, either between computers or applications on a given computer. So what he does is pull in all these DX spots. He's pulling in about 30,000 of them a day and putting them into a flat file or a comma-separated value file. He's collected since April 2024 about 3 million DX spots to use for machine learning training. So it's still zoomed out, I think. Yeah, Bruce, maybe you can help me.
Would have to individually do this on each one.
Can you bring up my PDF? No. This just seems to be those first ones.
Yeah, the rest look all good. All right, so we were back. Let's do this.
Okay, that's fine. I'll just keep going. Okay, thanks. All right, so these are some of the key data fields that he uses to pull into his spot database. Things like call sign, country and coordinates, frequency band, timestamp, and the space weather parameters for the time that that particular spot was tracked. So A little bit about space weather, of course. What we're really trying to do here is predict propagation, so we need to tie in the latest space weather. For those of you who may be living under a rock or who only operate 2-meter bands or above, we're at the peak of solar cycle 25. We're approaching peak activity. And I wonder if we even have, okay, well, I'm just going to keep going with this. Automated spot collection data with Python to a CSV file is what he uses, and he uses several key Python libraries. First of all, he uses the telnet lib in Python, which allows you to create a raw socket connection and actually bring the data in across the internet from the various DX cluster servers. PyHamTools provides call sign lookup, band calculations, and distance and heading. And it offers comprehensive amateur radio functions for Python. It also handles Maidenhead locator calculations, DXCC lookups, and more. He's also using PyTZ, which is how he manages all these different time zones that we have that comes out of the various cluster spot data. He also uses interval tree, which is a Python set of Python libraries for dealing with intervals. And then Python itself, as you all may be aware, is a very, very, very powerful scripting language. And so it handles all parsing and CSV file implementation without having to hard code all that, just by throwing a few lines of code around. So what we use here is a TCP socket connection, or a telnet connection, as Bob likes to say. And so this is the Python code here. That's a loop in Python. And there's a little bit of snippet of code for you real true gearheads out there that he's, like Steve Gears here, he's actually using to pull this data in from the cluster. So the big thing about these socket connections, though, is we know socket connections are unreliable, as we've all tried to download things off the internet. And so the big thing here is building in robust error handling and recovery. And so it monitors, the Python telnet library monitors that connection for you in real time, has automatic reconnection after 60 seconds, logs errors, maintains a collection state. But the main thing is with the track set block in Python, we can use that throw and track capability in the Python language to catch errors without, once again, really having to get down and write a whole lot of code to do that. So here's an example of his systemd unit file. Those of you whose Unix knowledge goes a really long way back like me, we would have put this information in the old init tab and used init. And so if you can see here, this is a unit file for the clustered telnet spider. The after network.target means that systemd will not actually try to launch this service until after the network is up and running. It's a single process is only allowed to run under the user dextra and sets its working directory before it launches it. The big thing is this restart always, which is, once again, we would have put this type of process launched out of the init tab in the old days. Systemd does all this. Restart after 60 seconds. And the main thing is wanted by down here at the bottom, for those of you who may not be familiar with systemd unit files, that's saying that don't bring this up until the system is up fully in multi-user operation. And for those old timers like me out there, this is what we used to call run level 6. So once we get the data in here, we're going to use Pandas and Redis for high-performance data handling. We're going to load all of this into a Pandas data frame, which is this really, really, really powerful in-memory data indexing library that's out there. And we're going to use Pandas for data processing. That efficiently handles multi-million row data sets in memory. It provides powerful filtering, transformation, and statistical analysis. and handles time zone conversions, and you can load 3 million records in seconds with parallel processing. The reason we're doing this is to be able to feed these machine learning algorithms very quickly index sets of data. Now, Redis is an in-memory database, and those of you who have worked with database programs like SQL know that the long pole in the tent is going out to the disk and making these queries, and even if you have it highly indexed or whatever, but Redis works by having all its data and everything all in memory. So you've got ultra-fast lookup and retrieval with microsecond response times, and it uses set-based operations, and you can do multidimensional indexing to explore these complex data relationships to feed these machine learning algorithms the data that they need. In order to make this all work, we've got to leverage parallel processing to get the response times that are necessary. So what he did is got a server that had 88 cores, so it can run 88 parallel threads simultaneously. They're actually available on eBay these days, really cheap. So it's got 512 gigabytes of RAM, and it can handle years of spot data without performance degradation. And then to use the very latest Linux hackers out here will recognize the ZFS file system. So here's where we took the multi-threading ability of Python to process chunks in parallel, and each file chunk is assigned to a dedicated worker process so that we can simultaneously parse through this 3 million record database. Now, Redis allows us to index all this in multi-dimensional ways, so we can make these really complex queries into it, like I want to see all the spots that went between New Jersey and Japan on a Wednesday evening, you know, that were when sunspot numbers were a certain value, and we're going to use that for the machine language training. So what we really want to do with all this, though, is create propagation analysis. So our Redis implementation employs set-based indexing for instantaneous lookups. So we can do real-time querying in the database. We can create set intersections to create propagation charts from CQ zone to a specific country in just 3 seconds. So once again, Bruce is messing up my thing here, but that's okay. We'll just keep going because we're running out of time. The main thing here is to talk now about how the AI model actually is able to do predictive analysis on this. And the question you're all asking about is, well, where's the AI in all this? But once again, this is kind of like my talk. This is how we create the training data that allows our machine language model to actually make predictions based on the real world data that we picked up from the DX cluster servers. And we're actually going to use a hybrid approach here, which, as I discussed earlier in my talk, uses several different machine learning techniques. So the bottom line is here, to make a long story short, is you can make predictive analyses to create data visualization charts like this one. This is a chart that was created by the machine learning algorithm trained by the DX cluster data, showing you when would be the best time and the best zone to go between New Jersey and CQ Zone 5. So future work, this is what Bob wants to do to expand his product and commercialize it, make it available for radio amateurs. He wants to expand data collection to include all of the data clusters, DX clusters worldwide. He wants to add receiver data from the reverse beacon network to get additional information on propagation in real time. He's developing a web-based prediction tool for operators, and we've seen some demos of that. He also integrating the FCC call sign database for more accurate distance calculations, implementing advanced machine learning techniques such as XGBoost for improved prediction accuracy, deploying a vector database to help retrieval augmented generation in the LLM query model, creating a conversational interface for natural language propagation queries. If anybody has questions about this, you can reach out to Bob, rtg@dextra.com. Come by and see us in booth 1811. I'll get you his contact information. One more thing, Bob's got a new product coming in fourth quarter 2025. I've seen this actually in action at the Tentec plant. It's a real-time HF speech-to-text black box. It really does it. Steve's seen it. Works great. Those noisy HF, does noise reduction as well. It can even identify the speaker on the other end by the sound of their voice, and it'll be integrated in all the new Tentec HF transceivers. Come and see us. What's the booth? 1807?
1807.
All right, guys. Thanks for your time, everyone, and thanks again to Dr. Cohen and Dave Bart here. Good night. It's great forum.
We'll have some time for additional questions at the end of the session here. Our next speaker is Jim, WA3FET, and Dave Bart, KC9YPD, is going to introduce him. We're going to load Jim's program on the system first.
You don't have that here.
We got a late start, so while they're loading, I'm going to do the introduction here. My name is Dave Bart. I'm the former president of the Radio Club of America, and I'm also editor of the RCA Proceedings. For 115 years, RCA has brought you the newest in radio innovation and camaraderie, all rolled into one. Our next speaker is Dr. Jim Breakall. Jim is an old friend to RCA. He has served on its board. He was co-director of the Technical Symposium and has received several awards from RCA. He's also known for his work at Arecibo and HARP. He's a professor emeritus from Penn State University. And most recently, he had the privilege of receiving the Technical Achievement Award here at Dayton last year. And last week, or within the last couple weeks, he was named to the CQ Hall of Fame. I'd also like to point out that Angel Vasquez is out in the audience. Angel leads project engineering at Arecibo, and he was also named to the CQ Hall of Fame, and I really want to congratulate both of them. It's quite an achievement to be recognized by your peers. So Jim, WA3FET, is going to talk about the introduction to AI, OWA antenna optimization, and take it away, Jim. Thank you for coming.
Thank you, Dave, and thanks to Chip and the Radio Club of America. And I think Chip said I got an hour, is that right?
An hour equals an hour.
Yeah, my kind of talk, yeah. Okay, Charles. Yeah, 5 minutes, okay. Anyway, I want to give a tutorial. I was going to be here earlier, but we got caught in the traffic jam out there. So Alan graciously took over, and you sure you don't want to come up and give this talk too? You're on a roll.
Don't have that much fear.
Okay. Anyway, let's go on here. So before we start talking about AI and how great it is and everything, I thought a comparison should be made to something we all have inside our heads, okay, the human brain. And it's pretty interesting when you consider the speed of memory in the brain and power and all that. So if you look here, over to the left there, that's the world's fastest supercomputer called El Capitan, and it's at Lawrence Livermore National Lab where I used to work. And it has about 1 exaflop. That's a 1 with 18 zeros after it, okay? And the human brain also has about 1 exaflops. It's pretty amazing. Now, the power requirement is really interesting. That computer takes about 20 to 30 megawatts of power. The human brain's about 10 to 20 watts, okay? So quite a better efficiency. The dimensions, as you know, the brain's like 3 pounds or so, that computer and the building and everything. The cost, you know, 600 million plus. The brain, well, there's no cost on that. I mean, you know, so that's way out there. The cabling is interesting. The El Capitan has 90 miles of cabling, but the human brain has 528,000 miles when you consider all the neurons and axons and dendrites. The memory, the computer, we can put more memory in, okay, 700 petabytes. Petabyte is one with 15 zeros after it. But the human brain has about 2.5 petabytes. And the storage, the computer has about 58 billion transistors. The human brain has 125 trillion synapses, and each one can store 4.7 bits. So the brain is still pretty much a great thing, okay? We'll talk where the brain is still better than AI. Okay, so this is supposed to be a tutorial. So what is AI? Okay, AI is where you try to simulate what humans do, but you do it on a computer. Many great things are there waiting for us with AI, such as speech recognition, translation of languages, things like that. The human can still do better, though. Okay, in translating and getting things out with our petaflop memories and so forth. So anyway, trying to simulate human things is what AI is on a computer. There's different types of AI, reactive machine, like the Deep Blue chess game, okay? So you react to anything that's happening in the present. Limited memory, like a self-driving car, okay? So you use past data of how cars drove and everything, and you put that in. And then these are things that can actually exist right now, as we know. But then in the future, things like human emotions or intentions, like that arm wrestling, you know, how's the guy going to push harder and things like that. And then to get way out there is like consciousness and getting aware that things are happening around you and things like that. So AI has a couple of other things involved in it, as Alan talked about, machine learning, and there's something called deep learning. Machine learning is a subset of AI, and deep learning is a subset of machine learning. And so machine learning is where you allow the computers to learn from all the data that you try to put in, like that, what he was trying to do with the propagation, okay? Not too much programming, just like, you know, it learns from data, that kind of stuff. Deep learning is where you're really trying to simulate what's going on in the brain with what's called neural networks and things like that. And so there's machine learning and deep learning. So machine learning. There's different types of machine learning. There's what's called supervised learning. That's where things are labeled, okay? So like all those fruits have some kind of markers or labels on, and then the computer takes that and it does some kind of image processing to pick up what the labels are, and then it sorts it out so it puts it in the right boxes, okay, to be shipped to wherever. Unsupervised learning, that's called clustering, and that's where the computer, it has to do a little bit more than the labeling. It has to somehow look at the objects and see if there's a pattern with those objects. And then it goes and sorts them and basically does the same thing as what the label, but it's a little bit harder to do, okay? But those are the types of things. And you can always have reinforcement training. Deep learning, this is where you're trying to simulate what's going on in the brain, which is called artificial neural networks, deep neural networks, and the complex patterns and things that flow with the data. And so neural networks have neurons and layers and connections and weights, and you know, it's a whole science into itself, trying to simulate what's going on in the brain. Some of the things that this is great for is image recognition, okay, which, you know, there's some of that exists already. When you log into the computer, your face is on there, and you get logged logged in. If Angel's face is there, it doesn't get logged in, you know. But anyway, translation and language things, the humans still can do a lot better and faster in translating than what the best computers can do now. But in the future, you know, you'll have something on you, and you'll speak in one language, and it will be speaking to somebody else in a different language in real time. Okay, we're not quite there yet. So some of the applications of AI in the healthcare, there's like diagnosis. That's going to be a big thing because, you know, how can one doctor or even a group of specialists know everything about every disease and every treatment? And so AI can go through all that data, and you'll have the best doctor in the world then, and new kind of drugs, you know, coming up and things like that. Finance, fraud detection, and trading of stock, things like that. Hopefully we'll get better. Self-driving cars we talked about, and you know how to manipulate traffic if you get self-driving cars. Entertainment, gaming, that's a big thing. There's a lot of gamers out there that it's going to be great with AI. Education, I was in the education business as a professor, and I used to have this method. It was pretty good. It might even beat the AI. I would put this dartboard on the wall, okay, and in the center, throw the dart, that's an A, and then the next ring was a B, and so it made grading very easy, but hopefully this will be better, okay? And of course, robotics we know about. And it looks like I'm cut off a little bit at the bottom there, but amateur radio, all kind of things in amateur radio. So I'm going to talk a little bit about that next. Yeah, boy, this computer's really messed up. Anyway, it should say, what's the optimized wideband antenna? I did an antenna design some years ago that used something like AI, but it wasn't quite AI yet, okay? And I just thought I'd explain a little bit about that and some things that are related to AI, and then how AI will do antenna design in the future. Anyway, this OWA Yagi came from actually an OWA antenna that was on a cell phone, okay, Qualcomm and Sony, and then I said, can we apply it to Yagis? And it was putting extra wires of some length and spacing very close to the main radiator. And so what's optimization? Optimization is where, with this simple case here, 2-element Yagi, you would change the spacing between the Yagi, and you would change the length of, say, the reflector, okay, or director. And you might get something that you know, you're adjusting for front to back ratio, and it has some curve that looks something like that. And so that red peak there would be the best front to back, but you're looking for the minimum radiation in the back, so you're looking for those minimums. But there's one that's bigger than the other. That's called a global. Okay, so you come up with methods to do global. So here's a really fancy function. It has a lot of peaks in it. And one of the things that's, a lot of these new optimizations techniques that were sort of related to AI is where you try to use nature involved in doing the optimization. So this one's called ant colony optimization, and it's basically you put a bunch of ants there and you program them up, and then the ants leave trails of chemical trails going to the food, and so they don't go back on those same trails, and you can let the ants go. And this is a simulation that just shows how the ants are going to move, and you'll see them moving around, and they're going all over the place, and they keep trying to find the food, okay, and finally they got it, okay. There's another one that's called firefly optimization, and that's where you have fireflies, and they have indicators with the lights. They light up or don't light up, and that's how some fireflies know not to go to the same position. And so here's all the fireflies get started, and then they keep going. And there they go. And there's that one guy that's sort of, I don't know why he stopped there. There's one guy off to the right that he finally gets there. And then you could come up with algorithms. You could find all the peaks. Suppose you have a whole bunch of peaks, and so you let this one go. And so it's finding all the peaks, and all those other circles are the dips in that function, okay? And so that's pretty neat. And there's all kind of things that involve nature and things like that. So anyway, I applied this to a Yagi, and we tried to get the best bandwidth, the best VSWR, front-to-back ratio, so forth. And when you run this through an optimization, like one of these things I just showed, you can get a almost perfect SWR over the 20-meter band. And then you can also get the front-to-back ratio, which is the blue scale on the right there, more than 24 dB across the band, and the gain's about 9 dB across the whole band. So AI, where's AI going to come in antennas? It turns out there are some commercial codes right now that actually have this machine learning in them. One of them is called FICO, and it's from a company called Altair HyperStudy. And what it does is it takes something like this Yagi antenna, and it trains it with a very specialized algorithm called FAST, that if you're familiar with this mathematically, it uses something called fancy regression analysis to do fits of all the different parameters that you're varying, and then it stores a big database of gains and front-to-backs and SWRs for every possible situation. And so you do that once, and you store all that data, and that's the learning process, the machine learning. And then when you do the optimization, it just has to go on that database, and it has all the data there, and it's like super fast. Those ants or fireflies can get to the optimization like that. Where the kind of optimization that is the classical, it takes like, maybe hours to optimize something. And so this is going to revolutionize all kind of things with circuit filter design, things like that. But this is an example right now that you can use for antennas. And I can't go in to show you a sample and all that. It would take too much time, but it's out there, okay? And so you're going to see this eventually. All the stuff that's commercially eventually gets into ham radio, okay? And that's what we want. So just a little bit of PR here on the OWA Yagi. It's used all over the world and everything, and I didn't have machine learning. I had to use the classical techniques of optimization, but it came up with some pretty amazing antennas. And I just put in Google OWA Yagi, and I said, put out all the images that it finds on this. And this is just the first page, okay? It's page after page of people using this antenna. Now, here's the coup d'etat, and this is especially for Chip back there. Okay, the next slide. Turns out I don't really know much about AI, to be honest. I was a professor at Penn State for 33 years in antennas, but of course I've heard of it and so forth. But what I did is what the students are doing these days, okay? And now I'm saying it, so don't crucify me, but if a student does this, not good, okay? And they use something called ChatGPT and other things. But this is Gemini. Some of you may know about Gemini on Google. And all I did in Gemini is I made a screenshot of exactly what I did before this presentation was made. And I said, make a PowerPoint presentation for a tutorial on artificial intelligence. And it came out with every slide here, what pictures to put, all the bullets and everything. So Gemini really gave this talk, I should say. So, thank you. We'll take questions after, or are we taking them now?
One question.
One question? Anybody have? Angel? Did you use AI at the observatory for astronomy?
When I was there, no.
No, okay. But some people there knew about it, certainly, yeah. And I'm sure Joe Taylor knows about it. Yeah. Oh, yeah, question. Oh, it's right there. If you go to Google and you type Gemini, it will come right up, and it will ask you. Now you have to be logged in as a Google account, okay, like a Gmail account or whatever. I think you have to be logged in, And there's another app called ChatGPT that you can download that, and that's free as well. There are paid versions that do better, I guess, and that's what the students, I guess, are getting. And they probably didn't pay for them either. But anyway, yeah, Gemini is right there under Google. And you can ask it anything. I asked it, who is WA3FET? And, well, it came up the first time I asked it, and it gave a big description of me, okay? Then I asked it again, who's WA3FET? And it came out WHCI is. It came out with Michael Calder for some reason. It got mixed up with Michael and me. Then we asked Angel, and oh, man, we got a lot of stuff on Angel. So anyway, Gemini is there under Google.
Yeah, and I might add that my AI generated images of the AI brain were generated by the AI Claude.
Okay. Charles.
Yeah, I've done a lot of research on plastics and chemistry and charges and whatever, and I'm kind of the go-to guy in vinyl.
Oh, yeah.
And a lot of the information that comes out of AI and GPT, completely false. And what's interesting is where the education of these AI systems are combining a lot of information that's out there in the World Wide Web. I call them armchair YouTubers. They think that they're experts, and they create their own monologues, which AI and GPT
Picks up.
And I've had a couple of discussions with Google regarding information that is completely contrary to things like the triboelectric table of charges, where you go to a library at a university and you pick up a book on chemistry and whatever, and they're confounded.
Right.
So there's an issue where all of this AI stuff does not, at least in my study field, has a lot of lack information and incorrect information.
Yeah, it came out. Yeah.
All right, thanks, guys.
It came out pretty good on this talk, I think, and also when we said who is Angel and who's me and stuff like that came out pretty good. Anyway, thank you so much.
Thank you so much
Thank
for the
Dave.
presentation.
Okay.
I'm going to introduce John while he makes sure his presentation's on the computer. You know, the conversation about AI reminds me of the early days of Wikipedia, when there was a search for good, validated information, but over time, everything fell into place and it's self-correcting. So it's a brand new field, but you're right. If you get an AI output, you need to know the subject and you need to double check it.
I need some help finding.
Okay, we need a little help on the computer up here.
I'm in the, wherever the form presentation was. We copied it.
Have you? Can you see his presentations?
Otherwise,
Is it this one? No.
otherwise I've got it. Yeah.
You have a stick?
I got a Zoom in 5, so, you know.
But we copied it to your forum correctly.
We're known enough on AI.
I've got it.
Sue's got to do your time in
Let's
the
just
booth.
use the stick and get going.
Thank you. Thank you.
You guys might want to ask the AI how to put your presentation.
Should say AI. I can't
Yeah, there we go. Okay. So we got Ackerman. And then I'm going to need also to leave this in. I'm going to get the floor. We'll start from here.
Okay.
Okay.
All right, we're almost ready. Okay. So thank you very much for giving the next presentation. John Ackerman, N8UR, is an expert in precise time and frequency measurements. He has been a longtime advocate of open source hardware, and he is the prior president of TAPR. So today he's going to talk about AI, making AI, and building AI. So thank you very much. Take it away.
Thank you. And how this is going to work. I hope I can maybe answer the question or comment that was made just a minute ago about getting bad answers from AI when you particularly want to ask about specialized information, because there are ways that you can address that, and that's what I hope my presentation will talk about. Come on. Okay. There we go. So I've been a time nut, one of the people who are really interested in precise time and frequency measurements for many, many, many years. And we have a lot of material available to answer questions. There's a mailing list called Time Nuts. It's got about 1,800 members, and it's been going for more than 20 years. There's 110,000 emails in our archive from that mailing list, all public information. There also are thousands of published papers. National Institute of Standards and Technology Time and Frequency Division has over 3,000 documents in their downloadable archive. There are other annual time and frequency forums where there are papers published and presented. So there's thousands of those available. Also, several of us have websites that have the results of our experiments and measurements. And so the question was, could we combine all this information together to make an expert system that would let you ask questions about time nutty things and get answers that are not hallucinations? And I started on that project. So first, just a little bit of background. What's an AI and what's an expert system? Well, most AIs, at least the ones that we're talking about most today, are based on a large language model. And you can think of that as being the world's most powerful autocorrect tool. What an LLM is really nothing more than a set of data that's been trained to know that if you type the word hello, the next word that's likely to follow, if you're a programmer, is world. It might be Bob or Jim or Sally if you're somebody else, but the LLMs predict what token or word is going to come next based on all the tokens that have come before. And from that, it keeps building the answer out as you go. And that's great as long as the predictions hold. When the predictions don't hold, you get these ridiculous results that are called hallucinations because the prediction model fails. And AIs that use LLMs are generally trained on a general set of data. It's pretty much everything on the web, but some of that's garbage, some of it's good, and the AI can't really tell which is good and which is bad, so it goes down these wrong tracks. So that doesn't make it very useful for answering specialized questions in a technical area. So what we want to do is come up with a way to add the domain knowledge that will allow it to generate accurate answers. Now, the first presentations talked a lot about training. And yes, if you have a huge amount of data, you can train an LLM to give you better answers based on what that data would indicate. But the problem is that takes a huge, huge amount of data to be able to make that work well. There's a different approach to doing that. And that is you use a knowledge base that contains these email messages, PDF documents, and all the other information. And you create what's called a retrieval augmented generation. And that is where you ask the general purpose LLM a question, but when you ask the question, you say, hey, here is some context information that might help you answer that question, and you feed it the documents from your knowledge base that have relevant information. So the query might be, what's a crystal oscillator? So we go out now and search our database and get 50 or 100 documents that talk about crystal oscillators. And using various semantics and complicated algorithms, we find the most relevant 10. That's a random number. It could be other numbers. We take those 10 most relevant documents, and then we go out to the LLM, the ChatGPT or whatever, and say, hey, what is a crystal oscillator? Here are 10 documents with information that might help you with your answer. And the LLM then uses that and can generate an answer that has some valid information guiding it. And that is how you can get expert results out of a system without having to have a totally custom language model that might cost millions or billions to create. This is a picture of that process. It's a little bit of a word chart, but it starts out at the lower left. You start out with your documents. So I'll just focus on our PDF files. I downloaded about 3,000 PDFs from NIST and other organizations, Hewlett-Packard application notes, equipment manuals. We have to make those usable, so I scanned those, used an AI that Google makes available to convert them into text. So all these PDF files got turned into text documents, and the text documents then are chunked up into pieces of, it turns out to be about 400 words, and each of those chunks then is fed into a database after looking at its semantic content, which is something I don't fully understand, to be honest, but you take this 400 words, feed it into a model that compares what those words are, how they relate to one another, and comes up with a set of vectors. In the case of what we're using, 1,000 dimensions that indicate the semantics of that chunk of text. That vector goes into the database. When I ask a question, my question is converted into a similar vector. Now the database looks, what are the answers in the database that are closest to, in semantics, to the question that is asked, and it returns those results. Then those results are combined with the query. It goes to the large language model. The large language model synthesizes from the context and its own knowledge and gives me an answer. And it's really kind of amazing. I have a very short demonstration that I'll show in a second that shows the way the query process works. Now, how do you build this thing? And that's the other AI part of this. I have done some coding. I've hacked around, and I'm really good at syntax errors in C. I'm almost as good at syntax errors in Python. But Python's what seems to be the language that people use for this type of programming. But I could never generate the code to do this because 4 months ago, I didn't know what RAG was other than something that was in the laundry bin. So I literally went to an AI to tell me how to write the code. And after I was about 3/4 of the way through this process, I learned there's a name for this now. It's called vibe coding. That's the newest computing industry buzzword. And it's essentially where you ask an AI to write code for you. And I went in and said, I want to write an expert system. Help. And I got some answers back about kind of the architecture, and then said, okay, well, write me some code. And it wrote the Python, and it sort of worked, but it wasn't great. And I said, well, fix it. And it fixed it, and we iterated. And at this point, I've got about 10,000 lines of Python, and about there's 20 or 25 separate code modules. I have looked at it, I've edited within it, but essentially all the code in the application was generated by AI, and it works. So an aspect of AI is, apart from using it to get useful output like this, is using it for coding. And again, I might have been able to write something given months and months and months, but this process literally took me 2 months. Yeah, I'm retired, so I could work at it harder than I ever did at my real job. But I was able to get this thing up and running in a couple of months, and it seems to be relatively reliable. It looks pretty. So it really worked well to do it that way. And one thing that I noticed is the AI knew about lots of libraries and frameworks and things that I had never heard of. So just generating a web page with the interactive chat kind of format, there's a thing called Streamlit that does that. And I had never heard of it. I would never have known about it. I didn't know what vector database to use. So the AI, in addition to just cranking out code, really helped with the architecture and the design. So it's something to consider. I think these days, AI coding is not going to replace code, but it can sure make it a lot easier to get things up and running. And if you're a good programmer, you can have it do the starting point, and then you can make it much better yourself. So the end result of what we put together was programs that I wrote about the AI wrote, to take each of the three types of collections, the 110,000 emails, at this point, about 3,400 PDF files and 6 websites, and convert those into chunks of ASCII text, feed them into the vector database. We use a thing called Chroma DB. There's also a full text database so that you can search for actual keywords as opposed to just the context. We wrote the RAG server that provides that front-end interface to the database, and then the chat server that you use to enter your query. It sends it off to the RAG server to get the context documents, then sends everything else off to the LLM to get the result, and a bunch of other text and testing programs and utilities, all in Python. Everything's open source, and I said it's around 10,000 lines of code right now. I'm sure that a good programmer going through it could reduce the lines very significantly. There's a lot of unnecessary stuff in there, but a lot of it was there for testing. So we're going to try to do a demo, but because of the technical issues, I'm going to go to my last 2 slides first and then come back to the demo. So I just want to mention that there's lots and lots of AI involved in this. I used AI for code generation. I mainly used the Claude Sonnet model, which is really, really good at writing code. Some of the LLMs are really awful. Google's Gemini 2.0 Flash, which is free and cheap and very, very good for a lot of things, cannot write a simple bash script to sort a directory. It's just utterly awful at coding. So it's really important to find the right language model to use for the task. For PDF to text conversion, Google's Cloud Vision AI, it cost me about $100 using their API key to do over 3,000 documents, OCR scanned, so not overly expensive. The database embedding was done with an open source embedding model called BGEM3. Then the model that ranks to find the most relevant documents was another open source model called BGE Re-Ranker. And then finally, the thing that generates the answer for you goes out via Google's API using the Gemini 2.0 Flash. So there are actually 5 different AI systems involved in creating and running this system. And some full disclosure, yeah, it wrote the code, but I don't think it would have worked if I hadn't been able to go in and read the code, see what was going on, find out why it wasn't working, and helping the AI learn how to fix the problems. So you need to have some technical knowledge, but you don't need to be a genius programmer. Yes, yeah, sometimes more than you want. You have to pick the right LLM. The Claude Sonnet 3.7 is really good. Google Gemini 2.0 is really bad. There are some length limits, context limits that can be a problem, and I'm going to move real fast. This last thing is, if you want to play with AI, you can go to ChatGPT, and their account is like $20 a month. There's a thing called T3.chat, and there's a free tier for low-level use, but for $8 a month, you can get unlimited access, and it gives you about a dozen different LLMs that you can try, and it's a really fast, nice user interface. So I'd highly recommend T3.chat. I won't go into these decisions, but there are some issues about what you do locally, which requires using a graphics video card versus what you might host remotely. And I will, if I can get to the file. This demo takes 1 minute 15 seconds, so hopefully we'll have time for it. But I've just got to be able to.
Go
How do I just get the?
here
Yeah, and that's the problem.
and
Oh, there we go. Okay, so we should just run.
this.
Yeah.
And
There we go. So
hang
it's just-
on, except
it's
need to project this.
oh.
That didn't do it. Just minimized it. What program is this?
It's just it's an MP4 file or an M4E file, like a media player.
Let's see. Oh. Can I get there?
There are people who know more about DSP than I do in here, but you can certainly, I can easily see how an AI system could be used to, be basically a noise blank or noise reduction. Well, so unfortunately, our demo's not going to demo. Yeah, it's was simply showing the TimeBot GPT window. I entered a query. One was a crystal oscillator first used for timekeeping, and it went out, got the context documents, printed the answer, a nice about 5-paragraph answer with all the reference documents listed with footnotes and then the references. So just showing how the system worked, but unfortunately our video didn't want to video it, so my apologies for that.
John, if we can't bring it up now, we may have a few minutes at the end and we can try.
Okay, sure.
You want to, let's hear it for John. You guys want to switch the programs around? Thank you very much. Okay, we've heard from a non-programmer programmer. Prior to that, we had a non-professor AI expert. Our next up, we have a non-presenter presenter. Chip Cohen, who you all know. Chip is the inventor of the fractal antenna, an astrophysicist. He is a longtime participant at Radio Club of America, a fellow, a multiple award winner, and a board member. He is also a recipient of the Technical Achievement Award here at Dayton. He is going to present Randy K5RMN's presentation for him. So I said, non-presenter presenter. And that presentation is AI noise reduction with RM noise. So it's a proxy presentation as soon as we find it. It's using AI to overcome and reduce the impact of noise. So but I'm done.
So let me give you a little bit of intro on Randy's talk here, and then we'll switch over to the.
Chip, why don't you take the mic?
Should RM noise? No, what is that? I have no idea where you are. All right, so K5RMN is Randy. Randy has, by the way, is a very humble guy and a very brilliant one. And along with his father, K5CE, who is now a silent key, he's been working on a secret project, which is not so secret anymore. And that is a amateur radio-oriented noise removal, not noise filtering, noise removal system using AI. That's it. Hey. Here we are. Okay, so I do want to say that I'm delighted to give Randy's presentation here because he couldn't join us today. I do hope that you will leave this room under the impression that there's a very neat system that you can download and use yourself to try to remove noise. So let me move ahead. What I am going to do in this talk that's a little different is Randy did come up with some great stuff talking about how AI works. I'm not going to go into that section so that we can take advantage of the remaining time that's left to get to the demo. But I'm QRO only. So this will give you an idea. Is that better? We good now? A little more? You want me to turn up the compressor? All right, I'll go off axis here. What Randy has come up with is a system that works in very close to real time. The latency is on the order of 100 to 150 milliseconds. Noise reduction that uses the cloud to do the AI part and then feeds it back into your computer. So here's the kind of noise that Randy is able to filter out. Of course, most of these are the ones we're really worried about, including things like power line noise, LED noise, over-the-horizon radar, et cetera. The intelligibility is quite remarkable. He's able to pick up to 20 dB of signal versus noise on CW, for example. And again, the latency that he's concerned with is on the 150 milliseconds. I believe he's trying to speed that up, but again, when you go to the cloud, the latency is kind of hardwired. Whoa! Let's go back to that one. I can't control the volume, but I can guarantee the noise is going to disappear. All right. See, there's no noise.
It's perfect.
All right, let me try this again. Yeah, I'm trying to go backwards on the slides. And let's see what it does. So he's got a toggle about how much noise you're removing from the system. Pretty amazing. Let me try to run one of the other demos. You know, it almost sounds fake, but it's not. It's very real. Are there any RM noise users in the audience? You think this is an accurate representation about what it can do? Yeah, that's what I thought too. Let me try the sideband one, see if that comes up.
So you're moving the slider, right?
I'm trying to, yes.
I mean, it's not part of the movie, you're actually doing that.
Yes, I'm trying to. It's not letting me do it. All right. Okay, so in any case, there's a very nice description that Randy gave about how he does it. What he takes is a signal from the radio and runs it to the computer and then the internet. Then it goes from the internet to his RM noise server. He applies these AI noise filters, and then, of course, it feeds the system back. So here's how the setup is made. You basically have to connect through a USB or line in from your receiver to the computer. And then, of course, from the computer, it's running all the systems, and it comes back through your headphones. Now, I'm not sure why that has to be headphones. Presumably, you can do it with stereo speakers. Here's the bottom line. This is a free noise reduction system. And you need to go to Randy's website, which is rnetplace.com, and download the Windows software program. I'm not sure he has this available for Apple, but in any case, it does work quite well for Windows. You run the setup program. You register your call sign. You've all been through these kind of processes. Would you like me to go back to get the picture? I'd be happy to. There you go. And again, here's a process picture. If you'd like to do that. Everyone okay? And there's apparently, you have to use the Microsoft Sound Mapper in order to really make this happen. So just a minute, I'll be happy to answer a question. Yes, if you could speak up so everyone can hear your question, please. I can't hear you, I'm sorry. Right. The point is that you can control the amount of noise filtering that's done. It has your slider to do that and choose your signal type and so on. Yes. Yes. Make sure you can get, if anyone wants to get that picture, here we go again. You know, I'm pretty much a Luddite when it comes to implementing some of these canned programs. I actually found Randy's system to be quite easy to navigate. It looks like it's harder than it really is when you're looking at these slides. I'm going to skip how the AI works section because you've already heard this in several different versions over the last hour and a half. But the bottom line is that AI learns what it means to have a signal, in other words, a CW signal or a sideband signal, and then it learns what noise is. So by that learning mechanism, it's able to remove the noise from the signal. And there we are, that's about it. Please take a picture of this one again if you want to contact Randy or you want to get at that website. And I've made a career of mapping noise in the sky. I'm a radio astronomer. I'm intimately familiar with noise. When someone says that they can claim they remove noise, I'm exceedingly skeptical. Now, Randy's not doing any magic here, and he's not removing all the noise under all circumstances. But for most practical applications of very limited bandwidth in known deterministic signals like CW and sideband and so on, this thing does a great job. Can you use it in a contest? Has anyone used it in real time in a contest? Okay, one of the reasons it's not commonly used in contests is because of the 150 millisecond latency. Not easy to get beyond that, but at some point, maybe we can coerce Randy into either doing a free version you can install on your computer or doing something that is a little more accessible and a little less latency. Thanks very much. Check out RM Noise, decide for yourself. Thank you. Okay, our last talk is a hybrid, and Bruce, can you help the speaker bring this up? I'd appreciate it. So it's on the same. So the last talk is a little bit different. Let me get to the microphone.
Yeah.
It's whatever you called it. Okay. So the last talk is a little bit of a different. It's not a programming talk. It's a talk of the application of existing AI that you and I have access to. So what K1BG, this is Bruce, K1VR, it's Fred. Fred, stand up for a second so everyone sees you. Thank you. And myself did is we said, let's try to see what kind of stuff comes up when you ask about the future of ham radio through AI. Now, I'm a big historian of technology. I'm well aware, for example, of the pulps that were published in the 1930s about the views of the future with the supersonic vacuum tube driven trains and so on, okay? So we all know that predicting the future is kind of taken with a huge caveat. So we're going to give you some of those results today in the context of a huge caveat. Let me tell you the general approach that we took. First of all, the engine that I used was ChatGPT 03, which is a little more advanced than the one that you normally have access to for free. And the general process is asked it some initial questions. Then we asked it to add additional databases. Often these databases come from lateral fields. For example, if you want to find out what might happen to ham radio in the future, you need to go and take a look at A, what's happening in telecom now, and B, what people are forecasting for telecom going ahead. You also want to take a look in the computer field, the optimization field, and so on. So what starts out as basically a super search engine gets to be much more advanced and to bring in stuff from the outside and then to extrapolate based on combining all those data fields. So I concentrated in my part in coming up with the technology end, and it came up with some real wacky results. I'm just going to describe very briefly three of them. One of these that came up with an artificial ionosphere based on satellites. Another, it came up with the idea of what it called chordal bandless HF, which means that based on real-time optimization of the link, it was saying, forget about operating on one band versus another band. I'm going to put this wherever I want over the course of 2 or 3 or 4 different bands in real time. And finally, it came up with a very interesting immersion scenario that is sonically based that also, it's almost like a Tony Stark situation. So I'm not going to go into all three of those because we are running out of time, but let me talk about the artificial sat ionosphere. First of all, it is illegal to directly transmit signals at satellites that may saturate their receivers or transponders and so on. It so happens that most satellites don't operate anywhere near amateur radio frequencies, and you have to accept the fact that there's some very minor reflection that happens from them. That amount of reflection is determined by the so-called radar cross-section, and that changes very dramatically at frequency, but it's basically a function of the wavelength that you're using versus the size of the satellite in wavelengths. What it found was that between Starlink and the programs that are being planned and going to be put up in the sky by China, there's going to be tens of thousands of these satellites in low Earth orbit. And although they have fairly low radar cross sections, you can get reflections at 2 meters on up. Now, those of you who have a little bit of a memory might understand that the ISS actually was able to impart a transcontinental reflection on 2 meters back, I think, in 2013, 2014. So we know this can happen. The reason it's important now, according to AI, is there are so many satellites up there that even though the reflections are low, the probability of entertaining and seeing them is fairly high. And it came up with a new term for it. It called it sporadic S for satellite. So it claims that sporadic S propagation is going to be a totally new regime for amateur radio operators, passive reflection from satellites moving ahead in the future. Just talking about the last one here, it did something kind of neat. What it said was, why don't we take a monaural signal? And I know what a formant is. If I have several people talking to me on the same frequency, I understand the formants are different. That means I can separate out the different speakers, and by using delays of less than 1/10 of a millisecond, I can actually, in a stereo headphone, spread out the mono signal so the position of the speakers that you're hearing, that is the localization, gets spread out. Also can do this for CW. I've actually done some of these experiments with analog, and it works. It's really quite amazing. So it really is putting us kind of in a Tony Stark kind of environment. Well, that's come of this on what happened with some of the technology end. I'm going to ask Bruce K1BG to go into some more general questions about when we asked it about the actual future of ham radio. Very interesting results. Bruce?
Thank you, Chip. So I'm Bruce K1BG. When we started this process, I knew absolutely nothing about artificial intelligence. I have a hard time with natural intelligence. And so we went to Chat GPT, asked it some questions. It was iterative. We asked questions, we asked follow-up questions, and it did a little bit about prediction on the future of amateur radio. I'm just the messenger. I don't necessarily agree with what came back, but I found it really interesting. So basically, it came back and said the following: amateur radio in 2045 would be a world where the shack lives in the cloud. In other words, pretty much remote operation is kind of the standard, but you don't necessarily stick to one remote station that you use, okay? That the cloud will be full of these remote stations. They looked at current trends, things like remote operation and contesting has now kind of become accepted, but that it'll go mainstream, okay? That there'll be, in the 2030s, there'll be grids of hundreds or even thousands of public shacks that are out there that you can use, okay? And that urban and HOA restricted homes will default to remote HF operation, okay? Station architecture in 2045. ChatGPT came up with this concept of what they call front-end pods. And we asked it, what do you mean by a pod? And a pod is nothing more than a box with all of the, with everything inside it, the station inside it, the software inside it, the algorithms inside it, everything is inside it. You attach power to the pod, you attach an antenna to the pod, you attach a dish to the pod that will go to some kind of low Earth orbiting satellite for your network connection, okay? And this pod can be deployed anywhere, okay? It can be for your de-expedition, it can be the remote shack. They talked about different types of pods, an HF pod, a VHF UHF pod, a microwave millimeter wave pod, okay? But when I read this, I think in terms of a product where instead of you're integrating radios and antennas and computers and software and all of these things, the pod just does it all, and it's all there for you, okay? So they talk about inside these pods, your waveforms, your ALE, automatic link establishment, okay, which is a software algorithm where frequencies and those kinds of things are pre-established based on the type of propagation that exists and the kind of connection you want to have. Logging, reporting, all of these are all inside the pod, as is what they call trusted path regulation. In other words, if you're an operator and you access this pod, before you can use it, you enter your call sign, okay? And the trusted path algorithm will determine, is this person licensed to use this frequency? Is this person licensed to use this power? All of those kinds of things are all part of this pod application. Okay, it talked about operating culture in 20 years. Talked about DXing and how these pods will just be deployed in different places around the world, okay? Contesting, they talked about new operator categories, single operator at station versus single operator remote, okay, for potential categories. Awards would be automatically generated, things would happen kind of in real time, okay? And they talked about youth. They referenced the current remote ham radio program. Everyone familiar with remote ham radio? Yes? Okay, it's a system of remotely, W2RE runs the remote ham radio program. It's remote stations that you can basically become a member of remote ham radio, but for youth, he offers the access to the network for youth free of charge. And ChatGPT talked about youth-style pods, okay, which would be available to youth, okay? And they said this would be the normal licensing lab in high schools. In other words, you have a youth program in high school, okay, and remote ham radio is part of that, and that is what's used hand in hand for getting young people interested in amateur radio. Emergency communications reimagined. What's that? Okay. They talk about how civil defense teams would lease time on pods that could be hundreds of miles away, okay? You have voice gateways and mesh networks in containers, and local volunteers only need a smartphone with a 70 centimeter dongle to access the local pod that's part of an ad hoc network. I don't know if I agree with any of this, but I found the results particularly interesting. Bottom line, by 2045, remote will no longer be an asterisk. It will be the default path into the hobby for anyone who lacks land, low noise, or high budgets. Think about that for a minute. The shack moves to the cloud, the antenna farm to low noise ground, in other words, places where there isn't man-made noise, and the operator, whether a 70-year-old in the country or a 17-year-old on a subway, logs in, clicks Enable Transmit, and meets the ionosphere on his or her own terms. That's the prediction.
Thank you, Bruce. No, we're good. We have time for one question, if there's one. Okay, thank you very much. Oh, I'm sorry, did I miss it?
It's very hard to hear you, so I would encourage you to come up, no, hang on. I would encourage you to come up afterwards, because we're out of time, and talk to any of the speakers. I would like to thank all the speakers today. This is a new concept. It's basically like a mini technical symposium. We run an advanced version of this every year in November. We're hoping that if there's a nice response, that this will be an annual event at the Hamvention. So I want to thank all the speakers for their contributions today, and especially Chip Cohn, who really is the one who kind of put this together. And I encourage you to visit the Radio Club of America booth. There's a QR code on the sign, booth 1811, and get some additional information about the club. Chip?
Great, thank you. I just want to mention that John, N8UR, will be available at the Tapper booth. Very good. So hopefully at that point, if you'd like to see the demos, John will be able to show them to you. Thanks very much. Have a great Hamvention.
Does anyone know who this stick belongs to? It's orange. It might be the control operator. I'm going to leave it here. All right. Thank you.
Thanks. I'm going to keep it.
Yeah, I would gotta talk to Chip.
Oh, yeah, that's a good idea.
I want to make sure that this is going to run. This is not PowerPoint. This is a series of JPEGs. The main thing is, you have an audio output on the HDMI, don't you?
Yes.
Okay, all right, so my WAV file should run.
Yep, so if you just, this is someone else's.
No, that's not
drive,
mine. Can I plug it in just to see if it's going to go?
They should not have left that here, but.
Thanks, yeah, somebody. So,
Hey, Dan, how you doing?
no, you're going to go first. Okay, that looks like it's going to run. I may need you to help me get this back to it when we get to this point, but let me go ahead and I'm going to remove my
Me,
thumb drive.
I was just gonna make sure the image opened, but
Yeah, it's a JPEG.
try to remove it.
Okay.
Should be.
Okay. Maybe the color.
All right.
I was told to say hello to you from John Mock.
Oh, wow.
People on the radio from me last week, and he's going to teach me balloons. And I'm going to go learn from you.
What's his last name?
Maka, he's in Texas, AB5SS.
Oh, yeah, MAGA. Yeah.
Told
Okay.
me, yeah, go listen to your forum.
Okay.
Go and learn balloons.
Yeah, cool.
Last night in Texas.
Well, say hello to John for me.
Say hello.
Is he coming to the GPSL conference?
No, he's not here. He's in.
Yeah, I know, but,
I
okay.
don't know. We just met over the last few weeks on radio from me, and then we've been talking, and nice man, real nice.
Okay, cool.
Anyways.
Showing up? Okay, good. Hey, Joe? In the 3 minutes before the talk starts, I wanted to ask people to show your hands if you've ever been involved or witnessed a high-altitude balloon launch with carrying amateur radio. Very cool. And just what kind of start around here, what groups are you all with and where are you located? Where? Okay. Boy Scouts, and where at? Okay. Texas A&M? Oh, yeah. Say hello to Matt for me. Anybody else? And so just shout out where you're from and what kind of group you're with. West Virginia. Okay. Of where? Okay.
Space Sciences in Denver.
Your name badge is on the table up there. And we have Mr. Arduino here, Grant Glenn Popeil, KW5GP. There you go. Now, how many of you have flown the round the world Pico balloons? 1, 2, 3. And, oh, wow. What's the call sign on that one? What is it? Oh, that's the one where the call sign changed. Yeah. Of course, that's how it works. It'll be up there forever.
Bill, raise the mic closer to your mouth.
Okay, is that better? All right. Okay, it's 11:10, so we're going to start out the Balloon Sat Forum. This is taking amateur radio to new heights. And we're actually sending up weather balloons carrying amateur radio. We've been doing this. I've been personally doing it for 38 years now. And I launched my very first one from my farm in Findlay, Ohio. And it was on a weather balloon carrying an ATV transmitter and a little 2-meter CW beacon. And I launched it on August 15th, which was my birthday. So it was a big birthday balloon. And that was the first balloon launched carrying TV in America. There have been previous flights carrying amateur radio, some on the very big, large balloons they do from Texas and New Mexico. But this is on an actual small weather balloon. And ever since, there have been groups and colleges and schools and even middle schools and elementary schools flying balloons. And it's a poor man's space program and allows you to send, currently I'm working on these small pico balloons that transmitter weighs half an ounce. And they stay up for weeks, months, sometimes a year, and they go around the world multiple times. And your classroom can monitor it every day on their smartphone. And that's the way to hook a lot of the young people into amateur radio, is you do something that hooks into their smartphones, because you know they're always there glued to them. So now we give them something to watch on an amateur radio balloon on their smartphone. So we're going to talk a little bit about sending the latest advances on these small miniature payloads. These have to be under a half an ounce. Now, there have been some that are about 2 ounces, but that's pretty much the limit. So a lot of these are totally solar powered. And so this is one that was very interesting. It was launched from San Francisco. It's still flying. It's been around the world multiple times, and it's been aloft for several months. And they're using an end-fed half-wave antenna. He sends down APRS, CW, and slow-scan television. Now, slow-scan television is a real challenge because we're only running about 10 or 20 milliwatts of power on an HF frequency. He's using an HF, he sends on 40 meters, 20 meters, and 10 meters with this end-fed half-wave. However, the way the antenna is working is on 10 meters, which is the best channel frequency to listen on slow scan. It's very directional, and you have to be within 20 miles of a ground station to have a chance to receive the image. So I've been using these remote web SDR radios, and I've been monitoring his balloon for weeks, seeing if one was going to pass directly over one of these ground stations anywhere in the world. And I finally found him going over one in Utah, and I copied that image. And it's a Martin 1 slow scan. And he's got the full telemetry, altitude, temperature coming down on slow scan. I thought that was, and it's a live camera view. He's got a little live camera on it, all in a payload that weighs 10.8 grams. So that's pretty innovative. There's another one launched by DL7AD and DL4MDW from Germany, and they're sending down live images with a little camera, and their payload weighs under 11 grams. And they send down strips of an image through APRS packets. And if you receive all the packets, you get a perfect image. And this is flying currently around, it just came over Alabama yesterday after being around the world several times. So we're using these small spherical balloons. Now, years ago, you probably saw me fly these silver pancake balloons. They have one seam around them. But the new ones have 4 gores on them, and they're actually a ball shape. So they get more volume to them for the weight, and they go much higher. And therefore, you have a much better chance of going completely around the world. And the current ones that are in vogue right now are Party Woo. They're $3 a piece from Amazon. Yokohama, they're about $15 a piece or so. Orbs, also about $15 to $16. And they're all stretched to about 32 inches in diameter. You'll see them advertised as 50-inch or 60-inch, but don't believe them. That's flat, laying with a ruler on them. And the Simlar is the very newest one that they've been flying. It's a clear balloon, and it's 60 inches, so it's actually about 38 inches. But it is enough volume that you go higher. If you get above about 43,000 feet, you're going to be above most of the storms, and you have a very high chance of going around the world. Anything below about 40,000 feet, it's kind of risky. You'll still make it, but you have a little more difficult time of it. This is a kind of a visual difference between those little super pressure pico balloons and a regular weather balloon, just to give you an example of the size difference. So the difference in emission is with a weather balloon, you're spending a lot of money for the weather balloon, typically about $80 to $100, plus you're using 100 cubic feet of lifting gas, which the price of helium nowadays is quite high. So you've got several $100s in a balloon that's going to go up and pop and parachute back down with your payload. With the pico balloons, the balloon costs, $30 or less, but your big expense is in the actual tracker payloads. Now, I wanted to show you, how many of you witnessed the pico balloon race we did from the food court last year? So this is the Hamvention launch we did from the food court, W8BI on the left, -11, and W8BI-12 on the right. And the one on the right, that the girl was flying, I believe she was 10 or 11. Hers went around the world twice, actually 1.99 times. It landed, it hit a storm in Iowa and came down 300 miles short of going around the world 2 times. And the student on the left, his balloon went all the way to Israel. And at the time, they were having the big battle over Gaza. And we think maybe something might have happened bad to the balloon because it was never heard from again after Israel.
9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. There they go.
They are transmitting nicely.
Yeah, well, it should be.
Now, those were on APRS, and we're going to do that again today, somewhere between 1 and 1:30, right after the forum. It'll take me about a half hour to inflate the balloons, and then we're going to bring them out and near the flagpoles at the food court. Just look for us around 1 o'clock. So I wanted to talk a little bit about this balloon here. This is a very unique, one of a kind, because it has been around the world, and we recovered it. Is W8QT in the audience? No? Eric? It went around the world in 8.5 days. I launched this from my farm in Alabama. It went around the world 22,000 miles, and that's the payload right there. It's an APRS 20 milliwatt transmitter, totally solar powered. Hit a storm in Ohio. Of course, Ohio, right? Because as we all know, if you don't like the weather in Ohio, wait a minute, it'll get worse. So This took this incredibly long route to go from Alabama to Cleveland, Ohio, in the course of 8.5 days. And curiously enough, and it went over Israel, Iran, China, North Korea, and it survived. And you know, I'm pretty sure that if I were to mail a package from Alabama to Cleveland, the Postal Service takes the same route. But this is the very first balloon ever recovered that's been around the world at least once. And you can see the balloon is kind of crinkled and weathered. You can actually see through it, and it's a silver balloon. But the payload still works. There's the flight path as it came back and crossed the magic line to go completely around the world, and then it landed northeast of Cleveland near Geauga Lake. And we could see the APRS track. It was 80 feet up in a tree, and it was hitting a digipeater 10 miles away for several days, and it was W8QT digipeater. And I emailed him, Eric Bartholomew, and he went out and he found it up in the tree. It was 80 feet up, and he hired a tree climber to go up and get it, and we recovered it. So thank you, Eric, W8QT, for this remarkable recovery. So it's called balloon mail. I'm still working on that final delivery stage, but it's worldwide delivery. So with that, any questions? And then I'm going to have some demos here. And we'll have this in the table back there that you can take a look at the balloon and the tracker. And go ahead and set that down for a minute. Or actually set it on the table there as we find. You can come up and see it there. Yes?
Ground stations, can you talk more about that?
Okay, with APRS on 2 meters, there's a real challenge because as you go around the world, the frequency changes. It's 144.39 in America. In Europe, it's 144.800. In China, Japan, and Korea, it's 144.64, 66, and 62. I don't know why they couldn't agree. So I have to draw a geofence around every region and switch the transmit frequency if I'm in that zone, because it's a frequency agile transmitter. So that, and then there are certain areas of the world where there aren't very many ground stations. And so that's, there's going to be gaps in the data. So I also fly whisper balloons, and those are thousands of miles coverage. So I usually with a 10 meters have been really hot lately. So I've been flying a lot of 10-meter balloons on a whisper band. And what we do there is we embed telemetry by sending the standard whisper sequence, which is just your call sign, a 4-digit grid, and power. I embed the altitude in the power field, and then I send 2 more transmissions with a 0, 1, or Q for the call sign beginning, which is an invalid call sign. But since it's sent within the 10-minute window, it's legal. And then I embed telemetry in those, and I use a Python script to grab that data and throw it up on the internet on APRS-FI like it was an APRS object. And amateur.sondhub, that's sondehub.org, is a website that shows you all the balloons that are currently flying in the world right now. So, Mark, go ahead, and I'm going to have Mark talk about something interesting you can do on a website called tracker.sondhub.org, which shows all the National Weather Service radiosondes, and you can go out and grab one, and you can convert it and change these radiosondes to transmit on the 70-centimeter band with teletype, APRS, and there's a variety of things you can do to reprogram them. And Mark, talk a little bit about what you've been doing to recover these radiosondes, and we'll show you an example.
How many of you not have any amateur balloon or club activity as far as recovering balloons? Raise your hands. Quite a few of you. I'm one of them. Basically, I'm in a part of Illinois where our clubs are just very small. They don't really have any events other than maybe field day, and that's about it. And I was always looking for a way to do some fox hunting and such, and they would occasionally do ones every now and then, but wasn't enough really to keep things going. So I started looking at some of the radiosondes that were being launched by the National Weather Service. And luckily, I have one about 85 miles away from me, but I live in the wrong part of Illinois for that. I live in the western part of Illinois where they're due north of me, and very rarely does a radiosonde come my way and enter what I call my zone of interest, which is probably a 40-mile drive around my QTH. So I started looking at tracker.soundhub.org and watching the balloons and watching the daily track of where they're going. And if I find one that looks like it might come my way, or a weather pattern sets up where like we have a large high pressure coming over Illinois, I will tend to pay very close attention to see where they're going. And if it looks like one's coming in my direction, I grab my HT and basically we'll do that. And I've also got a small little 433 megahertz, what is it, LilyGo that I got, and I've only had to use it once. So it's more of a, yeah, LilyGo is a little 433 megahertz receiver, and it connects via Bluetooth to your phone, and you use a software program called GoSonde. And that basically will tell you, it'll lock onto the balloon. You tell it the frequency that the balloon's on. It will collect that information, display it on its little screen, and send it to your phone with the GoSonde app, and then draw a map or draw a direction and distance to the device. And if it's like down in the bushes, or in my case, the time I did use it, I tracked it RF-wise to a field, but I couldn't see the balloon. I couldn't see the parachute, couldn't see anything. This is what I'm hunting. This is a actual radiosonde that I caught in Illinois here about 3 weeks ago. It has a parachute. It has of course, the graw that they're using now. It has that. There's what's left of the balloon envelope. It cut it nice and flush with the nozzle. And there's a flight train and a parachute. I couldn't see this orange thing fluttering in a soybean field. I couldn't see it at all. I knew it was in the field, but I didn't know the distance. So I got out the little LilyGo and said, okay, it's that direction, 800 meters. So I took off walking, and this radiosonde landed in between the rows and laid down perfectly. And I could only see it about 100 feet away because I turned around and actually walked up the field. Normally, I'll say this, do try to get permission to recover these in a farmer's field or any private property. Do ask. Tell them what you're doing. Tell them what you'd like to do. Tell them that, it's down in the field. But do try to get permission. You don't want to trespass because that could be a whole world of hurt. Most people are very open to having you go out and recover it. This is kind of a liability for a farmer. He doesn't want to get it caught in his combine. That's the term I use. You don't want this balloon or the transmitter or the plastic or the flight string getting tangled up in that. So you're doing him a favor. Treat his crop with respect and treat him with respect. If he says, no way, Jose, or I want to go out and get it, by all means, involve them. When you involve people, it's half the fun. And also, do take a moment to get to know the people around your area. Because if you're out hunting and you recover this, be sure to note that it's been recovered because you may have somebody else trying to go after this. So try to get in communications with people that are local to you and go out and try to get it recovered. The batteries last about 6 hours after flight. This one still has a little battery left, so if anybody's got an HT, I can turn this thing on, you can hear what it sounds like. But that's pretty much it, just it's a thing to do when you're bored, and they fly twice a day. Although some National Weather Service offices are suspending some of the operations and flights. So you're going to have to kind of keep an eye on what's going on, do the budgets and stuff, since some of them have been cut. So I'll have this up on the table as well with Bill's flight.
Yeah, free transmitters from the government. How can you beat that? But they're on the 70 centimeter band. They're typically around 403 megahertz, and you can convert them up into our ham bands. They will work there. And there's several sites you can go to figure out how to modify it to do APRS and teletype or Morse code. If you do fox hunting, these would be a great little fox hunter transmitters. So, and yes. To launch a balloon? Oh, if you're not near a huge airport, you really don't need to do anything, but it's always a good courtesy to file a notice to airmen, a NOTAM, and specify your location and the time. And that's just, you call 1-800 weather-brief and just ask for their highball division, means high altitude balloons, and just say, I'd like to file a NOTAM. So now if you're near a big airport, it also is a good idea to call the tower and ask them when the best time to fly for the least amount of air traffic, because we usually ask for windows when we're launching from the university. So with that, I'm going to introduce Ken Piper, KD8PZU, and he is going to show you a little bit about Mesh-tastic. How many of you heard about Mesh-tastic? He's got some interesting concepts of launching a Mesh-tastic node on a high-altitude balloon, mostly latex balloons, but he's got one small enough that potentially could launch on a Pico balloon. So here's Ken, KD8PZU.
Okay, so there was a lot more hands about Mesh-tastic than I thought there would be. I guess I don't really have to explain too much. I'll keep it brief as far as what Mesh-tastic is, what mesh stuff is, because it's kind of taken off. In your typical, like say if you have like your phones or your tablets and stuff, when you want to get on Wi-Fi, all of those devices have to connect to one specific point, your router. That's called a star network topology. So with these mesh devices that are taken off, there is no client and router. Everything is a client and a router. So all of the devices that are in an area can receive those, any sort of data, like telemetry data specifically for like weather balloons. And they can all rebroadcast it. And this means that although you have very small transmitters, I don't know if you can even see this thing from all the way back there. I'll have it back on the table back there with the rest of the stuff to look at it closer. Although you have very small ones, small transmitters that can't go very far themselves, as long as you have many of these transmitters all over the place, they can hop along, and then you wind up with signals that can, go tens or even hundreds of miles. And these, obviously, we're at Hamvention. There's a whole lot of ham radio operators here. So you already know about things like HF and VHF and UHF. These actually use the 900 megahertz band Sometimes you can have them in ISM, so they're unlicensed. Other times, if you want to run more power, you can run it under Part 97 for ham rules. But when you get into upper UHF, it's very line of sight. And as Bill was saying, these right here, this particular device is 2.85 ounces, so it's just a little bit heavier than what's needed for the Pico balloons. But with a little bit of work, these can be made light enough that it can fly on one of the very low-cost Pico balloons. But because this is extremely line of sight, if you can send it up on a balloon and get it, 30, 40, or even 50+ thousand feet in the air, it's going to have a very large area that it's going to be able to see. So the transmissions from these little things here can go potentially hundreds of miles. And if you were to put environmental sensors on these, such as temperature, humidity, pressure, you can even do things like particulate matter sensors and GPS receivers. You can actually get that sort of telemetry to go, like I said, many hundreds of miles with just a little tiny thing here. And these also, because they are so small and low power, they can be run off of solar. This particular device here actually uses not a whole lot more power than like Bill's, his Pico transmitters that he's got. So they can be solar powered. They're extremely small and lightweight. Like I said, they support all sorts of different environmental sensors. If you want to fly it around the world, there is some things you have to watch out for with that. Just like Bill was saying with APRS, how there's different frequencies for different regions. That same thing would have to be done where you geofence it. But yeah, I think it's going to be quite interesting to see how far we can get on this. If you wanted to check this out later, when we hopefully fly this one, we will have this running on long fast. And I'll be available to answer questions about that right after this.
And where do you get these boards from?
I forgot to mention that. So these here, this particular board is, it's made by Seed Studio. It's what they call a Shao form factor. So again, I'll have it back there because it's going to be too small to see, but it's just that little tiny black speck right there that's not much bigger than my thumb, and that has the microcontroller, the GPS receiver, and also the 915 megahertz LoRa radio that's on it. And these are extremely low cost as well. So that entire board without GPS was about $13. And then an extra $10 for the GPS receiver.
Well, that'll be a fascinating project, so we'll have to look for that. Thanks, Ken. Next up, I'm going to have Phil Karn, KA9Q, talk about 4FSK and multiple receive stations. And so take it away, Phil. Let me remove my talk here. There you go. Is it showing up?
Yeah, oh, there we go. I have to select the mirror.
Oh.
Oh, there we go. Got it? Okay, good. All right. Let me move this out of the way just for a second.
Talking to the microphone.
Yeah, this one. This out of the way. Okay. Okay, Phil Karn, KA9Q. I'm from San Diego, California, despite the 9.
Bill asked me to talk about actually a very small little feature that we've been using lately in balloon tracking that I think is actually needs to be better known and more widely used. So this is going to be a very short talk. It's just this one page of text and a couple of pictures. I'm going to talk about a new modulation mode that's come out of a very talented group in Adelaide, Australia, led by Mark Jessup, VK5QI. Dave, VK5DGR, is known for the Codec 2 project, if some of you know about that, and a few other Australians. Their software is open source. That's the repository for it. They call it Project Horus, Horus. It's implemented in firmware for one of the common radio signs. We just heard about recovering radio signs from the National Weather Service. One particular model that we see a lot in California is the same model they use in Australia, called the Vaisala RS41. Vaisala is a Finnish company that makes radio signs for weather services. That particular radio sign is very easy to reflash. Somebody reverse engineered it. There's a connector already on it. When you recover it, you can plug in a programmer, flash the code. We'll also tune it to about 430 megahertz in the 70 centimeter band. If you want, you can retune the antenna, but you don't have to, and then you put fresh batteries in it and fly it again. What this software does is it implements a very efficient modulation mode for sending navigation messages. Instead of AFSK FM, which we used for 40 some years now with Packet, which is very inefficient. This is really well designed. Dave Rowe in particular is very talented at doing modulation and coding. And he's designed a very good modulation method and protocol that works extremely well. It uses 4-tone FSK, that is FSK with 4 tones instead of 2. Unlike, it's somewhat related to the C4FM that we use for digital voice, but it is much more efficient. And in my opinion, it's properly designed, although it's much slower. It's only 100 bits per second. But the modulation is very efficiently designed. It has forward air correction. So if you hear anything at all in an HT, because it can be received even when that doesn't open to squelch on a FM radio, you just hear a low rumble. There really isn't much to hear. The link margin, I estimated and calculated, the link margin is about 16 dB better than AFSK FM, than ordinary APR. 16 dB is nothing to sneeze at. It's enormous. In my opinion, nobody really should be using ordinary APRS anymore, not over 1200 watt packet. I mean, come on. I was involved in the X25 when we first did it in 1983. And even then, that modem was considered obsolete. It was a placeholder until we got something better. Basically, this modulation method just works. It sends a nav message about every 2 or 3 seconds, then there's a pause, and it sends another one. So it's even faster in terms of getting a fix through than APRS. It just works extremely well. In Southern California, we have a network of remote receivers that can receive both the weather service frequencies and the ham frequencies that we fly balloons on. One of the receiver sites is on Toro Peak. It's a mountain not far from the Salton Sea. That's about 9,000 feet above sea level, but it's about 100 kilometers from my house. It's not close. One night I was testing one of these converted radio signs, and I just turned it on and happened to sit it down on my bed in my bedroom, not expecting it to hear it, and it picked it up 100 kilometers away, transmitting about 50 milliwatts or so, just lying down on the bed, heard it 100 kilometers away. This stuff gets through. Once you've used it, you never want to go back. It can be received using a Raspberry Pi and any of the common software-defined radio dongles like the RTL SDR. It can also be used with my own multi-channel receiver I'm calling KA9Q that can receive lots of channels at once. This has come in occasionally handy at the high school where I mentor, Mount Carmel High School in San Diego. And sometimes we launch more than one balloon at a time, and having a whole pile of RTL SDR dongles, one for each, is kind of inconvenient. So with my receiver and a suitably wide front end, we can hear a whole bunch of them at once. It also comes in handy just when tracking the regular Weather Service balloons, because sometimes there can be a half a dozen or a dozen of those things on the air at a time. Whenever there's a Falcon launch from Vandenberg Space Force Base north of LA, you can always tell when one's about to happen because you'll see just a flurry of weather balloons going out there starting hours before the launch, like every hour or half hour or whatever. In fact, they often scrub launches because of high altitude winds, but that's how they know. And I've seen, I don't know how many of those things flying at once, and it's really handy to be able to see a lot of them. We've already heard about recovering these balloons. I'm very fortunate that I live very close to a launch site. I don't know if you can see this, but we don't have a pointer, but over in the lower right corner, there's a marker that says Radio Zone Launch Point. In the middle here, this is Miramar Marine Corps Air Station. It used to be known as NAS Miramar. It's where the Top Gun school was that was made famous a few decades ago. But I live just west of it, on the other side of this freeway, on the left side, 805, and the launch site is down there in the southeast. So I live very close to one. I didn't know this for a long time until I think I found one guy who was receiving these radio signs and had recovered them. He had written an article in QEX some years ago, and his name was Ryan Gomanis, WW6RAG. And it just so happened he was living in the neighborhood where my wife and I routinely go on walks, and we looked him up. We banged on the door. I was expecting to find, an older guy. He was a high school student. Of course, his mother thought he was in trouble or something, who bangs on the door looking for, a radio ham. But, he was just doing this. I had never heard of this before. And he was happy to talk about what he'd done, show me his collection of radio signs and all that. And he was the guy who infected the rest of us with this interest in collecting government radio signs, because we were living so close to, where they were launched. It was just a natural thing to do. Now the map in that part of California is just literally green dots, each one of them being a receiver running the software that's receiving these National Weather Service transmissions. This was the very first one I recovered. So I finally remember this one. This was a cemetery not far from where I lived. This is exactly where it landed. You can see the remains of the balloon in the middle, and the radio sign on the left, and the string hanging over the fence. This is also probably one of the easier ones I ever recovered. The first one's always easy. And then it gets harder and harder. They land in the desert, really rugged areas, or whatever. This one was really easy. This is what the RS-41 looks like, the one that we refly and reprogram with this software. As you can see from the scale, it weighs 84 grams with the batteries inside. So it's too heavy to fly in one of those round-the-world balloons, but it's plenty for a fairly small latex weather balloon, what we call pop and drops. And you probably can't read the label on it, but it says harmless weather instrument. I've always liked that one, harmless weather instrument. It is not dangerous. Please do not return to the NWS, recycle or dispose of properly. So we can grab these things and reuse them without any guilt at all, because they don't care to have them back. In fact, they know we're doing this, and they're probably happy we're doing this because they're not leaving their litter in the desert anymore. So that's what they look like inside. One battery's been removed to turn it off. A lot of the way is the battery. There's a transmitter down here at the bottom. The wire between my fingers and the left side, that's the antenna. It's just a flexible piece of wire. The silver thing sticking out to the right is a sensor for temperature and humidity. It's usually damaged on landing. It's the most expensive part. That's probably why they don't think it's worthwhile refurbishing them. We just take that off, reprogram, and use them as trackers. There's a GPS in there and an antenna, and they work extremely well as trackers. Even if you're flying some other payload, you can just hang one of these on and use it to track your payload and get a very reliable track, so you can recover these things. So as you can see, they look like about the size of HTs made out of styrofoam. One of our guys, KQ6RS, Randy, has recovered at last count over 400 of these things. I think he's addicted. I mean, there's a leaderboard. I think he's still not number one, but he's close. I think some guy somewhere has gotten over 500 of these things. I think it becomes an addiction. Somebody said they're free. I don't think they're actually free, because he has a pretty big truck and he has to drive out in the desert, and the gasoline isn't free. So he won't tell me how much he spent on gas. So anyway, that's really it. I didn't really have much to say about this. I thought I'd leave most of the time for Q&A or or give it back to Bill for the rest of the session. Any questions? Okay, thank you.
Sure. All right, Jim. The next talk will be from Jim Langford, and it's KC0RPS with the Edge of Space Sciences Group. Oh, goes in there somehow. They said that the inventor
HDMI.
the inventor of the USB drive, when he passed away, they put his casket in and then they had to pull it out and turn it around to set it back there. There you go.
Okay. Well, I've done one pico balloon. Let's see. No, no, that's power. Here we go. PowerPoint.
How many balloons has Edge of Space Sciences been?
Yeah, I was going to say I've done one pico balloon. I've probably done about a dozen weather balloons until the Weather Service stopped doing them in Denver. And Edge of Space Sciences is now on balloon number 377. Started in 1990, and let's see, there we go. Started in 1990 with amateur TV folks. And they said, what are we going to do with this TV? Well, let's put it on a balloon. And then somebody said, do you think we ought to track it? Yeah. So, well, I Googled, on the left there, you can see that I Googled balloons and radios, and Amazon offers some radio balloons for sale. But, but what I wanted to talk about was some of the radio issues that we run into. Now, we do a program almost entirely of amateur high altitude balloons, latex balloons, goes up to 100,000 feet, pops, comes down on a parachute. It's about 90 minutes up, about 45 minutes coming down, and it usually goes somewhere between 50 and 75 miles out into eastern Colorado. What we do is support STEM school programs, university aerospace programs, high school programs. So what we're doing is flying probably a dozen payloads that students have made. They weigh about 1 kilogram each. The FAA regulations say that if your payload string weighs less than 12 pounds and no one piece weighs more than 6 pounds, which I think is the size of a goose, you can fly with very few regulations. If, however, you exceed that, there are regulations that you have to meet, but you can fly a balloon and there's no weight limit on that. And we generally are flying balloons that are larger than 12 pounds. We used to have a variance from the FAA that said we could fly it up through clouds. A few years ago, they took that waiver away from us. So now, if it's cloudy, we have to split it up into 2 12-pound payload strings. If it's clear, we can do 1 large balloon. But we send the balloon out into the field, and then we take the students out there and we go out and recover the equipment. We're interested in getting our equipment back. The students are interested in getting their payloads back. In 377 flights, we've never failed to recover any balloons. A couple of them took a couple of months until the farmer finally found them in his field, but we count that as being recovered. So there's a picture of the students lined up with the balloon. We have them hold their payloads and launch them. And even though Phil said nobody should be using APRS anymore, we always have 2 APRS beacons on our balloons for redundancy purposes. And we are now also flying an ADS-B, which is the aircraft beacon, and the flight controllers can actually see it on their screens. If you fly the exempt balloons less than 12 pounds, you technically don't have to contact FAA, but we go through the whole, we contact them a week in advance, 3 days in advance, 24 hours in advance, 5 minutes in advance, and we go through that process even with the exempt balloons. Now, you can launch your own balloon. You know, a single person, you can fill up your balloon, put some sort of a radio beacon on it and launch it, and go out, and if you've got a tracking mechanism, go out and recover it. And your chances of doing that are pretty good. We, however, do larger balloons, have a organized program that does happen months in advance, working with the schools. Poor Man's Space Program, I think Bill mentioned that. The big balloons that we use start out about 9 feet tall. They're probably 8 feet in diameter. The burst diameter on that balloon, I think, is rated at 47 or 40, I'm sorry, 47 feet in diameter. So as it goes up, what's really neat is as it goes up, if it's blue sky, it gets larger, and the white against the blue sky, you can see it with the naked eye at 100,000 feet. There's the flight profile. It's pretty linear going up and then exponential coming down because the parachute comes down as a function of air pressure. And there's the blue dots are the every 30-second beacon tracked out into the field. If you're going to do your own, or if you're going to do a balloon and you want to recover it, there's a couple of things you need to do. Proper prior planning prevents poor performance. I think there's another P in there somewhere. I'm not sure what that is. But habhub.org has some prediction software on it that you can run, and you can estimate how much gas you need to put into the balloon to go up at a constant rate or go up at a known rate. And then once you know the rate you're going up, there's some software that will take a look at the wind models that the Weather Service publishes and show you where the balloon's going to go. And one of our keys to success is we use the predictions to get our tracking and recovery team out in the field prior to the balloon coming down. And about 50% of the time, we can get the students out in the field as well. And so if they can launch the balloon, and then we can get them in the cars, take them out in the field, they can see the parachute coming down, and then the landowner will let us walk the kids out in the field to pick up the balloon. That's really neat. They're very enthusiastic and get to participate as much as possible in this thing. So that's pretty good. Yes, question. Well, he said, why do we let it pop? We want it to come back down within range where we can pick it up. If we went with a floater type balloon that did continue on, the likelihood of recovering the student payloads is 0. And most of the student payloads do not have radios in them. They have data loggers in them. They collect, ultraviolet and temperature and particulate and that sort of thing. But they're collecting the data, and they have to recover the balloon in order to recover their payload. Well, his question is what do we have to, if we're flying VFR rules and we do run into clouds? The regulations say you shall not fly through clouds with less than 5/10 visibility, cloud cover. So in the morning we get up and I look at the the cloud prediction models and the air stuff, but the aircraft prediction stuff. But in the morning, we go out there and we look, and if it's clear and where we're going to be flying down to the south is clear, we go ahead and fly. If it's not clear, we then go to the exempt balloons, which do not have the cloud requirement. But we put our teams out into the field, and we typically have on the order of 4 to 7 vehicles going out in the field. One of our people is the tracking and recovery coordinator, and we all communicate using ham radio to talk to each other. And we also track the balloon in that we all have APRS equipment in our cars, computer that collects the data, puts it on a map, and so we can see what's going on. So communications gets to be important. One of the primary things that we use is repeaters out in the field. One thing nice about Colorado is we've got some really tall mountains just to the west of us. And there's some repeaters up on Pikes Peak, for example, at 14,000 feet. It's a hell of a tower. And we can use that repeater quite a ways out into the eastern Colorado. There's also a couple other mountains that have repeaters that we typically use. If we get out of repeater range, we switch over to simplex and communicate amongst ourselves with simplex out in the field. We have a ground station that we leave at the launch site, and that ground station serves a couple of purposes. Number one, it a couple of purposes. It eye-gates the information from the balloon back onto the internet. And the reason we do that is because we have a site on the internet that shows the maps and the balloon performance, and all the kids can bring that up on their smartphone and track the balloon as we go out in the field. So they can see essentially the same stuff we're seeing in the car on their smartphones, and that's really valuable. Once in a while, some of these college students will take off in their car on their own, and that gets a little scary as far as interfacing with the landowners and things like that. But most of the time, it works out real well. The other thing is our ground station guy. He's sitting in the comfort of the truck in his bunny slippers and can look at what's going on in great detail. Right now, the guy that's doing it actually is a PhD in aerospace, so he's the right guy to be doing this. But he can look at it, he can predict, computers are predicting where it's going to land, but he can fine-tune that, radio that information out to our tracking and recovery coordinator, and then he can put things out. So this is a big operation, but I just wanted to talk a little bit about this. Another neat tool we have, Rocky Mountain Ham in Denver has put together a DMR network. Actually runs along the Continental, or the Front Range, Continental Divide, clear from Cheyenne, Wyoming to Albuquerque, New Mexico. And they let us use their system for DMR or communication. So we actually have two modes of communication. And the DMR system that they have set up actually works better than the mountaintop repeaters when we get out in the sticks. So most of us have DMR capability in our cars as well that we use for that. But if all else fails, cell phone coverage. Actually, when we first started doing eastern Colorado, there was a lot of dead space where there was no cell phone coverage. Over the years, things have gotten better, and once in a while, I'll get a cell phone call from the Alpha, the tracking and recovery coordinator, just because it's easier than fighting everybody on the radio. Yes, sir. Question.
This only work in open country. In the Northeast, all you will see is trees.
Yeah, well, the communication would work just as well. Yeah, we're lucky in eastern Colorado. It's all grass plains and almost always lands on the ground, once in a while in a power line. That's a different issue. But like Bill said, if you're out in the east, you're likely to land in a tree, and then you got to deal with the trees. And you can usually find them because they'll still be beaconing. And you know, the best thing is when it lands, you can still hear the beacon. You'll get a latitude and a longitude. You can actually put that into your handheld GPS and get the kids together and hike out. You gonna shoot me when I'm running out of time? No. Okay. Short comment.
When I was out in the Edge of Space Sciences for one of the Great Plains Super Launch events, it's wide open spaces, prairie land, no trees. My balloon landed in a cornfield, which is one of the worst places you can land. They somehow found a cornfield in Colorado. They came back, the chase team came back, and it had a ear of corn stuck in my payload.
Okay, so that was the kind of radio that we're using on the ground. Yeah, question. Oh, you're beautiful. He asked, what kind of APRS transmitter do we use? ADSB. I'll show you a picture of one. ADSB, the aircraft transmitters, were pretty big and pretty power hungry until they were required on UAVs, drones. All of a sudden now they've got really small. Unfortunately, they haven't gotten really cheap. But as far as APRS, let me talk about that first. Over the years, it started back in 1991 with directional antennas, and people out in the field, and the tracking and recovery coordinator would position people out in the field. We had a grid system that we said where we were. He would triangulate and use a grease pencil to draw on a map where the balloon was. When we went to started using ADSB, some people quit because it wasn't fun anymore. But we were using GPS units, using TNCs and radios. The Elinco DJ C5 was a credit card size radio. We were using that. Then we used some of the smaller HTs. I forget if they were Yaesus or what. But now what we're using for radios are these radio modules that the Chinese make. And it's actually a circuit board radio. Probably can't see the block diagram down in the bottom, but it has all the pieces to do CTCSS. They're usually both VHF and UHF, or maybe you buy just one of the bands, but it's got a microphone in, it's got audio out. You do have to have an external if you want to use it as a radio. In fact, this is the module that's in the Baofeng. And so that leads immediately to the question of what about spurs on it? And as it turns out, it does need to have a low-pass filter built into it to meet the FAA specs. I'll show you a picture of that in a minute. But we've used APRS. I think Phil was talking about this Horse binary. We haven't used that to date, but a Horse binary is being used more and more. We have flown amateur TV, and we've had students that have tried to fly radio, commercial stuff like Wi-Fi, Bluetooth, and LoRa. So we've had all of those various things. There were some students just recently flew LoRa and were receiving packets back down from the balloon at 100,000 feet pretty reliably. Okay, somebody was asking about the ADSB. As the ADSB got smaller, for the drones, you can see what the size of that is. That used to be about $2,500. And you need to have a special one that will go above 18,000 feet. A lot of them, the GPS will stop at 18,000 feet or not go any higher. So we have to get a particular model that does. And unfortunately, the price of those has now gone up to about $5,500. And so part of it is these are certified for FAA flight on aircraft. And I don't think we actually need that certification, but that's what we get. So right at the moment, we've got 2 of these units. We'd like to get a 3rd one, but we haven't gotten the finances to do that yet. DIY, the APRS, the ADSB, the aircraft, I don't know. I don't know exactly what it is. I'm told that that puts out a 50 nanosecond pulse at about 250 watts. Okay, 3 minutes left. Okay, so building the beacons, we've got that's a picture of what our beacon looks like. We package it up. We use these things over and over again. So it's packaged up with a solid plastic top and bottom on it that will withstand as it hits the ground. The rest of it is foam core to keep it lightweight. The board is custom built by a couple of our members, has a GPS, has the radio on it. It has communications, another module on it to communicate with other parts of the balloon payload string. On the back, you can see the processor. And this guy actually, instead of buying a TNC, he programmed his own TNC software into this thing. It's got a memory card up on top of it to keep track of the data. But when we get the whole thing done and put together, it does have to have the low pass filter built into it, and designing that was an exercise. It was pretty interesting, but he finally ended up, if you look on the far left, you can see the peak, that's the primary, and on the far right, you can see the 3rd harmonic, which is down about 67 dB or something like that, well below the 40 that's required, so it worked. And then the mechanical build of these things, if you're gonna fly, and some of these have flown over 100 times, the mechanical build, it's all circuit boards that are bolted together, very few connecting wires between the 2 of them. Student payloads that fail, it's almost always because their connecting wires aren't soldered well or don't connect well together. So we have worked, some of the guys in our group have worked very hard making a solid unit. But that's kind of the big picture on a program that uses these beacons over and over again and flies lots of balloons. So that's what I've got to say. I will be around afterwards for any additional questions. Thanks for listening. Yeah.
Years ago, called Wind Tracks, and I think actually they were operating kind of at the same time that Edge of Space started, and they did similar STEM type things with schools. I know one of the payloads that they flew that was very popular was a crossband repeater, where they would set up different school groups and actually talk through it, VHF, UHF, through the repeater as the balloon got at altitude. Has Edge of Space ever flown any crossband repeaters?
Crossband repeaters, he was asking, has anybody flown those? Yeah, we have one that one of the clubs has made, and we have flown it several times, and I think, at 400 or 100,000 feet, the radio horizon's about 400 miles. And I think we did one time do a 700-mile contact from somebody over here up through the balloon and over. So crossband repeaters have been done before.
Thanks, Jim. Okay. I've flown crossband repeaters many times, and I was involved in the early days of Wind Tracks with Chuck Frist. Also a simplex repeater is the easiest thing you can fly, and it's a little HT with a little voice recorder. Argent Data sells a nice one that records a message and plays it back. And once you get used to the 20-second delay, we're covering 12 states from a high altitude balloon on 2 meters. So, and by the way, if I fly a balloon, there could be a field of 1,000 acres with no trees, but one tree in the middle of it, that's where my payload lands, right in the top. Next up is Carl Lister, WA4ADG, and he's going to talk about flying a linear translator on a balloon, which he's done. Oh, yeah. There you go. And talk into the microphone.
This is a report on a flight that was done in 1990. Built a linear translator that we flew from Knoxville, Tennessee, and I called it the poor man's CubeSat. On May 19th, 1990, a mode HV linear translator, HF up and VHF down, was flown from Knoxville on a 3-hour balloon flight, and the performance was beyond all expectations. And it was all built from junk box parts for about $50. Transmitted with 100 milliwatts, and we had reliable contacts made from stations through the balloon, separated by 593 miles. WB8YIF in Marietta, Ohio, made contact with K4MOG in Marietta, Georgia, which claimed the record of 593 miles. The transponder received on 28.4 megahertz and translated to 144.3, and it had a 22 kilohertz bandwidth, so it would send several QSOs simultaneously. A beacon was also included on 144.311 megahertz. It was running about 25 milliwatts. The flight reached approximately 100,000 feet, which coincides with the received range of the two stations that were 593 miles apart. And we didn't recover it. This was 1990. GPSs weren't really the thing back then for inexpensive GPSs. But anyway, linear translators are an exciting alternative to balloon-borne FM repeaters. What are the differences between a linear translator and a repeater? A repeater takes a signal and demodulates it to audio and takes that audio and retransmits it through another transmitter. You can usually only pass one conversation at a time. A linear translator never converts to audio, but uses a common IF frequency between the receiver and the transmitter, and the signal is just simply upconverted to the new frequency, and there's no audio involved at all. But the nice thing about the linear translator is it will send any mode. You can send CW, AM, FM, single sideband, pulsar which aren't allowed on these frequencies. But the linear translator circuitry is actually simpler than a repeater. There's fewer electronic stages involved in it. The only disadvantage is they're power hungry. Everything's operating Class A linear on all the electronics, and that consumes a lot of electricity and a lot of heat, generates a lot of heat. With some new biasing mechanisms, you can get the transmit power stages down to lower, more efficient. So here's basically what the two look like. The top is a regular FM repeater, and the bottom is a linear translator, where we share an IF stage between the receiver and the transmitter, and everything up converts. You're not going to be able to read this, but this was the block diagram of the repeater of the linear translator that I flew in 1990, and it basically had started at 28.4, it down converted to 20 megahertz for the crystal filter, and then up converted to 144.3 megahertz. This is a picture of it. I don't have very good photographs of it. This was taken a long time ago. But that's the 100 milliwatt power amplifier right there. That's not showing. Yeah. Anyway, the top image is the 2-meter power amplifier, the CWID, or you can see the memory chip right there, and then the third mixer. And the very bottom picture is the actual transponder contained in the styrofoam box. And 1990, I had red hair back then. But the picture you see right there, the top picture is the trash can gantry and the parachute stretched out, getting ready to launch it. And that's me at the bottom picture right before we let it go. And, the top QSL card is from a K4 MOG. He was one of the stations that received the 593-mile record. And the bottom QSL card was from a station 25 miles north of Dayton, Ohio, who received the 25 milliwatt beacon. This is a picture of that was the first generation. This is a picture of the second generation, which I have given away to another ham. And that's one of the more modern circuit boards. The first circuit boards were all drawn with a Sharpie resist pen and etched with ferric chloride. It was all, like I say, very low budget operation. And there's what $125 worth of lithium batteries looks like. So I got the idea for this from an article that appeared in the 1983 Ham Radio magazine, which is long gone. You might be able to find this online someplace, but this was an excellent article on the operation of linear translators, how they work. This is a photograph that was taken by, I do a lot of work with the University of Tennessee Amateur Radio Club. This is a photograph from one of their flights. I want to make y'all laugh. I do a lot of repair work on electronics. Can you see what's going on with this picture? Somebody has taken a 1/4 20 volt, shoved it into a fuse holder. It burned up the circuit board on the bottom. And this is my favorite photo. You'll never forget this one. This is what I found in the heatsink of a TS-120. If that guy had been alive, I'd still be in a rubber padded room. Okay, I've got an audio clip I'd like. Hopefully this will run. Get to it here. This is a cassette tape recording that was made during the flight in 1990. Hopefully the audio is going to come through. I'm going to give you the short one here because we're running really low on time. There we go. This fellow was the Georgia end of the 593-mile contact.
Calling CQ, the balloon experiment, resting 144.305, 144.305, listening on 144.305, Kilo 4, Mike Oscar Golf, calling CQ, the balloon experiment, and standing by. Mike Oscar Golf, Kilo 4, Mike Oscar Golf, Kilo 4, Mike Oscar Golf, WA482.
You could hear some of the QSB as the package was rotating around. We had vertical antennas on both of them, but the vertical antenna on the top was a 10 meter, and the bottom one was the 2 meter quarter wave. But there was some QSB that rotated around. I have here a demonstration for you here. Linear translator. I can get somebody to hold it. Transmitting, I'm transmitting data on I'm transmitting into it on 28.4 and receiving on 140. Oh. Okay, I'm transmitting on 28.4 and receiving on 144.4. So I get all kinds of feedback. WA48.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
So, this translator only has about 8 kilohertz bandwidth, so only one conversation at a time can go through it. But it uses much more modern electronics, and it's about a fifth of what the original one was. This one's running about 30 milliwatts output. I have another power stage that goes on the bottom that brings it up to 100 milliwatts, but I didn't bring it for this demonstration. Any questions? Well, I'd like to fly this for field day. We may have to get a special class added I'm not sure how the ARRL would break these contacts. It's not really a satellite, but it's not really an FM repeater, so I don't know how they would rate that as a contact in their classification of it. Yeah, exactly. But that's just, $50 to $100 on this one, $50 to $100 worth of parts, much more modern electronics. And, to fly to 100,000 feet, you've got a 500-600 mile radius where you can contact stations for field day. This would be a great thing to do in an emergency. You could fly a portable repeater in an emergency. And they actually had talked about doing some of this in the fire problems they were having out in California, flying portable repeaters on balloons. That still may happen, but any other questions? Yeah, you are, okay, yep. Any other questions? Okay, thank you.
I wanted to mention that we're going to be doing, hopefully, a balloon launch of 2 pico balloons, 1 or 2 pico balloons at 1 o'clock, somewhere between 1 and 1:15 or so, from the food court near the flags, but the weather is not ideal. So it's very high winds, overcast, not the thing don't try this at home like this. Now, one year we ended up in the hex beam, and it stayed up there for several minutes, fell off the hex beam, landed on a power line. Then it fell off the power line and ended up 11 days later in Turkey. So that was a very tough balloon. Another thing we did recently that was kind of very unique is that a good friend of mine, Greg Mann, KF4ZTI, had been trying to send a balloon around the world for years and had never succeeded. Unfortunately, he passed away 2 years ago, so what we did was to send his ashes on a balloon, half-gram bag of ashes on one of the pico balloons, and it just completed, yesterday, its first lap around the world and is now over Africa and Spain. So I just wanted to give a shout out to Greg, KF4ZTI, as he completes his second lap around the world. We decided to send him around the world instead of a balloon. So I hope to see you out at the, tomorrow at the ARRL Youth Rally, if the weather is conducive. We do plan to send up a pico balloon. I'm not sure exactly where, but it'll be in Forum Room 3. If you're between the ages of 11 and 21, welcome to attend that. And we're going to talk about launching pico balloons, and maybe if the weather's good, we'll launch 1 or 2 of those. One will be, the ones today will be W8BI-11 and W8BI-12, which is the DARA club sign. And it'll be on 2-meter APRS every 2 minutes. Just as a side note, it's on 144.39, but also transmits on 144.34. So it's a clear channel, so that if you hear packets on that, it's probably the balloon, although this is Hamvention, so just one big RF field out here. Yes. A helium, because it's in a crowd. Hydrogen works better, even on the pico balloons, and cheaper. But when I'm around a big crowd, because static electricity, people smoking, you just don't want to be around hydrogen. But hydrogen is safe. I was also asked about legislation that has been popping up from different states prohibiting the launch of small balloons or of any kind of balloon if you're not a government agency. Florida had a particularly bad law that prohibited anything unless you were a 6-year-old kid or under. So my advice in Florida is to find a 6-year-old kid to launch your balloon. Then it's legal. And I assume one of the legislators in Florida had a 6-year-old grandson or something. So he wanted to exempt them. Louisiana is coming up with legislation right now, and we've got to try and add an exemption for educational and ham radio balloons. And Some states actually have incorporated that exemption in their state law prohibiting the release of balloons. And I can see some of the reasoning behind that is because they don't want them hitting power lines or affecting wildlife, but that's the primary driving force behind these new laws. And the FAA is coming up with new legislation in about a year that may impact us, but we're working to get access to that committee. We actually got an educational and STEM representative on their committee lists to address this. With that, any more questions? And then we have to say goodbye till next year. Yes. Yes, if you go to YouTube and search for Hamvention, all the forums are live and then they will be recorded so that you can watch them later on YouTube. So thank you all for attending, and hopefully we'll get these launches off in about, about a half hour to 45 minutes from now. We're going to inflate the balloons inside of a building and then take them out to the food court. So hang out in the food court probably just after 1 and see between 1 and 1:15, and we'll try and get at least 1 or 2 off the ground. But in these kind of winds, we smash into buildings and all kinds of wild stuff. We hit an RV one year. So actually we had an astronaut launch. We did 4 Pico balloons, and the astronaut was going to be the last person to launch one of these balloons. And we did that from near the flea market. He studied very carefully the 3 previous launches so he could get it just right. That's what astronauts do, right? When he released his, it hit a downdraft, hit the mirror of an RV and got stuck. He relaunched, hit a power line. But it did fall off and finally took off again. Thank you all for coming, and we appreciate it. Carl, do you want your laptop back? I'm sure they'd appreciate it.
The AC is apparently on the fritz. You couldn't tell. So the good news is the fan, the loud AC, will not be blowing in your.
Yeah. Oh, this is perfect.
See it on the screens.
Excellent.
You gonna go?
Yeah.
Anything will be over there. Thank you very much. I appreciate
Are you going to have a problem when they swap laptops?
Just look like it.
Didn't you have a problem a couple of years ago where it had to be our laptop?
No, we have the these boxes right here.
Okay.
They're fancy boxes.
Just don't
They,
throw
They have a constant out all the time. So like the TV will never turn off or anything when you unplug the laptop.
Yeah.
So and then it converts everything into 1080p. A constant frame rate signal. So if they plug in a MacBook, they plug in like some crazy 20-year-old Linux laptop, it all works.
You first started doing this.
Yeah, we fixed it. It was like these are like $150 a pop. Let me tell you, they're life.
One
wants to do. There's no clicker.
Right, so we just have to advance it
So
from
just
here.
advance from there, but this is the perfect, because you can see the next slide
Yeah,
coming up.
and lead into it.
So, I don't know if he's gonna wanna talk, and,
Well, he's got the first.
I know, but sometimes he's averse to.
Oh, all right.
Is that one live?
Switch. No, but I bet we can make it. There's usually an AV person.
Think,
Oh, wait a minute, there's another, no, that's,
they're kind of set up to use this one.
yeah, which. That's too bad, I like to move around, but yeah, whatever.
So, there's no clicker. No, huh? So you advance the slide with that one, just to the right. If you want, I can stand here for you and advance it, and then you can just take the portable mic. You just come up here and you talk, and this is the current slide that's displayed.
Yes.
That's the next one.
Yeah. I have a feeling that people have to stand here and advance it themselves, because we'll have to do this microphone right here, you know? Because past it, it's not gonna be any good.
So we can just talk this way.
Yeah, I think so. You just have to come up to the podium. But now, like, someone like Ann and Kathy, where should they be sitting in the meantime?
Where should I be sitting?
And Bob?
Try and sit toward the front, and then,
We can sit on here and.
No, you have
Yeah,
to sit in the
sit in
front,
front is good.
and then you just have to come up, and it'll be like an award ceremony.
Who do I follow?
I just called the fairgrounds to see if they
So Howard's early and then. Wherever he is, I'll be ready to come up after.
Good luck. Have fun.
And it's after Howard.
He's gonna hand it to you, you're gonna hand it back to him.
So you don't have to press this. This is ready to go.
It should be live.
I wonder if you really need it. Actually, you know, maybe that's a good thing that the speaker should. I think I can stand it.
But, Those are fighting words, Dan. Come on.
Well, I believe in multiple modes.
I swear, it's all up to the attempt. I have done. I've looked at this stuff. It's second on that was it worked out great.
Yeah, I think two more.
Okay. Good afternoon, everybody. Just wait a couple of seconds for everybody to take a seat. Thank you very much for coming to our forum today, and sorry about the heat. They tell me they are working on trying to get the air conditioning going, but we appreciate your patience on that. I'd like to say hello first. My name is Howard. My call WB2UZE. I'm one of the founders of the Long Island CW Club, and today we're here to talk about our club and the renaissance of Morse code. We're very pleased to see that we can call it a renaissance now. We have a number of speakers that are going to take a few of the slides sitting here today, but I'd like to introduce first the two primary speakers. Mike.
Hi, I'm Mike, N1CC. I am an instructor and a student of LICW, and I work in our curriculum development.
Next, we have Don.
Good afternoon. Good afternoon. My big voice doesn't work in here. I'm Don, KC0DWZ. I too am an LICW instructor and student and help Mike and Howard sometimes.
Okay, so let's get started. So what was Morse code used primarily for over the years? Well, we've all heard of Samuel Morse. We know through his invention and work that the United States was wired from coast to coast. And if you can just imagine how exciting that was, where you'd have to wait for the Pony Express to get a letter. Now you could send a message instantly. So that was revolutionary. And then, of course, as we proceeded through the 1900s and into the early part of that century, Marconi came along and created radios where people were actually able to converse with each other. And it became a law that it had to be on maritime vessels, especially after the Titanic disaster. So Morse code was very important in emergency communications and regular communications while at sea. Then came the use extensively in World War I, also in many cases using wires to connect up sets in the battlefield, and we're very pleased to have one of those units ourselves. It's fascinating to have. Through the 1930s, and of course, World War II was very important, a place for Morse code, and they were constantly looking to teach and to train in that particular decade. And Morse code was used commercially. There was messages being sent between gigantic radio stations all over the country, all over the world, predominantly using that mode of communications. Unfortunately, the majority of them are all gone except for K6KPH that we know on the West Coast, and there are some remnants of some major antenna systems still around the country that you can see where there were gigantic radio stations all using CW. So it was very important, but then the FCC came along about 25 years ago and eliminated the need for Morse code to get a license, and we thought things would be finished at that particular point, but instead we have seen that because Morse code is no longer forced upon us, many of us are interested in learning, and as our hobby population has been getting grayer, as you can see right here, a lot of us now have free time and are retired, and people are coming back and say, hey, you know, I didn't learn it back then, or I didn't learn it that well, and it was forced on us. I didn't like that. Now I want to learn, and people say that they're putting learning of Morse code on their bucket list. So what is the general attraction of Morse code? What are we using it for these days? Well, we're very pleased that the young people like to use it in POTA and SOTA. We all know that if you're going to do a portable operation or something outside, if you're going to go deep into a park, or if you're going to go on top of a mountain, you'd rather carry a radio that's the size of a pack of cigarettes as opposed to a sideband radio, which would be much heavier. Or if you're going to do FT8, you'd have to lug along a computer. So here you can take something very small and a compromised antenna and get out. It's very exciting. So that's driving a lot of young people to come and learn. And, you know, as far as I see it, you know, today, I think that people might be getting a little bit tired of the immediacy of everything that you have in the palm of your hands. And CW is a very efficient yet romantic way to communicate. There's people that can use 1 watt or less than a watt and get out all over the world. I mean, somebody lent me for a vacation that I was going to take a KH1, which is this big, and it has a telescoping antenna. So I went down to the water on Long Island where I live, sat in my car, I threw out a 20-foot counterpoise, and there was a contest on, a CW contest that worked all over Europe, got into Russia. I think I was only putting out 3 watts because the battery wasn't charged that high. So it's kind of amazing. I couldn't believe it. Here I am sitting in the car with the antenna sticking out of the window and sitting in the driver's seat with this little paddle on the thing, and it works terrific. So all of this is creating a nice resurgence of people who want to learn, and that's one of the reasons we established the club. Okay, so I've spoken on this particular slide. I kind of know this by heart. So next up is Don, and I'd like to give him the microphone here.
Okay, thank you, Howard. Hello again, everybody. So I'm going to talk a little bit, I'll probably repeat a little bit of what Howard said. I'm going to weave a story of why CW is making a renaissance and a comeback, along with my personal story, because they're intertwined. So primarily it's making a comeback because of the newer hams. And there's many, many advantages that Howard already talked about. And it's the original mode of radio, right? So we're going back to our roots. I like it because it's another tool in the toolbox. You know, you can do a lot of phone, you can do a lot of FM, you can do a lot of satellites, you can do a lot of digital. But for certain awards, you know, CW is really better. If you're into paper chasing, whether it be contesting or worked all states, DXCC, whatever, CW is a very good way to pursue that. Since the code was eliminated, I've only been a ham 4 years. I found out about it during COVID when I stumbled across a video where somebody was talking about emergency preparation, and they said, as a ham radio operator, you no longer have to use Morse code. My ears perked up because that was my white whale. I wanted to be a ham when I was a kid, but the code slayed me. So I became a ham, and one of the things I heard when I became a ham was, oh, you guys, you no code hams, you're lesser than. Not exactly those words, but the message was there. And I'm sure many of you have heard that. Hopefully nobody in this room has ever felt that way. But I think it also makes you a much better operator. I know since I started learning CW, I really had to find ways to use my radio to my advantage, to find signals, to be heard, to hear things, etc. So to me, I'm a better ham today because of CW, in my opinion. As I mentioned before, it was my white whale, and it took me about 50 years to achieve my dream of becoming a ham. And within about 3 months, I had all my licenses. And I was fine with phone, I was fine with digital, because I was never going to learn that CW. I couldn't, right? I just couldn't. Then I discovered Parks on the Air a couple of years ago. It's like, oh, that's kind of cool, but I'm lugging my 7300 out into the wild. That's not really cool. So finally in 2023, I went face to face with my demons. I had heard of LICW through multiple avenues. Some folks that I know that are members today, they were in other associations that I was familiar with. They went to LICW. I heard Howard on a podcast or a YouTube video or both. I said, all right, why not? And for a lifetime membership of $90, I said, it's a slam dunk. If I can learn CW, it's worth the $90. So I joined as a lifetime member in January of 2023. And within 7 weeks, I had my first on-air QSO. One of our instructors, W4EMB, Ed Bennett, he does a YouTube channel himself. He was one of my instructors. He said, get into this Zoom room, turn your radio onto this frequency, and from there we got through the QSO. It was not pretty. I guarantee it was not pretty at all. And then, just as an aside, I heard a really slow station just a few kilohertz away. So I tuned that. He was calling CQ, and I recognized that. So I went back to him. And I think we had a QSO, but I don't think I've ever seen him on the air again. I think I scared him off. Anyways, another advantage of it is you get to expand your available partners. There's a lot of folks on this panel that don't even have a microphone attached to their radio. So there's a lot of hams who are CW only. And if you learn CW, you can become a QSO partner with them. So that's really cool. The other thing is you get a lot more distance because of the power density. So if you have a 100-watt signal going across a 3 kilohertz spectrum on sideband or a very narrow spectrum for CW, you got a higher power density. So that's really cool. A little less affected by QRM and QRN. Of course, QSB is going to get us all anyways. Those modern radios can pull out signals that aren't there, and I even found some things in my 7300 that were limiting on CW. 7300 is a wonderful radio. But in order to achieve certain things, I found a different radio. I'm not going to do any promotions here. The other thing is if you're in a park or say you're an evening operator in your home and you have someone in the house that's asleep, you can put your headphones on and you can just hear the clicks of the keys and nothing more. There's not voices yelling, calling and trying to pull signals out. It can be a very quiet mode, and it's great for parks, especially if you're a bird watcher, for instance, in a park. And finally, I think SOTA and POTA, along with the youth coming into the hobby, SOTA and POTA has really driven the advancement of CW. I'm just going to walk through a typical exchange, and just to show you how simple it can be, because we typically coach our students at least most of the instructors I know, if you're nervous about getting on the air, chase POTA. All you have to do is what's in green on the right side of the screen. So if I'm activating, I call CQ POTA, DE my call sign twice, once or twice, and the hunter, in this case, Mike N1CC, all he has to do is send his call. I respond with his call, a polite thank you or good afternoon, to give him a signal report, where I am, Minnesota, back to him. All he has to do now is know his call sign, recognize his call sign at the speed I'm sending, and be able to send BK, UR 599 or whatever, and where he is, AZ or IN or wherever he might be, BK. That's it, he's done. That's how easy it is, and it's a very low intimidation factor way of getting on the air for a new CW operator. And most good POTA activators will slow down or at least space out the characters to try to get those folks into the fold. So that's all we have to do, and then a nice little polite dit at the end, or EE. Now, when we go to a formalized exchange like Straight Key Century Club, which Kathy is the president of, there's a little bit more formality for an official exchange. We add in the name and our SKCC number. We also have an LICW exchange, same thing, name and LICW number. So you got a little bit more to copy, but it's all good. Or the very bottom one on the left says Standard QSO Protocol. And that's where after you do the RST and the QTH, you usually say your name, and then you'll talk about your rig and your antenna and the weather, and then at some point there's a nice little polite goodbye. So that's the simplicity of getting on the air. Now, if you want to ask about, is it hard to learn? It's going to take time. It's not hard to learn, it's going to take time. And butt in the chair, as we like to say, in the instructor ranks, is the key. And you can't overwhelm yourself. You can't sit there 7 hours a day. And I've had students say, well, I practice 8 hours a day, 5 hours a week. I said, go find something else to do. You're spending too much time at the radio. You're going to burn yourself out. But practice, practice, practice. And we have a lot of techniques. We have a lot of experienced instructors, much more than me, that will be able to give you some suggested practice drills. You'll probably be on the air in 4 months or less. Now, some people have things in their life that come in and kind of disrupt things. Or some people can do it within a few weeks. I've had students that are doing a dual track of our Beginner's Carousel 1 and 2, which Mike will talk about, at the same time, and they get there faster. And you don't have to. You just put more pressure on yourself. But to really become fluent, it's going to take a year or so of practice, if not more. So with that, I am going to turn back over to Mike, and he's going to give you more information on our curriculum and how we arrived there.
Thank you, Don. Today, I'd like to give you an overview of our teaching methods and their origins. And to do that, I need to take you back to 2018, when our club was founded, really with a goal of just teaching some local hams on Long Island Morse code so that they could be CW operators in the following year's field day. Our two club founders had to stand up a training program almost overnight with very limited resources. One of them knew of the G4FON trainer, which has teaching methods and a character sequence attributed to Koch. So they adopted the G4FON as the club standard and began teaching with it. Now, one of the limitations of the G4FON is that it is not able to produce a CW character sound at any speed under 20 words per minute. It's designed to be used in what's commonly referred to as the Farnsworth method. And this is where a relatively fast character speed is used, but then additional spacing is added between the characters to bring down the effective speed. They were teaching at 20/5. That's a 20 word per minute character speed and a 5 word per minute effective speed. And they built the club to almost 1,000 members teaching that way. But by 2021, we had significant concerns after observing some student behavior and student performance. Too many of our students were stagnant and unable to progress to the intermediate level. They had become dependent on this exaggerated amount of time between the characters due to the Farnsworth. One of our instructors coined the term the Farnsworth trap. And it certainly felt that way. But we also knew that there is no Farnsworth on the air, so we weren't accurately preparing our students for what they would experience when they made their initial CW contacts. So we decided to take a clean sheet approach and develop a new beginner's curriculum. We began with research. We collected every historical document that we could find related to learning Morse code. We read and analyzed each. These are some of the more significant. Many others were interesting, but not directly applicable to our curriculum development. We took what we learned from the historical documents and we combined it with our collective experience, now having taught hundreds of students Morse code. And we concluded that there are many different ways to learn Morse code, and there is no clear consensus on an optimum method. But there is no shortage of strongly held opinions on the matter. Just ask any ham. The bottom line is this: if you are under the age of 18, or if you're an adult student with a high degree of aptitude for learning Morse code, and by that we mean you likely have musical talent, and you would score high on the Seashore battery of tests in the areas of pitch discrimination, tonal memory, and rhythm. If you're in one of those groups, it doesn't matter what method you use to learn Morse code, you are likely to achieve proficiency. But for everybody else, the method does matter and could be determinant in whether proficiency is ever achieved. Our goals in developing our teaching methods were to give the average adult student the best opportunity for success, to achieve proficiency in Morse code, to get on the air in a reasonable amount of time, and to do it all with maximum flexibility, taking into account that our students have busy lives, other responsibilities, and holding them to a fixed class schedule could be overly restrictive and thus counterproductive. All right. So let's take a look at some of our teaching methods and their origins. Of all the historical documents that we read, the one with the greatest influence on our teaching methods was the 1936 report by Ludwig Koch from Leipzig, Germany. This was a very difficult report to read and understand. For starters, it's written in an old technical German, but even after professional translation, it was extremely challenging. And that's likely the reason almost everything we had ever read about Koch turned out to be inaccurate. And we'll give you examples of that today. If I were to summarize the Koch report, it's that CW characters should be learned as single acoustic sounds and not by reference to a visual chart, what Koch referred to as the analytic method. And Koch developed several techniques to amplify the acoustic nature of the CW sounds. For example, he would play those sounds for his students without telling them what character they were associated with. And he would ask his students to mark a piece of paper with a dot every time they recognized that sound. For example, he would play did-dot-it, dot, did-dot-it, dot. And it wasn't until that sound familiarity was firmly established that Koch would tell his students, did-dot-it is an R, did-dot-it is an R. And from then on, his students would say and write the letter R every time they recognized that sound. Now, we thought this was innovative and effective, and so we adopted the Koch method of character introduction into our curriculum. And you'll hear a lot more about this concept of sound familiarity throughout this presentation. Koch experimented extensively with character speed. A full third of his report is devoted to it. Koch found that characters needed to be sent at a minimum of 10 words a minute to be perceived as a single acoustic sound, what he referred to as gestalt. And he zeroed in on 12 words a minute as optimum for initial learning of Morse code. Now, that wasn't his ultimate goal. Koch wanted to get his students to 20 words a minute, and he did. But when he conducted his teaching experiments with new students at a character speed of 20 words per minute, only those students with the highest degree of aptitude were able to keep up. The rest found it much more difficult. And so the Koch method is to establish initial proficiency at 12 words per minute and then ramp toward the goal of 20. And we thought that was quite consistent with our club mantra of preparing our students to get on the air, because so many initial contacts are in that 12 to 13 word per minute range. So we adopted Koch's recommended 12 words per minute for initial learning of Morse code. But remember that G4FON trainer that we were using, which purports to use the Koch method, is not able to produce a CW character sound at any speed less than 20. So we knew we would have to find a new trainer solution. Koch provided guidance for how a sequence of characters to learn Morse code should be created, which characters should be avoided being taught side by side, and what the distribution of difficult characters should be from beginning to end. Now, the real irony here is that Koch is best known for his character sequence. You will find the so-called Koch character sequence embedded in the most popular Morse trainers today, and we were using it. It starts with the letters KMR, SU. But we had become suspicious of this sequence because, quite frankly, we couldn't understand why anyone would develop an initial sequence of characters you can't even make words from. So we paid particular attention in studying his report in an attempt to validate the actual sequence of characters used by Koch. And as it turns out, he never provided it. But by applying his teaching methods to a series of exercise charts that he did provide, we were able to very accurately extract the actual sequence of characters used by Koch. There it is. Notice it does not begin with the letters KMR, SU. So we knew additional research would be required. And ultimately, we found the origins of KMR, SU. They date back to 1919 in Berlin, Germany, where Otto Lippmann was conducting his teaching experiments. And he published his findings in an article in 1928. Now, the significance of Lippmann's work is that he was the first to theorize one could accurately predict future performance in learning Morse code by how well a student learns their first few characters. And to 71 of his students, he taught what he called an obscure character sequence of varying difficulty, KMR, SU. And as it turns out, Lippmann was correct. Donald Taylor validated his findings in his 1943 doctoral thesis at Harvard. And to this day, the most accurate predictor of future performance in learning Morse code is how well a student learns their first few characters. But now that we realized we had been misled into teaching with an aptitude test, we decided to develop our own sequence of characters. And here, we took a cue from Samuel Morse and Alfred Vail. Now recall, as they were developing Morse code, they first determined the frequency of use of letters in the English language, and to the most often used letters, they assigned the easiest Morse characters. Our approach was similar. We determined the frequency of use of letters in the QSO protocol. And as Don mentioned earlier, the QSO protocol is how we communicate in Morse code. The more often a letter appears in the protocol, the earlier in our sequence it is placed. And this allows us to very tightly integrate QSO protocol and QSO abbreviations into the curriculum. And what that really means is that as LICW students are learning their Morse characters, they are also learning to communicate in Morse code. That's fine business. ARBK. All right. So now that you've seen some of our teaching methods and their origins, let's take a look at how they are applied in the classroom environment. We begin each class by introducing characters in the Koch method, but we introduce them one letter at a time. Yet everything we had ever read about Koch described a two-letter approach. And it's this two-letter approach you will find in the most popular trainers today purporting to use the Koch method. The two-letter approach is where two letters are introduced simultaneously. When 90% proficiency is achieved between those two, then a third letter is added. When 90% proficiency is achieved between those three, a fourth letter is added. And this repeats until all the letters in the alphabet have been added to the practice group. Now, admittedly, Koch wrote extensively about the two-letter approach. He developed it, and he was enamored with it. And one needs to dig very deep into his findings to learn that Koch had to, quote, reluctantly convince himself that that method did not work. And so we introduce characters in the Koch method one letter at a time, and no more than 3 letters in any 1-hour lesson as per his guidance. Once the new letters have been introduced, we ask our students to send them on a straight key, and in the absence of a straight key, to verbalize them in what we call code talking. This is a fascinating exercise because it provides a window into the mind of our students, since we have learned that the way a student sends a letter on a straight key or verbalizes a letter in code talking, that's exactly how they're perceiving that letter. And so, for example, if we ask a student to send an R and we hear dit, da, and dit, well, then we know they're still perceiving that as separate elements. And we will continue to work with that student until we hear them send it as did-audit, a single acoustic sound, gestalt. This is a great example of why we believe learning Morse code in a classroom environment with a live instructor is optimum. That way, students receive timely and accurate feedback so as to not practice and reinforce their errors. And you can't get that from an iPhone app. Once we are confident that the new letters are being perceived as single acoustic sounds, we transition to our sound familiarity model. Now, like Koch, we believe that sound familiarity is the foundation of recognition or copy. But unlike Koch, we have access to the Long Island CW Club's Morse practice page. This is a powerful web-based trainer which we developed in-house so that we could accurately and effectively support our teaching methods. We worked hard to make the Morse practice page accessible to our students with disabilities, and we proudly make it available free of charge to the world. In the sound familiarity exercises, the Morse practice page does all the work, and all our students need to do is sit back, relax, and assume what we call a loose focus or laid-back copy. This is a relaxed state of mind we consider optimum for learning Morse code. In the sound familiarity exercises, the Morse practice page voices what it's going to send and then sends it 3 times in Morse code. For example, it will say R and then play did-audit, did-audit, did-audit. R, did-audit, did-audit, did-audit. Now, most students only need a few minutes of that, but others may need longer. And it doesn't matter because we ask our students to take as long as needed until the sound of that character automatically conjures up the associated letter in their mind. Then they can transition to recognition or copy. And here, the Morse practice page turns the exercise around, now playing the character in Morse code. And our students are asked to recognize it and verbalize it before the practice page voices it. We call that beat the computer. And throughout the beginners, intermediate, and advanced curriculums, our focus is on the interval of time between when the character is heard and when it is recognized, because that is the true measure of proficiency in Morse code. The goal being the quick, the accurate, and the effortless recognition of characters, which is commonly referred to as instant character recognition. And or ICR. And just as important as ICR is the sister skill of IER, or instant error recovery. And that's the ability to miss characters without dwelling on them, so as to not have a negative effect on subsequent copy. So, now you have seen how we introduce characters in the Koch method, one letter at a time. Why we utilize a 12 word per minute character speed for initial learning of Morse code. The sequence of characters that we use based on the QSO protocol. How we ensure the new characters are being perceived as single acoustic sounds, gestalt. How we establish character sound familiarity before transitioning to character recognition, with a focus on time to recognize, the true measure of proficiency in Morse code, and not dwelling on errors. And we do this methodically with each and every Morse character. Combined, we refer to this as the LICW method, and we believe this method affords the average adult student the best opportunity for success to achieve proficiency in Morse code. Now Howard, Don, and some other friends will tell you more about our club.
Well, I know Mike doesn't like when I say this, but I always have to. You can see he's grimacing already. When we started the club, as Mike said, we were using G4FON, and that had, you know, the system of sending the CW at a high speed, but a slow rate to receive it. And I thought, who were we to even consider to change the way CW has been taught over the past 30 or 40 years? And we continued with that. But then Mike came along and started to say, well, maybe our success rate is not that great because we don't have the volume of people transitioning from beginner to intermediate that we would like. So Mike took it upon himself to do the research. Mike was the #1 FedEx International pilot before he retired last year. And one of his skills was writing trading manuals for FedEx. So he knew something about doing research and teaching people. So he took it upon himself to read all these historical documents from the 1900s in Morse code. And why did we have to go back to before World War I and during World War II? Is because that's when they really needed CW operators back then for the war efforts. And there was only really a success rate of about 30% of everybody they kind of brought into those schools. So these scholars were trying to figure out, especially the Germans, because they were getting ready for war before us, how can they really teach Morse code effectively? So this was written in a high technical German. And when we had it translated, I looked at it, I said, I wouldn't be able to read this in English in a million years. But Mike sat down with all of this stuff and brought it to our committees, and we reviewed it and rebuilt the entire curriculum in committee about this. And I must say that nobody has really attempted to rewrite how CW was being taught in the past 30 or 40 years. So what he just told you in 15 to 20 minutes is a result of thousands, and I mean thousands of hours. And I really salute you for that, Mike, and that's why I have to say this in front of the audience today. I had really nothing to do with it. It wasn't me. Thank you for that. Okay, so now a little bit about our club. We were founded back in 2018, and why did we get started? At Field Day in 2017, we realized on Long Island there weren't enough CW operators for field day. And we all know that you get 2 points in field day for CW versus sideband, so it's very valuable. And I was at one club, and I was there like 14 hours straight with headphones on, and I got cauliflower ears, and I said, I can't do this again. So I went to my friend Rich, K2UPS, and I said, how about we give back and we start teaching CW on Long Island and grow some more operators? And he said, yes, right away. Well, we got started, and I went around and I strong-armed everybody I possibly knew from the 3 largest clubs on Long Island and came up with 52 members. And I thought at that particular time, we were finished, and that was going to be it. But then we found out about Zoom, and I realized that with Zoom, we didn't have to have a brick and mortar place for a club, which would have been difficult on Long Island because everybody was from all over the place. And then COVID hit, and we had a captive audience because everybody was locked down, and it exploded. And right away in the next year, I think we had 1,000 or 2,000 members. And since then, we've been very fortunate to have taken in over 8,000 members at this particular point, and we have a net retention of 6,500, which means that we get a little bit over 80% conversions to lifetime, so people do stay with us. So people are coming in about 150 a month still, so there's quite a bit of an interest in the club. We have members in all 50 states, and at this particular point, 68 countries. We have over 100 instructors, some of them here on the stage, and we have 168 classes per week on Zoom. That's 168. We started off with one Zoom room, now we have many. And we also have classes. We started classes in Spanish a few months ago. We have Spanish classes on Saturday and Tuesday. So how are we structured? What's it all about? In this organization, we have no officers. I'm not president. I have no title. We have no board. So then you're probably thinking, well, how do we do it? We're organized from the bottom up. So our pyramid starts from the bottom up. That means we recognize all the members, and we're interested in hearing their participation and their feedback. And we seriously consider anything that's brought to our attention. So we don't lead from the top down, where the ideas of the club are only centered in the minds of a few people. It's bottom up. And some of the basic tenets of the club, besides our mantra of getting students on the air quickly, which we like to do within 3 to 4 months of their joining, is that it's very important for us to have mutual respect and kindness among the members. Nobody on Groups.io is allowed to criticize anybody else. We have also Facebook and Discord and all these type of social media channels, which are watched very carefully. And we want to make sure that everybody's very supportive and understanding of each other, and nothing controversial or political is ever raised. And I'm very pleased to say that very rarely do we have to take any type of disciplinary action. And you'd be surprised that the vast majority of people will default to kindness if they're involved in that type of organization. Okay. One of the most important things of our club is our participation of YLs. I also thought when we first got started that I would be blessed to have 25 YLs. That was my goal. Just this week, we hit 400. The 400th came in. We wanted to have that before Dayton. And today we have 2 of our senior YL members here, senior members of the club, that will say a little bit about the program. Ann, would you like to start off?
Hi, I'm Ann, KC9YL, and drove in here yesterday from Wisconsin, where we still had freeze warnings last week, so this is kind of crazy weather for me. I host the Monday night open house. Originally, there were a YL instructor that taught actual learning the code classes. We kind of have morphed that into just a YL open house, and the members show up and we talk about whatever needs to be talked about that week. We don't do any sending or receiving practice. It's just an open discussion, and we share tips and tricks and our experiences. We recommend classes if people need them. Talk about POTA activations that people are doing, just whatever's going on in the ham world, and we share our experiences so that we can learn from others. I have about a 10 to 12 that kind of people show up every week. New people come and go. Some people can only show up once in a while, so it's just whoever shows up, shows up. It's a small enough group where we can all keep our microphones open, and we just kind of make it a nice little chat session. We started a WhatsApp group several months ago. It was originally POTA focused on activations that the gals were doing, and that sort of morphed into just an open discussion. And we also have now a makers group offshoot of that, where some of the ladies are making kits and making their own radios and antennas and whatever. I send out a weekly recap that includes items of general interest, contests that are coming up, activities and special events that are coming up, and talk about QSO parties and whatever's on the schedule for the following week. We have several YL instructors. We've got Kathy, W4CMG up here, and Katie, KE8LQR. They both teach the kids classes, and Kathy also teaches the essential operating subject. So join LICW, and ladies, show up at the Monday night open house. Thank you.
Okay, I think one thing that's very important is that you realize that when you are talking in CW, you're talking with your fingers. No one knows that you're a YL unless you happen to send your name. And to me, that's very important because, you know, honestly, you can have a great time, you can have a good conversation. Many of my conversations, because I'm an SKCC marathoner, so we talk for about 60 minutes minimum, you can really find out a lot about people, and until you hear their name, you have no idea whether they are male or female. And that's important because it takes one more step away from, you know, highly political, you know, male versus female or whatever. So I find it very enjoyable. I think one thing that is also important for folks to realize is that the women who are part of the group, they do have an opportunity in Ann's class to go and talk about things that maybe they don't feel quite comfortable talking about, as far as, you know, for example, a friend of mine made an antenna for me, told me I needed a counterpoise. I didn't want to say, hey, what's a counterpoise? All right. But it gave me a safe space to go and ask somebody and not feel totally dumb. And so it just gives that extra little piece. Within Ann's class, very frequently I'll pop in and give a little bit of information about different things that I'm involved in. We talked about SKCC and a number of other groups that I participate in. And what it actually does is helps people to get interested in other things within and outside of Long Island CW Club, but it also gets people on the air. Anybody who participates in my class gets told 1 QSO a day, hopefully more, but if I miss a QSO every day, on a given day, I have to have 5 the next day. That's why I'm an active contester, because man, I'll tell you, we just got back from a cruise. I had a lot of QSOs to make up for. Okay, and I'm gonna give it back to Howard.
Okay, thank you, Kathy. Kathy's also the president of SKCC. SKCC is a very strategic partner to ours. And although you didn't want me to say anything, Rob K6RB is here. He's one of the founders of CW Ops. CW Ops is also a very important strategic partner of ours too. Okay, so what's the club involved with besides the rote CW learning? We decided to design the club around having fun at the same time. So how do you do that? It's not necessarily more CW classes. So every particular day, we have a different type of forum and a different type of class besides teaching CW. Some of them are listing here. We have sending classes. We have classes that teach the traffic system. We have classes that teach about Internet CW. And we also have forums on Monday night about radio and related technology. Right now, they're teaching electronics. On Sundays, we have an antenna forum. Saturdays, we have something that I lead called the Boat Anchor Forum, where we get together and we talk about vintage gear. Wednesday nights, there'll be a CW Makers Forum, and right after that is a 3D printing forum. So all of these things combined all around the classes of learning CW create an environment that you want to come to and be part of, and we're very proud of that. And I think that's really the basis for how you have fun at the same time. We also have classes with hams that have disabilities, and I'll talk about that in a minute. These are a listing of some of the forums. We have people very interested in bugs and how to use them. It's a very popular forum every Tuesday late afternoon. People come in and they talk about bugs, how to use them, and their history. Bob is very involved in that. Okay, what about another important tenet of our club? You know, what would I like LICW to be remembered about in the future? What's the most important thing to me? It's not how many members we have. It's not how many classes per week we teach. It's what are we doing for those that are not as fortunate as the majority of us? What are we doing? Well, we have a lot of blind hams in our club. And how were we able to achieve that? We made our website and all our documents completely accessible to screen readers, every single thing. We went over that and we had some blind hams working with us on that. And they get together every other Monday night in a Hams with Disabilities group just to make sure that everybody's doing okay and if they need any help. And then early on, we decided to try and teach autistic individuals. And we had success, and you can see a video of this on our website. There was a young adult who does not speak and could not speak to his mother. We taught them both CW, and it's very touching to see them communicate to each other. And then we had success with another autistic student. But unfortunately, I reached out to the autistic community, but just couldn't get them to be interested in what I was proposing. It seemed to be politically a little bit more difficult. Maybe the parents didn't think that this is what they wanted their kids to do or whatever. So I said, what can we do now? Let me make this a little bit easier. So we came up with the idea of making a haptic vibrational device. Bob is going to hold this up, that delivers CW vibrations to the palm of your hand. And if you have any problem hearing, or even if you've lost all your hearing, you'll still be able to learn Morse code and hear it and feel it with this particular device. And we're very proud of this, and Rob K6RB actually helped us get the patent on that. So thank you very much for Rob. Bob, you want to say a few words about the device, please?
Thank you, Howard. And Rob, thank you for all of your help with our patent. Granted. So I'm a retired medical device engineer. I have loved electronics since I was a tiny kid. I love it a whole lot more when I believe it can make a difference in somebody's life. Okay, that's core to me. The club has the fundamental tenets that we are going to make CW accessible. We're going to support people with wide-ranging abilities, and that we're going to develop things from the bottom up. A few years ago, probably 3-4 years ago now, anyway, a while back, there were a group of people in the club who had the notion, look, a lot of us are gray-haired, a lot of us are wearing hearing aids. I like my phone X. And we can support these folks. We have an operator who used to be a law enforcement, and he'd operate CW in his cruiser. He couldn't operate CW at all anymore. He was no longer able to copy code. We have an operator who was a retired commercial operator, decades at sea, commercial stations, very, very high-speed operator. We've got contesters somewhere in our audience who find the device supportive. So at many different levels of people who have had the ability to operate CW and have lost it because of declining hearing, or who would be interested in CW and aren't able to because they can't hear it. There were a group of people in the club, starts from the bottom up, who had the notion of, let's come up with a device that does this. I got wind of that, I can help, and this is what came out of it. Okay, so this was an initiative that started within the club, within a small group of people. We saw it, we jumped on it. I promised Mike I wouldn't go into resistors and capacitors and networks and stuff. I will say just the following. This is an incredibly simple device. We didn't want to compete with Elecraft and Flex and all these other companies that have wonderful signal processing folks. So all the smarts of the signal processing, that's in your radio. This is incredibly simple. It will notice the presence of one tone, and with that tone, it will blink LEDs, it will vibrate, and it has an output on the side that you can use something else. Incredibly simple device. Okay, but it came about because of that recognized need within the club. Okay, Howard?
You know, I have to say something about this fellow right here, Bob. Our first protocol just didn't vibrate strong enough. We were dead in the water. And then Bob is, you know, a retired engineer for the medical field, and he said he can fix that. And I couldn't believe it. And within a few weeks, he came up with the right guts to put in that thing to make it really a strong vibration. Without Bob, it would have been finished. So thank you, Bob. It was a fantastic job. Just fantastic. And you know, that's what I mean about the club. These ideas, they don't come from me. I might have had the desire to want to help people with disabilities, but I never knew any. I didn't even use the word in my language about haptic. That came from somebody else. So if you listen carefully in the club, and you listen to the ideas and you recognize them, you encourage them, these things happen. Okay, kids program, very important. And, you know, like I said before, we're not getting any younger. And if you look around, most hams are 50 plus. So it's very important to have kids. And we have the leader of our kids program and one of our homegrown students here, Katie. So Bob, you want to take it and tell us about the program?
I would be happy to do that. How did we change the?
You just press this button right here, that arrow.
Okay. Hi, I'm Bob Katie. I'm W7JNM. And about 4 years ago, I started in the program, about 5 years ago, to learn Morse code. I had an Elmer that I've known for, I started late into ham radio, 40 years old. And so 40 years ago, my Elmer was a great CW operator. And he tried to get me to get into CW. And of course, nothing worked. Cassette tapes, CDs, nothing worked. And he finally joined the LICW, talked me into coming here, and I started my journey in CW about 5 years ago, and I love it. I got about to 12 to 15 words a minute, and something happened. I'm stalled there because of kids. I had 3 granddaughters. Of my 4 granddaughters, 3 of them got involved in the program learning Morse code from a gentleman that started the kids' classes. And one of them stayed with it. One is a general class amateur. The rest have dropped out like many of us do. But that's what got me going. And when the program became open, Howard was looking for somebody to take it over. And 4 years ago, a friend of mine, Ken, K7BXI, if you've heard him on the air, and I took it over. And it's been a wonderful journey ever since. We do multiple classes. We have one Zoom room, and different from the adult classes, we do multiple breakout rooms within our classes. So it depends on who shows up on a given day for class, what level they're at, and how many instructors that we have. And we try to tailor it to them and make the classes as small as we can. One of the things that's different, most of our kids are, I'd say 70% of them are homeschooled. And when they get into class, part of it is a social aspect for them. They've been in class all day on the computer. They don't want to listen to anything from a computer. They want to interact with people. So that became something that we had to take into consideration. And that ratio has basically stayed the same for about the 4 years that I've been with it. Still about 70% of our kids that are in class are homeschooled. We provide instruction in CW and other aspects of radio licensing, technology, and antennas. Our main focus, obviously, is teaching CW. But we get a lot of kids that come in, they're not sure if they want to be licensed. Some are licensed, some are want to grow and get up higher level licenses. Some of them just like the technical aspects and stay as a technician. But all of the kids, our only rules that we have are that they're there because they want to be. They have respect for each other, their instructors and their parents, and that they have fun. So we do it to have fun, and believe me, it's a joy to do it. We encourage and mentor the students in getting on the air as quick as possible, using POTA, SOTA, K1USN, and the Long Island CW Challenge. We instruct using a combination of adult instructors and student instructors. Our instructors are either trained by the Long Island CW Club for adult classes or have been through an orientation program, and the same with our student instructors. Adult and student instructors go through an onboarding class, and then we give them to one of our instructors as a mentor, and they learn from them. And one of the interesting things that's different in our classes is that a lot of parents and grandparents are in the class with their students. We have some that learn CW from us in the kids' classes. We have some that attend, and they're always in the background. So I know that if we have a breakout room and certain kids are in there, we know that there's a parent available. We're very concerned about security. We don't give out the Zoom codes for our Zoom rooms to anybody except the parents, the kids, and the instructors. And we are very careful about that in protecting them. Half of our students are women, are young women. We're very proud of that, and we have students all over the world. Most of them obviously are in the United States and Canada, but we have students in the UK, in Italy, and in Hungary. And we have instructors in Europe that work with them, or we have one instructor here in the US that works with somebody in the UK. We encourage our students to be involved in other aspects of ham radio. They don't have to be. We have some kids that join us, and that's all they ever do is learn CW. We have some kids that join us licensed already and get into it. And we help them if they want to go on. We find courses for them to take and help them in studying for their license exams. So I'd like to bring up Katie, KE8LQR. Katie started before I was working with the program, and so she started at the very beginning. My granddaughter was in class with her, and have her tell you about a little bit about her journey through the Long Island CW Club and CW. Katie?
Thanks. So like Bob said, I'm Katie, Kilo Echo 8 Lima Quebec Radio. I joined the Long Island CW Club in early 2020, right when the kids' classes kind of started. I was in like the first round of all of them, so it was still very much experimental at that point. But I learned CW through that. We probably got through 3 to 4 weeks of class, and I was on the air. So even though it was experimental, it worked out really well. After that, I went kind of through like the beginner classes, the intermediate, and then I was in the advanced when the guy who started them was ready to kind of step down from the position, and Bob and Ken took over. So when he did, he was like, hey, do you want to teach the intermediate and advanced kids classes, like since you've been through the program already? So I agreed to do that. I've been doing it ever since, so about 4 or 5 years now. I'm really, really glad that I took the CW classes when they started and everything. CW is now the primary mode that I operate. Like someone said earlier, I don't have an SSB mic attached to my radio most of the time, so yeah. But learning CW through this program was probably a much better way to do it than learning like from the tapes and everything that I had tried before. So I'm very glad that we have the youth program, that it still exists.
We're going to have some questions after. Good. Thank you very much for your time.
Okay. Thank you to everybody. And Katie, it's wonderful to have you. She's homegrown from right after COVID. And here she is, a young lady, and she's going to be studying in Germany next year. She's growing up, and she's a great CW operator. We've taught over 600 kids, 600. Many have gotten their licenses. So we're very encouraged about CW for the youth. Okay, why is this? All right. All right, when you see this slide, you've made it. You've made it through. It's the end. Now, before you play it, Mike, yeah. Let me tell you, anybody who knows me knows that I'm a original Star Trek fan and a Three Stooges fan. I still watch the Three Stooges today at 12 o'clock in New York every night. This is a great scene if you haven't seen it. This is real CW with a 1930s fist. And they're not sending any vowels, it's all consonants, but it's real. And to people like me, this sounds beautiful. And it's kind of funny at the same time. It's not what we do with our students because that's not how we teach, but here we go. Mike, where is the arrow? Is it? It's there. It's not going to play for us. You know, this has happened once before. What a buildup, huh?
Oh, it's not connected to the internet. That's.
Oh, it's not connected to the internet, huh? All right. Well, I gave it a good build-up, and you can see it on the internet, or you can go to our website and see it. Okay. Well, thank you, everybody. We like Q&A. I know it's very hot in here, and it's been a long presentation, but we enjoy the Q&A a lot more than talking. So if there's any questions, we'd be more than happy to answer them. Let's go, ladies. Oh, thank you very much. Yeah, 1 second. Ladies first. The young lady in the blue shirt.
Okay, a question for the SKCC president. Okay, I have read about that, and there seems to be a couple of differences of opinion. I have read that you prefer that if somebody is doing a QSO, that they use the straight key. And others said, no, it doesn't matter, you can use a paddle. So the straight key hurts my wrist. So I've discovered I really can't use it all that well. I've tried between the straight key and the paddle for months and came up with a paddle better. Does it make a difference?
Yes, it does make a difference. However, I'm going to make you feel a little bit better, okay? You can use a straight key, which is up and down. I personally had some carpal tunnel surgery. I have a horizontal straight key, and so I can use that. It's called horizontal, and it's used just like a paddle, but it's one-sided. You can also use something called a side swiper or a cootie, okay? And you can use just one side or both sides of it. You can also use a bug. What you cannot use are paddles that have automatically generated code. So for example, just the paddles that I use for contesting, those, or for higher speed QSOs, those are put over to the side if I'm doing an SKCC QSO. It's got to be a straight key, a bug, or a side swiper, also known as a cootie. We have some over at our table. Come take a look, and I'll show you how to use each one. Okay, and you'll find that there'll be something that'll be able to help you.
Okay, very good. Young man over here.
What is the cost of the technology that you're using for the people that have visual impairments, hearing impairments, and also is there a possibility you have one device or something for people with abilities understanding more technology in their own program?
Okay, anybody with any type of disability or hardship gets an honorary membership, honorary lifetime membership to the club. So if there's somebody that qualifies for that, please let me know and we'll make arrangements. As far as specific things to help people, we do have this Hams with Disabilities class every other Monday night, and that would be a good forum for helping people. And if somebody needs any type of one-on-one instruction because of any type of disability, we're ready to provide that. Well, when you say technology, what technology? Oh, the haptic device? Yes, the haptic device is $275 delivered to any location in the United States. And if it's for overseas, we would price it at $255 FOB California plus whatever freight it would be to get it to the final destination. So that's the price. Why don't you come to the booth, our table, after this, and I'll spend plenty of time with you, and I'll answer all your questions, okay? We're at what, 4071? 4 what?
4107.
4107. We're in building E4. 4. Any other questions? Somebody in the back? Okay, young man in the red shirt.
For learning by sound, is there any studies that would suggest that would be, by vibration? So any studies that suggest that would be an aid to learning by sound? And also, have you ever considered vibration electric shock?
Did you say electric? Well, we thought of some people that didn't come to class to hook them up electronically and shock them accordingly. I do believe the haptic device would be very beneficial to people with normal hearing. The way I copy CW in 5 different ways at the same time, and one of them is paying attention to vibration. So I would enjoy that, but it would have to be a very personal decision, and someone would have to try it. But I do think it would be a benefit, yes. Any other questions? Yes, sir.
So I'm actually a junior in high school this year. I'm spending my senior year of high school there, so I'm not in a university. I'll come back to the States for college and everything. I'm not sure where I'll go yet. So basically my course load will just be normal high school classes, but in German. In terms of where I'll be, I don't have a host family yet, so I'll be just north of Frankfurt for about a month, and then after that I will go live with a host family somewhere in Germany, to be determined.
Any other questions? Yes, sir.
Camped out in USS Massachusetts, they had a Morse code class, and they only used the letters 7 letters with only dots and dashes, he got everything correct. So I'm thinking maybe this would be a good exercise for him. What's the process? What am I going to have him go into?
Well, you know, right now, we're not teaching autistic students because, as I mentioned to you, unfortunately, that program didn't get off the ground, and we put all our efforts into the haptic device. But if he'd like to learn, we'll make some sort of accommodations with him, with a one-on-one instructor, and see how he does. How old is he? How old is he? No, he'd have to be with the adults. At 25, it has to be with the adults. And we'll see how he does one-on-one, and if he would be able to be in the regular curriculum, the regular adult classes, we can try that too. We don't really want to isolate him. Liked him to be a part of the community and see if he can do it. He probably can. I believe those people can. You know, they have certain innate abilities that are far greater than the majority of us, you know?
13 or 14 when he was doing this thing at the USS Massachusetts. Yeah, just sitting there watching him copy.
Good point. Come to our booth and talk to us further about it, all right? No, come to talk to us more, okay? Any other questions, comments, anything? All right, I guess that oh, yes, sir.
Next time you watch it, look at Larry Klein's right hand and look the way he holds his fingers. Larry was quite an accomplished violinist. He may have known code. We don't have any evidence in the industry supporting us, but who knows?
No, from all my research, they had nothing to do with ham radio. This is written for them. Yeah, yeah. Okay, anything else before we go? All right, everybody, thank you very much for hanging in there. Okay, thank you.
Oh, okay, I just didn't want to mess up.
Oh, ma'am?
I thought that's what I didn't want to call you by the wrong name. I didn't want to sound so personal. Yeah. I had a great time back in those days. Yes, sir. You're welcome. Thank you.
Right. Yeah.
What I've done since in the LICW, progress quickly, because everything's already what ends up happening is you progress quickly, sort of that level that you're at when you kind of stop. But then you get there, we can take you all the way up in high speed delivery. Our attempts higher, intermediate, and advanced curriculum is a structured, comprehensive approach to understanding right. Some says, I'll see you in class. Thank you.
Yeah, I met you earlier on Bob's.
Yes, here you speak.
It's put a bunch of things together. I'm a professional sports fan. I'm not CWK. I'm president of the forum. So I'm trying to encourage that. We do a lot of super. Is there any chance you might? Mark, say my friend Lane.
Okay, well,
or however that works.
Okay, so you said Bob.
Yeah, Bob. Yeah, yeah.
Okay.
I'm sorry.
Just coordinate with Bob.
Sure.
He'll know to reach out to me or Howard, and then we'll coordinate. We limit the number of local events that we do a year, because otherwise we'd be overwhelmed.
Right.
But I'm sure we can find time.
Yeah, I mean, we're at the West Coast, so.
You just did it separate.
Oh, okay. Yeah, because I'm trying to encourage, and I think this kind of clicked on a lot of things, because I've been trying to, either get folks, to do the or some of it because of other things to do. And that thinking just sort of went bang, because, some of the people we put a meeting together, the first two meetings. It's like, we started security. Oh, and the other real quick question, you extend that same kind of recognition to
Yeah, that's what that is a common misconception.
Okay.
Pursuit of instant recognition is actually not. You can take my wife that doesn't know any more, and you can say, honey, when I send this CQ or 73, I want you to raise your hand. And in a couple of minutes, you'll raise your hand every time. And I said, that's it. She knows nowhere to go. Now, it's a work condition to happen by itself. And it's a nice thing that we all recognize CQ 73, QTA, TAG, call signs here. And that's nice because then you don't have to be in action. But the pursuit of instant work recognition as a way of ensuring efficiency is not anything.
Okay. So that's something that happens. Just happens by itself. It happens by itself. Okay. It's good to know because you don't necessarily it's just, hearing that, it was like, oh, I like to, it just didn't make sense because I was all right.
I look forward to it. So I'm really happy I came. It was really interesting to hear about researching very old sources. Reminded me of the research I've done for some other memory related, kind of like learning like Japanese or that's kind of a whole other story. I'm curious if you made any kind of research paper, anything to read or any. You go to our website, look at academics, you'll see a lot of we're very good and transparent our research, no secrets, but I've been asked to, why don't you write a book? I don't. That's not super fascinating. Then I wanted to comment on something else. You said like 18 and under. Here, everybody under 18. It's something I learned about a decade ago. The state of the field for language learning and switching, like foreign language learning, or learning a second language. After, instead of 18, like there's kind of this cutoff during the puberty where people most of the puberty have to have an accent. They can't really lose it, no matter how hard they study or practice. And that's like a brain ear kind of thing. Oh, well, accent. What they said was 100% of students under the age of 18 that are able to learn a second language without formal study. If a student does not learn that language at the age of 10, they will never speak it as a learner. Right, that accent. That's it. Yeah, interesting. But there was something I think that was it, yeah.
Thank you. There's somewhere in the materials that gets down into the level. Salt flow chart. What I'm supposed to do. I gotta dig down. Time frame. She needs to what was selected each ball. So I don't get to familiarity. I was focused on that. So I ran through that was going to be increased by screen just by doing faults. And you started getting into the little detail.
It's starting to it's not what you do.
Is there anywhere on the material that talk about the detail? I haven't seen what I'm saying.
Well, I mean, the purpose of the class is the instructor and the teacher how to do this. So your instructor how to use it.
They didn't show me what you were saying.
Oh, hello.
You're the next speaker.
Yeah. Life protection.
That was my only frustration. It's just awesome. I don't want to criticize it, but that was my only frustration. I go, I've got all this, but I don't have the detail that I need. I'm really entering the conflict. Everybody said I'm going to have trouble.
There's no reason you couldn't have these.
Those are all bad. I need to get off the stage.
Yep. Mike. Is that your
Yes, it is.
USB?
Thank you.
I want to take this opportunity. How are you? I'm on your lifetime member thing you can use.
I know that. I think that's your best.
Do you really?
Sure. I remember all those people from the beginning out.
Yes, it was the first time I saw it.
You stayed for the whole talk? Yeah.
Came in a little bit.
Was in here and checked. It's hot. I was told to look for you and see if it's not open. See about opening the door. So, yeah.
Maybe it's a firework.
Yeah. What the heck?
per repeater, $1,200 went out, and we didn't pay any of it after about 6 months. They pulled the plug, and they wouldn't give us our meter. So we ended up with a long, drawn-out multi-year lawsuit that ended up over 10 grand. And we got our equipment back. I had the board of directors that if I want to do an account of how much it's worth, I can tell the guy, yeah. It was a whole like that. Where I tell a friend of mine, he has nothing to do with property on. Way back in the power, helped out on it.
I'll wait a few seconds here for everybody to get in, then we'll start. They've been trying to get the air conditioning in this room to bring the room down since 11 o'clock this morning. So they've given up and they've opened up doors and we've turned fans on. If we need to open up more doors, we can, but at least it's a little cooler than it was an hour ago. Anyway, with that, we'll start. There's one slight modification to the schedule today. Bruce Sparrow, who's the engineer from Fairlight, is sick, so he's not going to do his presentation this afternoon. So I'll have Gary and Dan do their RF suppression first, and if there's time, I'll do a basic RFI presentation. And with that, I'd like to thank you all for being here. It's a little bit bigger crowd than what I'm used to, but I'll survive. Anyway, so I always start off with this picture. One of the interesting things is that first off, lightning does strike a place more than once. My tower at the previous house got struck at least once a year. The one repeater that I have gets struck almost every electrical storm. And so knowing how to deal with lightning will prevent you from having damage. And it's anywhere from DC to gamma rays. And I'm going to try to stay on the microphone, mainly because this is being recorded. It's also being live streamed. Wait a minute. It jumped all the way to the end. Yeah. For some reason, the page forward page weren't working. There we go. Okay, so one of the things I always try to tell everybody, and this is in the book that Ward Silver wrote, you should always follow your local electrical codes. If none exist, then follow your USA National Electrical Code, or if you're outside of the US, follow whatever your country's electrical code is. And you always want to be safe. Make sure what you're doing is electrically safe. The ARL recommends vacating your shack during thunderstorms, and that's a good idea. Also, I'm going to ask that you hold questions to the end for a couple of reasons. One, because of the live stream. Two, for the most part, whatever question you're going to ask, I'm going to probably answer in 1 or 2 slides anyway. And not to mention the fact that I don't hear worth a darn. And on the very last slide, you will find a QR code that you can take a picture or scan, and you can download the presentation. Okay, so the characteristics is a typical lightning strike is anywhere from 3 to 4 pulses per strike, anywhere from 10 microseconds to 170 microseconds. The first pulse averages anywhere around 18 kiloamps, with 98% falling between 3 kiloamps and 140 kiloamps. Subsequent pulses are half the current. Of course, we're in Dayton, and so I sort of target this presentation for the Dayton area. Dayton has about 50 thunderstorms a year. If you have a 75-foot tower, you're likely to have 1 strike a year. I had a 50-foot tower, and it took a strike once a year. So I can confirm that the 75-foot tower taking a strike once a year is accurate. And if I do any math in here, just to keep things simple, I'll use 10 kiloamps for strike energy and a 10 microseconds at rise time. And I mentioned before, lightning contains DC through gamma rays. The gamma rays were detected by a NASA satellite a few years ago from lightning strikes that they had recorded. So how I learned the hard way was in 1984, I built a new house with the builder being very cooperative. He dug the hole and poured the concrete for my tower base. And when the neighbors saw the hole for a tower, they came over and the first question they asked was, well, are you a ham radio operator? And I thought, oh, here it goes. But they said, well, that's okay. If you put up a tower, it's a lightning rod, and we won't have to worry about lightning striking our houses anymore. And so they went on to tell me that, like, the house 2 doors down had a strike through the roof and almost burnt down. One a block away had the chimney blown apart. And oh, by the way, the trees on your lot get hit almost every storm. So it's like, okay, it was high ground. I bought it because it was high ground, you know. And so the first 7 years, we had strikes every year, and I had damage every year. So I got a hold of the Polyphaser book, which is no longer being published, but you can find PDF copies of it randomly on the internet. So I bought that book, read it, implemented their system, and for the other 13 years we lived there, I had 0 damage. And so one of the things is, well, what is the cause of the damage? Is it voltage or is it current? Well, it's really both. And with current being the worst, because current can burn through conductors and everything else. So one of the things is the current develops a voltage across resistance. So if you've got poor resistance connections or inductance, that develops a significant amount of voltage, which then can cause punch-throughs. And the formula for calculating voltage across an inductor, that's what this bottom formula is. Here's a simple transistor circuit. And the reason why I have this in the presentation is what causes this transistor to fail? Well, what causes it to fail is if you have too much voltage across any of the 2 junctions, or any of the 3 junctions, that punches the transistor and it's gone. So one of the primary things to preventing damage during lightning storms is making sure everything is at the same potential and that you don't have any differences of potential. Now, the house that I mentioned before, this is what the grounding system looked like. Everything was grounded, but nothing was bonded. And this is the way, you know, if you go back into the 80s, power companies and things felt this was the right way to do things. And even though the National Electrical Code said it had to be bonded, a lot of electrical companies said, no, you can't do that. So, but the truth of the matter is what you really want to do is have something like this, where everything is bonded together. And when everything is bonded together, there is no reason for the current from the lightning strike to go into your house to find another path to ground, because the ground path is all outside, because everything's at the same potential. And one of the things I feel is one of the most important parts in stopping damage is single point grounds. And you'll notice a lot of these illustrations I've had in the last couple slides in this page are out of Ward Silver's book, Grounding and Bonding for the Amateur Radio Operator. And there's a lot of, it's very accurate. But anyway, this is, by having everything come in at one point, everything in your house is at the same potential. If everything's at the same potential, there's no current flow, there's no damage. And here's another example of how you can do it. The current house I live in, I had to do something like the second slide or the second image, in that I had to run a ground wire from the electrical ground over to where the cables for the ham antennas come in. And so that's an alternative way of doing it if you can't bring it all in at the same place. And a lot of you people have that same issue. Resistance can be both a friend and an enemy. And it's an enemy because if you pass current through it, you got a voltage difference. But on the other hand, it can lower current flow if placed in the right place. In a way, lightning protection just breaks down to plain old Ohm's law. However, you have to consider impedance, not just resistance, because inductance can increase your voltage. So it's impedance, not just resistance. And for example, a half-inch piece of coax, half-inch coax 100 feet long is about 51 microhenries. Tower legs are somewhere in the 5 microhenry area per 10 foot. Tower joint resistance is 0.001. All of those things lead to having a significant difference in voltage between the top of the tower and the bottom of the tower. I found a whole bunch of really good papers on grounding. That's in this link. If you download the PowerPoint presentation, you can click on the link and get to it. For ground rods, you care about what your soil resistivity is. So here's a comparison of what the different resistances are you will find throughout the world. And there's some are really, you have to get really excited about someone who's got a 200,000 ohm per centimeter resistance. It's going to be really hard to deal with lightning. So as for grounding, typical grounding requirements is the National Electrical Code wants you to be below 25 ohms. The national, the IEEE standard 142, it depends. Standard 1100 is 5 ohms. Motorola wants 10 ohms. Verizon's standard is 5 ohms, and the typical telecom switch is 2 ohms. So if you want to calculate what your resistance is, on this page it's got the formula, and this is based on a single ground rod, and it's out of the Military Handbook 419. And so if you have a soil ground resistance 5,000 centimeters per 5,000 ohms per centimeter, resistance to earth is 20.67 ohms for a standard ground rod. If the soil resistance is 2,500 ohms, then you're down to 10.34. If your soil resistance, if you're lucky and your soil resistance is down to 100 centimeters, then your resistance to earth is 0.41 ohms. But if you pass 10,000 kiloamps through that 0.41 ohms, you got 4,135 volts across it. So even a small amount of resistance can be hazardous. If you have 3 ground rods, they've got the 0.14 ohms resistance, you then have 1,378 volts at the top of the ground rod. And it's just the top of the ground rod. So here's some ways you can improve the ground. You can have multiple ground wires coming off each tower leg, going to multiple ground rods. The last house, I had 2 ground rods on each tower leg. And so what you do is you've got an 8-foot ground rod. You put the first one in, you put one at the tower leg, you put another one in that's 8 feet times 2, 16 feet out. And then if you want another one, you go another 16 feet beyond that. Inductance can sneak in. These pictures probably don't show up that well, but if you look at the, let's see if I can turn the laser pointer on. Right, this ground wire comes over this way, takes a 90-degree corner, comes down to the concrete, takes a 90-degree corner, and then over to the ground rod. Well, each of those really nice-looking 90-degree angles are a significant amount of inductance. You don't want to do that. You want nice, slow curves on ground wires. Any kind of 90-degree turns to make it look neat, you're adding inductance and you're increasing the voltage involved. Just don't do that. But like I say, it's good for DC, but it's not good for RF, anything above 100 kilohertz. And in this case, the inductance on a 90-degree bend is 0.15 microhenries. 6 inductors in this particular tower leg makes a total of 0.9 microhenries. And using the formula I mentioned before, the 10,000 amps in 10 microseconds, you got 900,000 volts at the bottom of that tower across that ground wire. Here's just another method of grounding a tower. What gauge for the ground wire? I sort of thought it was nuts, but NEC recommends at least 10 gauge, but for antennas, 14 gauge. Polyphaser recommends the use of 10 gauge. Lord Silver recommends 6 gauge or 2 gauge. Motorola recommends 6 gauge. Mike Holt says 6 gauge. My power company uses 6 gauge. I currently use 4 gauge. But you also have to consider skin inductance, skin effect inductance, and resistance. Al Torres, KP4AQI and SK, likes to take old power cables, old Roma cables. He takes the 3 wires out of it, twists them, and uses that for a ground wire. And one of the reasons why it's not really, the 14 gauge isn't that bad, if I come across here a 14 gauge, it can handle 1 strike at 187 kiloamps, which if you happen to have multiple strikes, it might be a problem, but it will handle 1 strike and survive. So that's why you can get by with 14 gauge. Always use coax protectors. For VHF and up, I use quarter wave shorting stubs. The advantage of quarter wave shorting stubs is they can take strikes all day long and they'll never fail. But you can only use them if you're talking about a single frequency, single band, and they're too darn big for build for HF. Guy wires need to be grounded. Here are some more examples of bonding options. And one of the questions I get is, does it work? Yeah, it does. I don't know how well this shows up, but you can see the black on the transformer right there. And there's it's not the greatest, but over here this is the connection to the grid just hanging off in midair. That was a direct strike to that transformer, blew it off the grid. I had 0 damage inside the house. The house is basically to the right of that transformer and about 20 feet lower in height. And so, I mean, that was a direct strike, no damage. But everything in my house is all bonded and grounded, and so I don't have an issue. But the inside is also bonded and grounded, which Ward Silver is going to talk about. So not only have I done the outside, I've also done the inside. And all of this actually goes to help control RFI, which Ward Silver is going to be talking about. And, I got stuck this in, I forgot about that. I've been asked about the ICOM 905, IC905. In my mind, the IC905 was designed for rovers. It wasn't designed to be a tower installed radio. If you're going to mount it on a tower, treat it as you would a mass-mounted preamp or a mesh Wi-Fi device. And you'll see in their instructions they talk about grounding it. I would mount the RF unit up on the mast, close to the tower top. I would run a ground wire from the ground terminal of the RF unit to a clamp on the tower leg or mast. And the general intent is to keep the antenna and the RF unit at the same voltage level as the tower at that point. Depending upon the antenna, I would use a Nextech coax arrestor similar to the PT-CON XON F20G. It's good to 20 gigahertz. I would also mount 2 Ethernet protectors, one up at the unit and one down at the ground. And once again, I have part numbers. And once again, follow his guidance in Ward Silver's presentation for the control unit. The references for this lightning protection came from Polly Pazer's book, came from Ward Silver's book, and from a few pages on the next few pages. And there's a whole bunch of links on the next few pages. If you download the PowerPoint, you'll have access to all of this. So I'm just sort of bouncing through these, a whole bunch of different links. And I wanted to say also thanks to Ward Silver for providing images for this presentation. Dr. Al Torres, KP4AQI, for his additional information and review. And the reviewers were John Monteith, WYXD, Ward Silver, and AX, and Dr. Al Torres, KP4AQI. And here's the QR image if you want to download it. I've also started to build on this miscellaneous page. I started to build a spreadsheet for coax losses. If you're ever looking for information on coax losses, little by little it's being built up. But if you take a picture of this QR code, it should allow you to download my presentation. And for the first time ever, I actually finished this in less time than I normally do. So Ward's going to get his normal amount of time. Thank you for listening. This is Ward Silver, N0AX. Thank you. Let's see.
There you go. That was a really good tip by Al Torres. I mean, we're all ham radio operators. We haven't thrown anything away in maybe 40, 50 years. And so all that Romex that you couldn't bring yourself to throw away even 1 foot, it's all in a box in your garage. I know it is. And this is a perfect application for it. So you can wind it up, you can do whatever. So save you some money. Okay, my book covers AC safety, it covers lightning protection, and it covers RFI in the shack. So this part of the talk is going to cover the 2 second parts of the book. And also, as long as I'm mentioning books, Ron Block, who was one of the Polyphaser, he wasn't a founder, but he was an early employee there. He's written a new book that's available called Lightning Protection for the Radio Amateur. And he goes into great detail on lightning protection, and it's available online. I just wrote a review of it for QST, so that's the ordering information is there. It's very good, and Ron also wrote a couple of the really good articles that are in the ARL website. So, in-station bonding for home HF stations. There's my favorite book, and Ron was one of the reviewers for the book, and it was the reviewers that really added a lot of value. Ron Block, Jim Brown, Dale Svetnoff, WA9E&A, the ARL lab, all those guys contributed quite a bit to making sure that the advice was correct and complete, and I didn't give contradictory advice in different parts of the book. So it's not a cookbook. This is too complicated. Everybody has different circumstances. It's a toolbox. So we talk about the tools and how to use them, and then you go home and you go, okay, well, what am I going to do? And how much money do I have? And how much can I get away? I mean, no, anyway, how much can I do at my station? So that's what you do. Okay, so let's talk about bonding. All that bonding is a connection intended to keep 2 points at the same voltage. That's it. You go look it up. Even in a sophisticated professional dictionary, that's what it is. And so Jim touched on this, and you'll see me do this a bunch of times. Everything goes up and down together. And when everything goes up and down together, you don't have voltage differences. What causes current to flow? Voltage differences. So if you don't have voltage differences, you minimize current flow. And that's true for AC safety. It's true for lightning protection. It's true for RFI. It prevents shock hazards from voltage differences. If you have a fault, a short or something in your shack, and everything is connected together and it's connected to the safety ground, then everything stays at the safety ground voltage. So it prevents electrocution and lightning surges, as Jim alluded to. When you get a lightning current
And I don't know about you, but when people start talking about kiloamps, I get nervous, okay? I'm a circuits guy. I'm not a power guy. So kiloamps, that's a lot of energy. So these current surges, if you have everything bonded together and you get a big current surge through it, you still minimize the voltage difference. And the voltage difference is what drives the current that causes the damage. So bonding minimizes destructive voltage differences. And it limits current between devices, even if you're not getting hit by lightning. You're out there, you're transmitting or something like that, you still got RF coming into your station, and the station will pick up all kinds of RF, and RF voltages are what drives the current, and the current is what causes RFI, current getting into something that it should not get into. That's what RFI is. It's not the voltage, it's the current. So if you minimize the voltage, you minimize the current because everything's going up and down together, and it really helps for RFI. Okay, is bonding hard? It sounds hard. That's like you got to use fancy stuff and expensive materials. It's not. It's really easy to do. Once you figure out how to do it, you go, that's a no-brainer. I can do that. But you do have to use the right connecting materials and hardware. None of them are very expensive. And when you do the bonding and you do it right, you can work in your favor for all three of those types of requirements: AC safety, lightning protection, and RF management. You don't have to build one system for AC safety, one system for lightning protection, one system for RFI. If you do it right, one ring to rule them all, you save yourself a lot of trouble in all three of those domains. Okay, for bonding to work, it has to be low impedance. We talked about that a little bit. And it has to be electrically short at the frequencies of interest. At AC, the wavelength is like 50 million meters. So short can be something the size of a football stadium, but when you start getting up into lightning's upper ranges and RF, then the wavelength is much shorter. And for something to be considered electrically short, it needs to be much less than about a 20th of a wavelength. So 20 meters, what's the wavelength of 20 meters? Trick question, not all at once. Okay, 20 meters, 60 something feet, right? So a 20th of a wavelength is about 3 feet, and you want it to be much shorter than that. So if you're going to have a bonding conductor and you're going to expect it to work at 20 meters, it's got to be much less than 3 feet. None of these big, long 6 foot, 10 foot things. It also has to be heavy enough to carry the expected current. If we're talking about lightning protection and we're talking about kiloamps again, it has to be fairly robust, and that's why you have to use number 6, number 8, number 10, number 2, whatever. If you look online, there are some really interesting YouTube videos about what happens when you run really high current through conductors, and the Coulomb force, which is this magnetic force on the conductor, can be hundreds of pounds per foot on these things, and the wires will rip themselves out of holders and walls and move around under these stresses, mechanical stresses. So the wire has to be able to stand the load. It has to be able to carry that current without turning into a nice green lightning bolt, and I think we've all seen that, okay? And it has to be sturdy mechanically enough to get hit and not tear itself apart. And also, if you're outside and you're burying things, it has to be sturdy enough to survive the environment, which means you're going to drive over it. You're going to dig it up accidentally. You're going to trip over it. You're going to dig it up with the rototiller. Don't ask me how I know that. Okay. And so it has to be heavy enough to survive those mechanical insults. Frost heave is another problem, and you don't want that to break your ground connector. There's no real visual indication that says, oh, my ground has been broken, but you may not have a ground. You may not be connected the way you think you have to be. So you have to use heavy direct connectors, and that's why your building codes specify number 8, number 6, number 4. It's not just to buy copper, it's so that it will survive in the environment. Inside your station, what do you use for bonding? The commercial military standard is a copper strap that's 20 gauge, meaning the thickness, and about 1 inch or 1.5 inches wide. You will see wider straps and heavier straps, but what the basic lowest common denominator is a copper strap that's 20 gauge. You can use number 14 wire as well. That Romex that's under the garage workbench in the box, that's perfectly good. If the strap gets too wide, a similar effect to skin effect takes place, and the current is pushed to the sides of the strap. So once you get beyond about an inch or an inch and a half, you're not doing anything but buying a lot of copper. You can use the flat weave tinned braid that you can find at auto parts stores and various places like that. It's the silver stuff with about half an inch up to about an inch. And that works really well. You can use that if your equipment's got to move around or in a mobile station. Remember that you don't want to use exposed braid from old coax. Why is that? Okay, it's got a plastic jacket that goes over all the nice little braided wires. What is the jacket's function? It's to hold all those wires together very firmly and to keep them away from oxygen and water. And those two things will degrade copper. So if you take the jacket off, you've got this old piece of coax, you go, man, that'd make a great ground strap. Okay, don't do that, because you take that jacket off, the instant you take it off and you loosen it to get the center conductor out so you can use it as a high voltage connector. I do that. Okay, you've already loosened up all these little connections and they start degrading. So it looks nice, but eventually it starts becoming worthless. It's a noise generator, and always keep your braid dry. Water is the enemy of any kind of braid. So protect your braid, leave it inside the jacket if you want to use that old piece of coax, and just waterproof it on each end, put a terminal on there, and it becomes a very fine BAW, big ass wire. Okay, and just use that piece of coax as a big grounding wire. Okay, here's our single point ground panel. This is a typical single point ground panel. This is from the second edition of the book. And you can see it's just a big metal panel. It can be aluminum, it can be copper if you want to spend the money, but basically it's typically where the cables come into the house. Some people put them in a little garden shed or a truck toolbox outside, whatever, and you bring everything to this same point. Hopefully it will be close to your AC safety ground rod. Then that's usually standard construction now, but it seems like with hams, it's federal law somehow that your station is all the way on the other side of the house from the AC panel. But anyway, you put everything on this panel. All of your arresters go on this panel. Your lightning arresters for feed lines, your data, your phone, all that kind of stuff, and even an AC power protector is mounted on this panel. And then you've got the cables that come into it are unprotected. Those are the ones that are exposed to lightning. Those are unprotected cables. And then the ones that are on the other side, the downstream side of your protectors, those are protected cables. You want to keep the unprotecteds away from the protecteds. Even though it looks nice to bundle them all together, if you bundle them all together, lightning will jump from the unprotecteds to the protecteds and go around your protectors. Did I use the word protect enough in that sentence? Okay, so you want to make sure you've got a bundle of protected stuff and a bundle of unprotected stuff. And those are connected to your external ground electrodes or rods, and the NEC is unequivocal. They all shall, there's no wiggle room in shall, be bonded together. And that means you run a big number 6 or whatever between all of your ground rods, because otherwise, what are they connected with? They're connected with dirt, okay? What is the resistance of dirt? Dirt has a lot of resistance. So if you get 1,000 amps from a lightning pulse flowing through dirt, you can get thousands of volts between your ground rods. So what you do is bond together, and that creates what's called a perimeter ground system. When you bond all of the stuff together and connect it to your perimeter ground, all of your protectors fire at the same time. Ron Block pointed this out. This is really, really important. You've only got a few microseconds in this lightning pulse. Okay, so you don't want one ground to get a big pulse, and then maybe later another one gets a big pulse. You want them all to be at that same voltage going up and down together, and you do that by placing all of the arresters together. And then your whole system goes up and down together. Minimum voltage between these different conductors. This includes your non-RF and your AC power. So you want like a trip light power protector, not just like like a power strip, you want an actual power protector. They're not that expensive, 35, 50 bucks. Metal box, you mount them on this panel, and then you run your branch circuit to the protector, and then you run another power cable to your station. And it typically only takes one branch circuit to run most ham station equipments. Amplifiers, you have to run a second circuit. And we keep protected and unprotected cables separate. So here's an example. This is K4RO's single point ground panel. Kirk lives on a hilltop west of Nashville. Hams always live on streets that have like Scenic View Drive, Tower Hill, Sunset Ridge, all this kind of stuff. So he's up there, and he was getting nailed by lightning regularly. And every time there was a big thunderstorm, he would lose some piece of equipment. So he finally said, I'm done with that. And he's got one of these 2-level houses where you drive into the garage. This is in the garage, and his station's right above this panel. So all of the stuff, all of his antennas, feed lines, everything come to this panel through the wall. It's one big piece of aluminum, and he mounted everything associated with the antenna system on that panel. And you can see switches, filters, all kinds of stuff there. And then his ground wire is up at the upper right. You can see that copper wire going through the wall to his ground system. And since he's done this, he's lost no pieces of equipment. Been years. So it's a definitely day and night situation. Here's a couple of single point ground panels. I have several at my station because my station is also on a high spot, and it also has burned trees and all sorts of things. And I know the towers have been hit, 60-foot towers. And so I have several of these panels, one at the base of the tower, one outside the house, and one actually in the station to make sure everything is really thoroughly bonded together. And so I have a big metal rack, and I put everything associated with the antenna system and the amplifiers and all that stuff is in that rack. And you can get those racks for free, pretty much. You just got to make yourself known, and they will say, get this stuff out of here when they are redoing IT or something like that, and you go get it and haul it away. And on the back, you can see a couple of big panels there on the right where I have power switching and an antenna protector, and that's all bonded together, and then it goes out to the perimeter ground system, which is just a few feet away. This is from Ron Bach's 2002 QST articles. He talks about what's called a protected zone or zone of protection. And so you figure out what you want to protect, and you get a piece of paper, and you write a little box and make a little box for every piece of equipment. He's even got a wall clock on here, one of those little alarm clocks that's up at the top. Your TV, your tuners, your radios, everything, you put it inside the box. Everything you want to protect, you draw a line around it, and you show each connection to each one of these boxes. Everywhere one of those lines of connection crosses that red line, you have to have protection. Those cables must be protected somehow. Either they have to be powered from protected power, or they have to have an antenna protector or something like that. Because the one that you don't, that's where lightning will get in. And if lightning gets into these zones of protection, it's just as bad as if you weren't protected. So basically read his articles. They're free. They're on the ARL website. Just search for Ron Block and you'll find them. July, August, September 2002 QST. And he's the same guy that wrote the book I just told you about. Okay, let's jump over to RF management. You have to remember that everything in your station is an antenna. And as we all know, the more you don't want something to work as an antenna, the better it will work as an antenna. And it's just the way it is, okay? So let's think about this. You've got a 40-meter dipole in the backyard. What's the wavelength of 40 meters? Oh, now we're getting somewhere. We're cooking with gas. Okay, 40 meters is about 130 feet. If your station is within 130 feet of that dipole, you are less than one wavelength from the antenna. You're in the near field, even though you can't see it and it's way out there. So you're going to pick up RF. You're going to light up every stinking wire in the shack. Your feed lines, your protected cables, your RF bonding conductors, all this kind of stuff. Your mic cord, you are conductive, so you're going to pick up RF too. So you got to forget about keeping RF completely out. Certainly there are hot lines that you can put some ferrite on and things like that to help. But everything is going to try to pick up RF. Then we talk about an RF ground. Why don't you forget about that term? It's really not possible to make a single point in your station that is 0 volts at RF over the frequency range that hams operate. We go from 160 meters to daylight, okay? So it's not going to be possible to create a, quote, RF ground. Concentrate instead on bonding. You don't want 0 volt absolute. You want 0 volt difference, okay? So you're trying to keep everything at the same voltage, whatever that voltage is. And it's just like in an airplane. How many people have seen an airplane dragging a chain to contact the earth? No, not very many. Okay, so everything in an airplane is bonded together. You've seen pictures of lightning going through a plane on the way to the ground. Everything in that plane went up and down together, and it's kind of the same for a ham station. You want everything going up and down together. They're all bonded together. Your connections are all electrically short. You're not running big cables over here and around here and back to a point on the wall. Keep everything at the same voltage. If you add an amplifier, not only are you going to meet the neighbors, but you'll also have high RF field strength. You'll find all the weak spots in your bonding. Trust me on that. So you have to pay extra attention to bonding. And so you can do this. The easiest way to do this is by creating a common reference plane, meaning basically a metal sheet under or next to the equipment, or some kind of a bus. And we've all seen this picture in the handbook for many years. We go get a 1/2-inch copper pipe because that is the cheapest copper pipe we can possibly get. And we put it in the back of our station, and then we run a short wire from all the equipment to this copper pipe. And then the copper pipe is connected to our single point ground panel. When you connect to this copper pipe, if you use this technique, do not use hose clamps. Hose clamps are not made for metal-to-metal connections. They're made for holding some flexible material, like a hose, onto some inflexible metal pipe or tubing. Okay, if you put 2 pieces of metal together and hold them together with a hose clamp, you'll be amazed as thermal cycling occurs, how that clamping action will loosen up. So these are not really good for ground connections. You can use sheet metal screws and terminals. If you use terminals, use toothed lock washer terminals. When you clamp them down, they will bite into the metal, and that makes a good electrical connection. The little split O's are just not very useful electrically. Use the tooth, internal or external tooth. And you can also use ground clamps that are made for ground rods, because a 1/2-inch ground rod is pretty much the same size as a 1/2-inch piece of copper pipe. So you can actually go out and get a big one of those contractor bags of acorn clamps or something like that, and you can use those. Another thing I've been using is the ground bars that you can buy for the AC service panels. If you go to the service panel part of your hardware store, you'll see these silver bars up there. Some of them have 5, some have 7, 9, up to 20 something, and they're made for connecting the ground wires in your AC wiring to the neutral bus and the ground bus of your AC service panel. They're pretty cheap. They're sold in volume. They're not specialty items. And those make really good ground connections as well. When you are doing your cabling and you look back at the back of your equipment, the first thing you got to give up is this notion that you're going to get rid of ground loops. Ground loop is any conducting path between 2 pieces of equipment around between a couple of cables. And you can't get rid of that in a ham station. Even a modest ham station is going to have dozens of ground loops. Just in this little this little drawing here, there are more than 24 possible ground loops in this. So don't worry about the ground loops. You're not going to get rid of them, but you can bond to short them out. And that's what bonding does for you. It makes you less sensitive to these ground paths. Use the shortest cables you can and coil them up. And if you coil them up in a figure 8. If you coil them up in a figure 8 and you expose the coiled up cable to a magnetic field or an RF field, the voltage that's picked up in each half cancels out. So if you just coil it like this, it's like a secondary of a transformer. But if you do it in a figure 8, you can cancel out a lot of that voltage. You want to put your cables on the bonding bus or a ground plane, and I'm going to show you the reference plane here in a minute. You always use shielded cables, even if it's just for a switch, because it's going to pick up RF and it's going to go on those switch wires, and whatever you have that switch connected to, that's where the RF is going to get in. So always use a shielded cable if you can. And short straps or wires, they shouldn't do this. I realize that's not always possible, but they should be as short as possible. This is what a reference plane looks like. You can see the shiny thing under the monitor there. That's at one of my stations. It's basically a Costco table, a poor defenseless Costco table. And I went out and got a roll of aluminum flashing, okay? It's the cheap stuff at the store, and I just laid it on top of the table and took a drill and some sheet metal screws, pew, 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 and that's my ground bus. That's it. There's also a ground bus in the back that makes it easy to connect the ground wires to. And I've laid all the cables on that, and so that reference bus makes sure that everything is at the same voltage when RF comes to visit. Here's a picture of these ground bars. I didn't know if I had that in there or not. The thing at the lower right, that's a 15 maybe, or 15 position ground bar, and that would be bolted into an AC service box. It costs about $3 or $4. You put that right on the plane, you screw through the bus into the plane, and you use external tooth lock washers to make sure that you have a good connection that stays there. And then over at the right, you can see my BAW that is connected from the reference plane, and it goes out to the perimeter ground system, which is a few feet away. And there's a big terminal, stainless steel hardware, external tooth lock washer. Okay, additional resources, and these are out there. The National Electrical Code was written by the National Fire Protection Agency, which tells you a lot about what they were trying to accomplish. In the early days of electrification, there were hundreds of fires and electrocutions and all this kind of stuff. And so the fire people said, we got to deal with this, and they own the National Electrical Code. The International Association of Electrical Inspectors is another good website, and that tells you what they're looking for, and there's some training and guidelines on there. Mike Holt Enterprise, Mike Holt is an ex-electrician. He now trains electricians. And so there's a ton of free stuff on his site, a lot of good drawings and rationale for simple things to do. And then Polyphaser, because the founders were hams, they wrote a lot of white papers, and there's still stuff on the Polyphaser website. And then for those of you who are really interested readers, the standards that are used to generate this stuff, the Motorola R56 standards available online as PDFs all over the place. That's for VHF and up communication sites. The FAA document on practices and procedures. It's 6950.19a, and that tells you how they construct their communication site. IEEE standard, if you're a power person, it's expensive, but you can get it through the libraries, and that really tells you everything you want to know about power system grounding. And the Mill Handbook 419A, Jim references in his talk, that is how the military builds their HF communication site. Now, you don't have the budget they do. So basically what you do is you look at these standards and the books that are written from these standards, and you go, okay, what are they telling me to do? And then you look at your resources and your materials and wherever you are in your station, and then you try to emulate that as best you can. So there's some books. Ron Block's The Grounds, and his new book, Lightning Protection for the Radio Amateur, is really good. And then K.A. Rand, another Polyphaser book. And the ARL Technical Information Service has a ton of really useful information. People don't know about the ARL TIS. They've been busy trying to deal with the hack and other stuff, and it's not real well publicized, but it's a tremendous resource, technical resource. Go to the technology tab on the homepage and follow that down to electrical safety and grounding and lightning protection, and there's a lot of stuff. Ron's papers are down there in the lightning protection. So we're going to take a break, I have some time for questions if you have it. Do you want to have them ask questions now?
It's only 10 after 3, and we have till 3:35.
Oh, well.
So we got tons of time for questions.
Well, I blew through that. Okay, so let's have some questions. If we've got a field mic, can we take a microphone out there? We meaning you. Yeah. Hola. There. Come on up and talk into the microphone.
We're recording this session, so we need to get clear questions.
If you're bonding your towers across the yard, can you bury your ground rods and your wires under the ground so you don't hit them with your mower?
Okay, the question is if you've got a tower out in the yard someplace and you got feed lines and wires and stuff, do you bury them? What do you do, right, essentially? Okay, NEC says you can use feed line shields as your bonding ground conductor. Once you get more than about 50 feet from the rest of your house and your perimeter ground system, the ground is too inductive. That wire, length of wire is too inductive to be helpful, but if you can bury it and it's bare, it's a perfectly good ground electrode all by itself. But I would not run an insulated or isolated conductor from a ground system through conduit out to your tower and expect it to do anything but give you an AC safety ground.
And a second question, when you buy power supplies, why is there not a grounding nut on them? Even though
Oh, okay, power supplies. Most power supplies are made to float, so you can actually connect them together and make like a 24 volt or something like that. And there is generally a terminal close to the output negative of a power supply. If you go in there and open the enclosure, you can find a terminal that you can connect to it. Sometimes there's also a ground terminal or a jumper on the outside. And if you want to, then you can connect the negative of your power supply to your system ground. Otherwise, it's going to float.
Hello. Yeah. My electrical service comes into my basement on one side of the house. My ham shack is on the other side on the second floor.
There you go.
My antennas are coming in on that side with a ham shack. All of the cables are connected to right angle copper. And I have, let's see, there's a ground rod right below there. There's a ground rod by where the electrical comes in.
Mm-hmm. So what do you do?
Yeah.
Basically, you get the heck out of that room when there's a storm. Okay, that's a typical worst case. That's very, very common. I get a lot of questions about that. Basically, you treat your station like an airplane. You would just want to bond everything in that station together. And if you can, bring your antennas down to ground level and put some kind of a panel down there. I have at home, and not at the big station, I have some external antennas, and I bought a little trash can, and I put a ground rod right through the middle of it, and I mount the arresters right on that. And so in comes the antenna feed line, and then it goes up the side of the house on the other side of the arrestor. It's too far from a top level, apartment down to ground. That's too inductive. So it's not going to do you much for lightning. So basically, bond everything together upstairs. Don't run any of the ground systems through your house, okay? No ground conductors through the basement or crawl space. Don't invite lightning to flow through your residence or building. So that's got to all be outside. And then you just have to be careful. When it's stormy and stuff, you're floating. And I've got a second floor ham shack at home too, and I'm not in there when it's seriously storming. But everything's bonded together. Yeah.
I just want to thank you for your book and your videos because you saved my house. 3 top
I'll send a bill.
Yeah. 3 top rail fence posts, had a vertical on top of that, and I had 3 ground rods at the bottom. I figured give it some place to go. It won't want my house. That's exactly what happened. The lightning and the pole came a foot on the other side of my wife's head. Everything was good. Everything was fine. The other thing is I've been watching a lot of videos lately that I have a short, I use number 12 because that's what I just had, from my bus bar to every chassis of my computer,
Right.
my tuner, my everything. Is that proper? Because now I'm hearing people say, no, don't have to worry about it.
Oh, you got to worry about it, all right. It's when you have your grounds of your entertainment system and your computer and your telephone and your data service and all this other stuff, if they're not bonded together, when you wind up with a big lightning surge current that's flowing through the ground, something like that, they're all going to be at wildly different voltages. And that's when you hear stories like, oh, I was sitting there minding my own business and a thunderstorm came through and I saw the lightning and then there was this big green flash from my telephone to my computer and now nothing in the house works anymore. And you've got to bond your ground systems together. Whatever they're connected to, they have to be bonded together.
Yeah, I have seen people posting that you don't have to do that anymore. Not true. Bond and ground, it's critical.
Right.
If you want your equipment to survive. If you don't care about your equipment surviving, don't bond. You'll notice that moderator, I'm letting him do all the work.
So basically you said something about AC power protector. I assume that means like a surge protector.
Okay, the ones I'm thinking of, if you search for Isobar,
Yeah.
ISOBAR, and they have a sub-brand called Triplite, or it's vice versa, maybe it's Triplite is Isobar. And you can buy these boxes. Some of them are two outlets. You just see two outlets. It's got a big power cord that you plug into something. Get the biggest one that you can afford or whatever, and typically they're 4,000, 5,000, 6,000 joules. They're rated in the amount of energy that they can handle. Some of them also have little indicator lights on them to tell you if they've been compromised. So, and then strangely enough, they don't come with a ground connector on them, but then they're not selling them mostly to hams. So what I use is I undo the screw from one of the outlets and I use that as my ground terminal. I bond that to my ground system. So you're going to mount that thing on your ground panel or your single point ground panel. It can be on the inside. It doesn't have to be on the outside, which is exposed to weather. And then so you're going to plug that in, plug the big power cord into whatever branch circuit you're using to supply the station. And then you run another circuit from the output of your protector to where your station is, and you power everything off of that.
Okay, so if I have the station on the second floor and I put this on my single point ground panel, along with all my lightning arresters, should I have something outside close to the, like where the coax?
I would move if you can, put your quote entry panel down at ground level, as close as possible to your AC service. And then everything is bonded together there. And then you run protected cables up to whatever you use to get them through the windows.
Okay.
Okay.
All right. Thank you.
Yeah, some of these things will protect you just once. And so you want to check them. I get the, let's see, Alpha Deltas and DXC, and they have little cartridges in them. And once a year, I go out and I unscrew the cartridges and I look at them. And it's very hard to electrically test them. You would have to take them to a motor rewind shop and have them do a high potential test. But if they've been compromised, you'll see some little char marks, or you'll see some little pits or tits on the curved surfaces inside the glass cartridge. If they're a sealed glass cartridge, it's opaque. Just replace them once a year. They're not expensive. You can buy a box of them from Mauser for about $1 a piece.
I'd like to add one comment about isobar. I do the same thing you do with the isobars, but isobars also have 40 to 80 dB of RF suppression in them. So it helps keep RF off your AC cables. So there's a reason why they're expensive. They've got RFI filtering as well as surge suppression in it. And they also have a warranty with them. If your equipment's damaged when it's plugged into them, they'll replace your equipment. So they're worth the money.
It's worth it. Yeah, and I want to make a note that what the power company calls common mode is common mode between the hot and neutral. They're not talking about common mode on all three conductors. So what we talk about as common mode is RF pickup that's on all three conductors. So when you're filtering, you want to filter all three conductors. And the isobars do that, and you can also wind your power cord on a ferrite core. Okay.
Thanks for what you do, Ward. Postage stamp size lot, inverted V fed at the corner of the property.
I can't hear you. There you go.
Postage stamp size lot. Fed in the corner of a property, an inverted V, parallel feed line, coming into the shack, double pole, double throw, big ceramic switch to go to two different stations. I always, when I'm not in the station, it's always in the neutral position. What else would you recommend for parallel feed line suppression?
Okay. Lightning comes from 50,000 feet in the air, and it comes to your double pole, double throw switch, and it goes, what? You know, it doesn't care. Okay, it's effective at switching the feed line. Yes. Okay, so what you can do is mount a pair of spark plugs on a grounded plate and run that ground right to a ground rod. Run your open wire line down to these two spark plugs, and then run your protected line up to where it comes into your station.
Great, thank you.
There you go.
I'd like to ask you some questions about proper tower grounding and coax cables on towers. And there's two situations that a lot of us have to deal with. One is continuous towers like Roan 55G, and then there's the telescoping towers where you don't have good electrical contact between tower sections. I've always read that you're supposed to ground your coax cable at the top of the tower and at the bottom of the tower, as close to the ground as possible before you start coming toward the house. So you might address how that works with a telescoping tower because of the joint issue.
Okay.
Also, do you have any experience with, there's a guy by the name of Knott out there who makes these lightning dissipators that go at the top of the tower. It looks like a big metal brush.
Yeah.
And supposedly that causes lightning to avoid your tower. Is that black magic?
Even the broadcasting industry can't decide about whether the charge dissipator things, they call them porcupines, how well they work. And some people say, I put one on and I don't get hit anymore. And some people say, I put it on and it hit the porcupine. You know, it depends, like everything else, it depends on where the tower is located, what kind of storms you get, all this kind of stuff. It won't hurt anything, I'll put it that way. And maybe it'll work for you, maybe it wouldn't, but I would not recommend just a blanket, go out and get a porcupine and put it on the top of your tower. Okay, your other question about, okay, so you've got a tower, and we talked a little bit about inductance of the tower. You can think of the tower as a voltage divider, okay? An inductive voltage divider, inductive resistance. And if the lightning hits up here, you're going to get a progressive voltage drop down through the tower. The higher you take the feed lines off the tower, the higher the voltage they will be at during a surge. And even a little short piece of wire has enough inductance to make a significant voltage drop. 1 foot of number 12 hit with a kiloamp per microsecond surge will develop 761 volts from end to end, just a piece of wire. So you can easily get 100,000 volts between the top and the bottom of a 50-foot tower under a strike. So every 50 feet, basically, is the rule of thumb to bond your coax feed lines using a grounding kit or one of the grounding brackets. DXE sells them and other people. Where you actually cut the cable, put PL259s on it, and you got a little bulkhead connector in the middle. Yeah, you gotta go through all the weatherproofing and all that stuff. It's a pain in the neck. But you bond the coax to the tower every 50 feet or so, and that helps keep the coax at approximately the same voltage on the tower, and then you take it off as close to ground level or buried as possible.
Now, in the case of the telescoping tower, the cable hangs,
Right.
you really can't bond the cable to the tower other than at the top and at the bottom.
It's just a risk that you have to take. Luckily, there aren't too many telescoping towers that are really, really tall. So you bond at the top and the bottom, and that's about as good as you can do. Or you can make up some special clamps or something and just run a half-length cable down halfway, connect that, and that's bonded to one of the sections, and then the rest of the coax goes down to the bottom. And if you really want to, as you raise this thing, you can put on some kind of a stuff clamp or some other metal-to-metal clamp and then run a jumper around the sections.
Okay. And I think the last question that I have is, I've been told that as many panels as possible, put one at the base of the tower where you have all your suppressors and lightning arresters and what have you grounded close, and another one at the entrance to the building where you are, and if you can, one close to the shack before you actually run the cable.
You've been at my station?
Oh, so this is a recommendation.
Oh yeah, I got some cheap surplus electrical boxes from somebody, and I have one at the base of the tower, and there's a lightning protection. I have an RCS4L. It's a MFJ product, and they had lightning protection, which means gas discharge tube inside the switch. And so I had a remote switch, and I ran hard line out to the tower, and then I have 4 feed lines to come out. And also to the rotator cable. And here, I'm going to save you some serious money today. Save your money on the rotator cable. Don't buy the special multi-conductor, 2 different sizes thing that costs over $1 a foot now. Go out and get irrigation system control cable. A 10 conductor, number 18, you can pair up 2 sets of number 18 and make a nice number 16 out of it. And it's direct bury rated. You can put it right in the ground, and it's available. It's much cheaper than this stuff. And then at each place where you come up to your tower, for example, and you have a little terminal strip mounted on the piece of metal that you have in this box, and the piece of metal is grounded, and then you just put a gas discharge tube or an MOV or a Transorb or whatever you want to use from each line right to that panel with a sheet metal screw. I should have had a picture of that, but I have one of those at the base of each tower, and then I run everything into what I call the sacrificial barn. Okay, and so I have a big panel in the barn, and I have more lightning protectors there, more stuff on my rotator control cables, and then I run stuff underground to the house, and there's a little dog house there, and I have another panel. And I knew I was going to get hit. I just wanted to wear the lightning out to the point where they get close to my house, and he's just like, so it's worked.
Okay. And there's no issue with going through all those arresters and everything. At VHF and UHF, you wind up increasing your attenuation, I believe.
If you get the ones that are properly rated, it adds a little bit, but not much. It's a trade-off. Can you take 1/10 of a dB? If you're really, really, really high performance, you probably don't want to run a long run of cable anyway. You'll lose more in the cable than you will in the arrestor.
Thank you.
You bet.
Hi, thanks for the talk. I'm asked a question. My station, it sounds like yours. I have a single point ground at the base of each tower. Every wire that comes off the tower goes to a surge protector. Cables go underground. They go to a second surge protector, single point ground at ground level where the wires come into the house.
Yep.
My station's on the 2nd floor also. You failed to mention anything about CAD welding.
About what?
CAD welding for your grounds, isothermic ground bonding for the ground rods.
Yeah.
At my station, what I did is I started a perimeter ground around the building. I have a ground rod basically every 8 to 10 feet, and that attaches to the AC ground coming into the house.
Yep.
And that's what I've done to allow for a better ground system on the building. The only problem I ever had was actually when the transformer across the street shorted a 12 kV line and put 12 kV into the house. In that case, I have a pull down device in the panel box which took the house offline. Mm-hmm. It has saved me a fire.
Yep, I just had a tree fall. You really do have a very similar station. I just had a big tree fall on my service drop. Yeah, okay, I didn't get into the whole ground rod thing, but basically, I bought a big spool of number 6, and I found a buddy that had some surplus ground rods, and yeah, you space the ground rods approximately the length or twice the length of the ground rod. So if you got 8-foot ground rods, you put them every 15, 16 feet. You'll get real good. You get a lot of exercise, okay? T-post pounders are really good, things like that. And then you bond them together with clamps. You can use mechanical clamps, but then you have to inspect them every so often to see if they've loosened up. I got used to CAD weld, the one-shots. You like fireworks? They're fun, okay? So I watched the video on them, and basically it's you ground rod, you put this little crucible on it, you cut the 2 things or 3 things that you want to bond together, you poke them in the crucible through little eyelets, you pour in the stuff. Yeah, and then, well, not yet. And then you put a little shield on top, and then you put the lighting powder on top of that, and then the top of the crucible has a little hole in it. And there's videos on this, and I watched this, and I had never done one before, and I go, well, they must have really speeded that up because it just went poof like that. No, it goes woof like that, and you use a sparkler or a sparker thing, and it goes from 0 to 2,000 degrees Fahrenheit in about 2 or 3 seconds. And you wind up with a big ball of molten copper, and it welds everything together. And so you can bury that thing, and you'll never have to look at it again. And you just get good at it. 1, 2, prepare to lose a couple, prepare to sneeze in the top of the crucible and blow away the lightning powder. Don't ask me how I know that. Things like that. But CAD weld works really good. It's mechanically really sturdy, and building a good parameter ground system outside your house will save a lot of problems. Yeah.
Very nice talk. Thank you. What do you do if you have a contest station in the southern Caribbean that's on a 330-foot coral mountain with absolutely no ground? We can't drive a ground rod 6 inches in the ground.
Basically, you have an airplane. You know, you bond everything together. And I talked to like the cellular guys that do towers.
I sent an email to you a while back about this.
Yeah, you know, and I say, what do you do when you put one up on top of these mountains, you know, that are all granite and stuff? He says, we just run big, long, heavy, wide straps out from the base of the tower. We have to, we have to drill in and put some concrete in there, but we don't get a lot of mileage out of that. When the lightning comes, you can see the sparks flying off these things. I'm not sure I'd want to be up there when the lightning was coming, but they said you can really see it work. So the radials out from the base of your tower, buried or not.
Do you know how big to make these? Or
oh yeah, he said
we
it was
only
like
have, we only have 11 transmit antennas and 6 receive antennas.
Yeah. Well, they each one of them had like a 6-inch strap that was 30 feet long. So it's a lot of copper. You would simply stretch it out on the sand or coral or whatever you've got.
In all the directions that you can, right?
All directions, yeah. Just what does lightning want? Lightning wants to dissipate charge into the ground, and so give it heavy direct paths to do that, and that's as good as you can do.
All right, thank you.
3 minutes left.
There you go.
I want to make a comment about bonding. I used to work at a TV station where we had balanced video lines grounded on one end. A quarter mile of that has 750 volts riding on it all the time.
All the time, yeah. And
So-
you can have, there's a static field from the surface of the earth up, and it's about, I think every 100 feet you get about 300 volts.
Yeah.
And so when you put the porcupines on your tower, and if it's a real high tower, you will see corona streamers coming off that all the time.
Mhm.
And that's just from the geostatic field.
Yeah.
Yeah.
So that's all I want to say, and also good talk. Thank
Yep.
you, guys.
Just a suggestion, if you're driving ground rods, chuck it up into your hammer drill. It goes in very quickly.
Yeah, Black & Decker makes a really nice roto hammer, and the problem is when you hit a rock, and suddenly you and the rod and everything and the earth around you are vibrating, and then the rod kind of goes in like this. If you're in that kind of a situation, the NEC permits you to dig a trench, a shallow trench, lay the ground rod in that trench, and then bond to it like you would normally, or you can drive it in at an angle. But the important thing is to get as much surface area on the rod into your conductive soil as possible.
Okay, it looks like we got time for one more.
One more.
We talked about coral rock and trying to get effective ground. I live in Florida, sandy soil, water table typically 2 feet down. Putting ground rods in that, can you comment on what that does? I've never seen anything as far as measurements in terms of ground resistance, et cetera.
That's about as good as you can do. If you can get your ground rods into the water table, you're in pretty good shape. Yeah, it depends on the frequency. You know, at low frequency DC and AC, it's probably as good as you can get. And as you go up in frequency, you're going to get inductive effects and all these other things that'll make it hard for me to say. But the idea is you get a lot of electrodes into whatever ground system you've got, you bond them together, and make sure you've got as little inductance as possible, and that's as good as you can do.
Okay, very good. It was like I said, as a moderator, I let him do all the work. Thank you very much, Ward. We appreciate it.
Okay.
So we now have to supposed to take a 10-minute break. We'll restart at 3:45. It's RF on transmission lines, or my mind went blank. It's more RFI stuff. It's a Slane power line interference. And if there's time, I'm going to do a basic RFI.
Put that QR code back up there during the break, so, because I was trying to get a copy of that. Okay. And I was not quick enough. Or the presentation that you're recording, where is that going to be?
It'll be put out on YouTube. And this, what I'll do is, once they post it, I'll add that to my website. Go to trc.uru, and there's a page called miscellaneous, and I'll put a link to the presentation there.
I might be the QR code.
Yeah, the day after they sent me a note where it was, and a couple days later they sent me a link to a link up here. So I'll make a wait for the cleaned up version, and then I'll put that on my website. And this lady's page is basically just all amateur and everything stuff. No, it's sort of like that way. I got links to the spreadsheet and coax. My little coax Hamlet music I can never find anybody that's got it all in one place. So we're going to get it all in one place. So
That's going to take some time.
Okay.
Not a USB, it's over here.
That could create a problem.
You want this? Yeah, if we could put it in the other.
Yeah, it's not gonna go.
It's not gonna go.
All right.
So we'll have to go with what we got. We just.
Just hit the down arrow key.
Okay, so now what's going on here? Screen. Mouse, what's going on? There's no mouse. There's. Oh, here's
There you go.
Okay.
You don't want everything to hold the same.
We want the PowerPoint right there. Nope, that's a PDF.
PDF.
We want the PowerPoint.
Yeah.
Okay, here we go.
Okay, F5. All right,
I
we'll
don't
do
know.
it that way.
Yeah, we do it either way. Yeah, F5 work. That guy work.
I didn't bring the.
Here we go. Okay.
I think we go.
Excellent.
But thank you.
Round, everything is round, it's all round. When everything's the same, everything's got its round.
Hey, nice to meet you guys.
Finally.
Bruce got sick, and this room was too hot for him, so he went away. So you guys are up first. And if you guys finish and there's time, I got one I put together for basic RFI introduction kind of thing. If there's time left, I'll do that.
Sure.
If you need the whole time, that's fine.
No, I think 45 minutes, 40 minutes, and then a little bit of time for whatever questions you might have. That'll work for us.
Did you get you guys?
This is not.
That's not. Okay.
No.
No, that's not. But I think the one I gave you looked almost.
It looked very similar to that. Yeah.
It should be worth. What are you looking at?
We're gonna plug in the clicker, but it won't fit in the USB here.
There's a USB port. Right
Is there a USB there?
Yep. Now, you can also on Outlook, you can turn this thing on, and you can, get that out. You can do a laser pointer.
Oh. Oh. Oh, cool. Okay.
So-
That I didn't know about. This just to advance the slide.
Yeah, what I found out is most of my memory sticks would only work in this port. They wouldn't work over there.
Oh, okay.
Yeah, it came up first thing. You want to check, make sure clicker works?
Yep.
It works. Okay.
Yep.
Okay.
All right.
You want to drive? You want to talk? How you want to do it?
Why don't you start out? And,
Okay.
you've done presentation. I have.
Okay, we'll go for it.
I'll do a quick introduction, you guys, and announce the fact that Bruce isn't here.
Okay, good.
I announced that at the first, but.
Okay.
They've been trying to fix the air conditioner.
It's actually a fairly good breeze.
The breeze developed.
Yeah, we came in this morning, it was like, warm.
Yeah, this is, it's much better.
I was driving cars this morning.
Hard to say, this,
Man of many hats.
they helped us drag it.
Oh, yeah,
Yeah. You got us as far as the big concrete bollards. I can't drive in there. That's fine. We got doors out, and we walked a few extra steps, but he drove us the half a mile in.
Yeah, we used to be able to go through it. Thing, but it stopped a couple of years ago. But I work with 3 committees, and so I never know which committee is going to have my stuff to get in. So this year is formed.
Yeah.
Okay, well, let's see, how does the clicker work?
Advance, back.
Okay, forward and back. Okay, like reverse, forward and reverse on a car.
Yeah, that's right.
Okay, well, I guess we need to tell this.
No, it's 3:45.
We'll stand up and start off. Okay.
Okay, we're going to start the next presentation. The Bruce Sparrow with Ferrite Corporation was ill today, so he's not able to do his presentation. So we're going to start with the Slane power line interference, and when they finish, I've been working on a R5 basic presentation that I'll do to fill in the rest of the time. But our first speaker will be Gary Bishop, NQ0V, and Dan Fisher, AI4GK.
Okay, well, thank you very much. I'm Gary, November, Quebec, 0 Victor.
And I'm Dan Fisher, AI4GK.
And we're from the Space Coast down in Florida near Cape Canaveral, specifically Melbourne and Palm Bay. And we'd like to share what we can do to help you find power line interference and slay it. The man you see up there in the armor, he's our mascot. We call him Mr. Mew. And if you don't understand what that connects to, we can explain it later. But that's our mascot, Mr. Mew. Down there in Central Florida, we have a lot of activity with lightning. We tend to have the storms come up in the Gulf and drop not only a lot of rain and wind and the occasional hurricane, but a lot of lightning. Each square mile in our area receives about 40 cloud-to-ground strikes every year. And so lightning is a very serious concern for us down there in Central Florida. Here's a typical lightning arrestor, and this poor specimen here has given its life for the cause. It took a direct hit, it appears. In Florida, our power company, as is probably typical with most power companies, they use a value-engineered lightning arrestor. It meets minimum specifications, but it only meets it once. And, you know, we'll be you past that. Also, they don't necessarily fail closed, they fail open. And so a power company may not have any idea that an arrestor is not working at the time. So this one here is no longer working. And a direct lightning hit can wipe out pretty much anything, lightning arresters and transformers and stuff like that. So there's a shot of a defunct lightning arrestor. What we have here is, I think, a pretty typical scan spectrum of noise, and I'm going to see if I can get it to play here. I don't think I'm going to get it to play. Okay, well.
Maybe I have to turn off the lightsaber here.
Okay, try that.
Okay.
Well, what we've done is we've captured. I think we all know what that sounds like. Yeah, okay. Okay, that was a particularly poor example or a particularly poor condition with tremendous power line noise.
Great example.
Yeah, well, a great example of power line noise. Unfortunately, we tend to come across that quite a bit there in Central Florida. But we're not exclusive to that. It's pretty much anywhere you have AC power. What we did is we took an audio recording of that noise, and we had one of our members analyze it. We had Ken in AKH analyze that with some fairly simple software. And Clyde, KD8AN, was the one that actually made the recording. And as you can see on this chart here, you see that there are very pronounced spikes every 120 hertz, and that's very indicative of power line noise. That's the real giveaway that we have a power line noise problem. And at first blush, a lot of people will say, well, no, wait a second. Here in the United States, our power line is 60 hertz, and a lot of other parts of the world, it's 50 hertz. So why is it 120 hertz? And the answer is, if you look at the sine wave there, during a single 60 hertz full sine, we have 2 points where we have voltage peaks, and at each peak, we'll get a breakover and we'll have noise generated. So power line noise has a very distinct and easily identifiable 120 hertz component there. In the Space Coast, lightning arresters are bane. They're the #1 cause of power line interference. And in order, maybe not a scientific listing here, but this is certainly pretty close to our experience. We have, as #2 problems with interference is solar installations. #3 might be vegetation or vines or tree limbs coming up, encroaching upon high voltage lines in the distribution system. And then #4, it's kind of hard to pick an exact #4, but loose hardware does happen, and we've run across a few of those. And switching mode power supplies are a real problem, especially those that are, again, value engineered, where some filtering components have been left off. And they tend to cause a lot of issues. When trying to track some of these things down, it's hard for folks to try to figure out where do you start. And certainly you can start in your own home with very simple equipment. What this is, just a simple AM radio is all that is, a little portable AM radio. Any AM radio with a loop stick will work. It has directional properties, as you can see on the chart there. Along the axis of the antenna is where a null is, so you can actually turn the radio until you hear minimum noise, and then the noise is usually in the direction of that axis. So you can start out with even the most simple AM radio and still start to get close. Don Kirk here, WDA-DSB, came up with a fantastic antenna for direction finding and for noise situations. In the March 2021 issue of QST, he gave all of the dimensions and the directions on how to build this thing. He has licensed that to DX Engineering. This is a DX Engineering equivalent of that antenna. Very heavy duty, works extremely well, and this is something we use. In my usual cheap ham attack at this thing, this is my go at the antenna. Again, it may not look particularly strong, but it doesn't need to be. It still has a loop of wire with a coax and a load, and it works extremely well for isolating out power line noise and other types of interference that we have to go after. So this is, highly complex, very expensive. Maybe $3 for the piece of PVC. I don't remember. Oh, yeah, sure. Well, obviously, you can see it's just a piece of wood in the middle. I drilled some holes in. These yellow spars here are just to kind of maintain the shape. These are wire-pulling fiberglass tubes that you buy at Harbor Freight in a small plastic tube for, I don't know, $7, $8 or something like that. So the yellow you see on there, just to maintain structure, is from Harbor Freight. The actual guts, the working part of the antenna, is the little white wire business. That's what really does the job. The yellow just holds it into a shape.
Hit you in the head there.
One thing that's the beauty of this antenna, besides it being small enough to carry around, you don't have to have a big massive array, is it has directionality in one direction only. It has one and only one null. And what makes that really nice for direction finding purposes is you simply turn this thing toward a null in the noise and walk that way. Most other antennas are bidirectional, like a loop antenna on an AM radio, that's bidirectional. This thing here, it has one and only one direction. And so it has a main lobe of maximum response down at that end, which we don't use. And down here is a 680 ohm load resistor, which we do use. So the null is off to your left here. This is the null. So you null the noise and you just walk to it. And that's what makes this antenna so great when we're out using it. So the modeling of this thing shows it's got at least a 21 dB front to back ratio. That's not outstanding if you're talking some big massive full-scale Yagi. We don't care about that. When you're out finding noise, that's more than sufficient directivity from front to back to be able to follow your nose, follow the minimum noise, and it'll track you down and get you pretty close to a noise source. Power lines, unfortunately, make really great HF antennas. They do really well at irradiating HF energy. And so sometimes power line interference can radiate for miles. We've had several situations where we had to wander all around the county trying to find a source of power line noise. So the very large power lines are great at carrying noise along with power to your homes. A property of the power line noise, though, is you get closer to the source, you can actually use smaller antennas with a little bit better directivity to try to start to isolate down where a particular pole or a piece of equipment or a transformer might be. Dan, could you show them this thing here? This Yagi that we're going to hold up here is a commercial product, but I think you can see it's not terribly complicated, but it is quite convenient for being handheld. And so when you get close in meaning, you know, a block or 500 feet or something like that, an antenna like this, then you can use to point at and try to find the maximum that is creating the noise, and then we can zero right in with that. So for long distances, you use a null antenna. When you get close up, you switch over to this thing. That's not the exact antenna Dan has, but it's very similar, you know, a small Yagi, handheld Yagi. The thing on your left is a printed circuit board that has a log periodic printed on it. It's probably $5 or $6 on Amazon or something. So it's not a particularly expensive antenna, but it does have a fair amount of directivity. Again, if you're working close in, that'll work quite well. And it's to point out that you need a radio or some kind of a receiver that has AM mode on it. You can't direction find with FM or sideband. There's just not enough energy there to be able to isolate it down, and certainly not FM. The purpose of FM is to suppress noise, not go find noise. So FM is really a useless mode. So whatever you're going to go after, power line noise or similar kind of noise, it has to have an AM mode to it. Here's a couple of our fellows. We're out on a request. Certainly, if you have 2 or 3 or 4 fellows that are familiar with the terrain, familiar with how the antenna works, and they've got some of their own equipment, it'll make it quite a bit easier. And not to rub it in, but that was January down there in the Space Coast. Yeah, they suffered mightily. Oh, those poor guys. One thing that is just kind of an operational convenience for us is that when being called out to a power line complaint, as we approach the area, we use our AM radios in our vehicles, and we tune it to either a very weak station or an unused portion of the band. And when we do that, then we're not really getting into the AGC of the radio. And by not getting into the AGC, then the loudness of the signal is pretty much representative of how loud the signal is coming in the antenna. So you can use your ear as a really good gauge as to how close you're getting to a source. And so an AM radio in a car can be put to really good effect. You know, so just as an example, if you hear very slight noise, you know you're a little farther away. And if an AM station that's nearby is getting wiped out, you know you're almost on top of it. Here's an example where we were called out for power line noise. We found this transformer here. It had some kind of a leak. It was leaking oil, and it had an internal problem. And what's not easy to see on that right-hand shot there, but if you look on the ground, you see a small mat or a tarp. That was an oil-absorbing mat that the power company put out there. So they knew this thing was leaking. They didn't know it was causing interference yet, but they knew it was leaking. So they had it in the schedule to replace. And when we zeroed in on it and said it's, it's causing a lot of,
One day.
yeah, a lot of RF interference there. The next day it was replaced. You think there would be some environmental issues with this thing leaking oil, but fortunately, modern transformer oil is just oil. It's not particularly dangerous. So they knew about it. RF report elevated the priority of this, and it got replaced pretty quickly. We've encountered quite a few problems besides power line where we don't have one particular person or company that we can point to that's responsible for the source of the interference. And that's why I put the onion picture up there, because when you get into that situation, and solar panels are one of them, you have multiple layers of companies and people responsible. And the reason why solar installations fall into that is because you got an owner of a solar installation, a homeowner usually. You have an installer that put these things in, and then you had the company that actually built the equipment or designed it and sold it to the distributor. And so if you isolate down any kind of interference to a solar system, it takes a lot of detective work and a lot of tenacity and a lot of dedication to try to help find what that is. Communicating the noise sources to your power company provides a benefit to them because it saves them resources and time in not running all over the county or all over the city trying to find a report of noise. Now, they are still responsible to fix that noise, but it may take their technicians or field engineers, it may take them quite some time for them to get out with their equipment to locate a noise source, and then they have to put it in the queue to get it repaired. We have found that we built some trust up with our local power company, and when we provide a report to them, they depend upon that, and they realize we're not only trying to save them time, but we want to cut the time off of what it takes to get it fixed. So, it's a two-way street here. And we've had a really good working relationship with the technicians at our power company. Another thing that makes it convenient when we are out and actually find the source is we can confirm that it was fixed. In some cases, the power company will come out and they'll do what appears to be defective, or they'll replace some components, and it doesn't fix the problem. And so we'll be called back out and we'll say, hey, great, you guys did good replacing that, but the noise is still there. And we'll try to isolate out exactly what piece of equipment is doing that again. So it's a kind of a feedback loop that if we're out there we being our team, our Space Coast RFI team, if we're out there finding it, we can have a chance to go back and confirm that it was either fixed or we haven't found the problems yet. If you do have power line interference, most hams are kind of at a loss. They're adrift as to what do you do? Where do you go? And we find that the response to our requests to help are kind of fall into three categories. Well, you can give up HF, right? That's a real option. Let's just give up HF. It's too noisy. You don't want to go there. You can go it alone, which means you could try to report it to the power company or officials or wherever you think may have the authority to get it fixed. Or you can contact a local club or RFI team. That's kind of what we're trying to drive you toward here. Now, not every area obviously has an RFI team, and not every club does. But certainly, many of the larger clubs do. And as a resource, you could contact the ARRL directly. They have noise fellows there that know how to ask the right questions, try to get enough preliminary information about the issue, and then they have some suggestions as to who you might be able to contact. So the league is certainly a really viable path to try to find help for power line noise. So if you try to go it alone, you're going to have a real tough time. It's going to be a tough experience for you. You may not be communicating the correct information to the power company. When they hear noise, they're thinking mufflers on cars or trucks or something. Noise may not register with them. And if you're communicating with others, and others meaning like regulatory agencies, either for your city or for your state utility regulatory agency, you also may have difficulties explaining properly to them what's going on. You might not know what to do if you get no action. You know, you report it, noise, day after day after day, and nothing happens. Well, do you call the power company again? Or, you know, at what point do you kind of elevate this or raise the priority of your request? You could actually be making the solution more difficult to arrive at by complaining to the wrong people. And how can that possibly happen? Well, if you call up City Hall and say, hey, I've got power line noise, typically at the level of City Hall, they'll kind of say, well, we need power. We need power lines. We're not going to deal with you. So, I mean, you'll get a very happy, supportive response, but nothing substantial, usually from local officials. So some examples, that'd be city council, county officials, public utility commissions, are generally less effective than trying to find the correct person or parties inside a power company to make a complaint to. You might be tempted to just run right off and complain to the FCC. Hey, power line interference, shut them down, fix that. Well, there is enough power line interference out there that the FCC does not want to deal with that directly, at least at the first blush. What they will refer you to is back to the ARRL, and the folks at the ARRL then will ask the correct questions, try to correlate your problems with some past problems, and could put you in touch with local teams or local experts that might be able to find a solution for you. So the league is certainly a viable alternative. But going directly to the FCC, you certainly have that right. That's your right as a citizen to do that. They'll bounce you right back over to the ARRL. Expectations. Well, you know, you call up the power company today, you expect it fixed tomorrow, right? Not usually, no. Some power companies are very responsive, and it's great to hear those kind of reports. Typically in our area, the power company website says they'll get back to you within 10 to 20 days. You know, real firm commitment there, guys. And in our case, you're really lucky if you get any feedback at all from the power company. It just goes into the black hole and you don't know what's going on. You keep calling up, making more reports, nothing happens. There's no feedback. And that's sad because it's very frustrating. But there are some very good reasons for that, at least if you're making your initial report through the website of a power company, is the power companies are very, very concerned about cyber activities on their website, about being hacked, about shutting down facilities or damaging facilities. So when you go to a power company's website, usually you're just limited to filling in text blanks. That's it, nothing else. You can't upload files, you can't, drop and drag or anything. You can type in what you can type in, and that's it. And that's the safest way for it to be for a power company. And we kind of understand that, but it also somewhat limits your ability to communicate your problem to the power company. So the cyber attacks have happened. There's a link. I realize you can't read that, but on our presentation, if you want to download it, or even through the ARRL, they'll give you links of where cyber activity has shut down utilities. The particular link I have out there is for a pipeline during a particularly cold winter some years ago. I don't want to put out the wrong number, but a cyber attack actually shut down this natural gas pipeline from the southeast to the northeast where the demand was highest. And it took several days for the companies to be able to get that pipeline back in service. So the power company's concern is real here, that by limiting how much you can actually put in a report. One thing that is also available to you usually is a report of a phone, just a phone call. There's a trouble number you can call. And they may be able to accept additional information from you. And they can enter it in their system and consider that relatively secure. And so if you say, I have particularly loud noise at Main Street and Park Place, or whatever you think you found, or a RF team has found, they can generally enter that themselves, and that will also lead to perhaps getting a quicker resolution. If you are able to, through the power company, though, it's recommended if you try to capture any kind of a work order number or a complaint number, supervisors, they'll only give you their first name, but a supervisor's number, in the hopes of there might be some way to track this. And why would you want to track it? Because in 10 or 20 days when nothing happens, you want to kind of go back and refer to your notes or refer to a work order number or something and say, oh, well, I reported it back in, nothing's happened, here's the number. They can have a chance to go looking that up in their system. When you use a local RFI team, there are quite a few scattered around the country here. The experts in those teams can usually go out and find the interference in very short order, and then that can be reported back to the power company very specifically. And it aids in not only making sure you find the problem on the first time, but also connects to the power company to say, hey, we know where this problem is. You don't have to spend a lot of time chasing your tail to find it. We've already found it for you. The best method and examples of how to report the problem is if you can get work order numbers or have some kind of tracking system. Again, sadly, our power company, even though they're fine folks, there's no way for them to feed back to us on the Space Coast what they're doing for a power line report. We have to have back channels, or there's some alternate means perhaps that we can try to find out what's going on. But officially, once a report is made, no one other than the original customer has any access to that information. There are quite a few, probably 4 or 5 really well-qualified RFI teams around the country. One that we've worked with quite closely and shared a lot of information with is the fellows up in the New England division. They have 50 members and 7 sections up there, so they've got a lot of broad experience, not just with power line, but all other kinds of interference that could be tracked down. Also, ARDC, who is here at one of the buildings, that stands for the Amateur Radio Digital Communications Group. They made available to hams or clubs grant money to either purchase equipment or to provide some kind of assistance to hams. And one of the things that they wanted to fund was spectrum protection. Well, trying to keep the spectrum clear of power line noise and switching mode power supplies was one of their primary goals. And so we were able to apply to the ARDC and get a grant to buy some nice equipment that makes it really easy to find some of these problems here. So several grants have been made to the RFI teams around the country for getting some equipment. There's always work in progress for RFI teams. The Northeast Division is New England Division is no different than us. They've come across all kinds of sources of noise besides power line and solar systems, LED lighting, power supplies, electronic devices. And we're all still learning. I mean, there's so many types of electronic equipment out there that we're still trying to figure it out. When we hear some interference or noise, we'd like to be able to put it into a database and say, oh yeah, that's this noise over here. Well, we're not quite that far yet. Other than the normal 120 hertz signature power line noise, any other kind of noise is not well defined. And so when we put our heads together, we're trying to make that easier and a little bit more efficient for all of us. The RFI team can provide follow-ups. We've had to do that a few times. In the New England division, fellow W4DD has some software, really powerful software that merges mapping and GPS and directional headings of interferences found on their equipment. And that can find or triangulate basically into interference that you may not even have access to in terms of a citizen. It may be on private property. But the W4DD software can triangulate that fairly closely and identify that for the power company. The power company can get in there and fix it. You can't go in there with an antenna to check it. So his software is really, really good for that. If the power company is not responsive, that's never happened to us, has it? No, they're always responsive. Well, no, if the power company is not responsive, teams have experience to know how to elevate the visibility and the issues that you're having here. Usually, the next step for for an RFI team is to go to the DARA and ask them for assistance. And they have the ability to write letters or make suggestions or contact CEOs of power companies. And in some cases, they get immediate attention. In other cases, they get ignored. That's just the nature of the beast. And so the operating agreement between the ARRL and the FCC says if the ARRL can't get satisfaction, then it gets bumped to the FCC. If it comes from the ARRL to the FCC, then it has some really good visibility at the FCC, and they can take action. But the FCC does want you to go local first, then through the league, and only if the league can't help solve it, then ultimately to the FCC. When you go to the ARRL and request assistance, either if you don't have an RFI team nearby or you reported things and you're not getting any satisfaction, their members up there have a checklist. They have a bunch of questions they want to ask. And the reason why they do that is so that they can help identify a suspected type of interference and also perhaps add it to a database so that we can capture that and follow that information on to the rest of the teams. So there are experts up there have a checklist, things they can ask you. We have a checklist on our website that does the same thing. We ask the same questions. We maybe pretty up the form a little bit, but we ask the same questions that the ARRL will want. Here is a letter that after a local contact didn't produce any action at all, we had to elevate to the the ARRL. The league then wrote this letter to the CEO of a particular power company and asked them for assistance in solving this, for citing perhaps some FCC regulations of unintentional radiators are interfering with licensed services, and that can get some response usually. And it also points out in the verbiage there that if reported to the FCC, this would be considered harmful interference. It would shut down not only amateur radio, it could shut down scanners, it could shut down, TV, it could shut down public service communications. I mean, you could extend that quite a bit, even though the original complaint is from an amateur radio operator. So once you got the power company's attention, obviously, you got to be a pleasant pest. You got to keep their feet to the fire, follow up, and you have to be reasonable. You got to give them a chance to fix it. So what's a reasonable amount of time? 30 days, 60 days, 90 days? I don't know. There's no defined answer here. I think 60 days would certainly be a long time, but so reasonable is in the eyes of the beholder. In the power company, reasonable may be forever. For Ham, it may be yesterday. But just to point out, though, once the ARL does make a complaint, then keep in contact. Keep your visibility high and see if you can keep pressure on them. Now, there's certainly some mitigating circumstances where a power company may not want to fix something right away. And, we're all reasonable, and we're aware of some of the emergency situations that TAMs may be called upon to serve. And in our case, down in the Space Coast, that's hurricanes. We get a few of those things. And when they do, it tends to have a real big drain on the infrastructure. There's a lot of repair activity going on. And that repair activity could even extend beyond just simply restoring service. It could be temporary situations where eventually service has to be replaced. The power company has to come back and put in better equipment. And so there's some logistics behind the scenes that you may not be aware of. I'm not saying don't keep complaining, but so there are some issues, though, where power companies truly won't have the capability to get at a noise complaint right away. Well, it could, yeah, it could fix the problem, if they got to do something like that. One thing, the last point on here is for underground service. Many companies are trying to make the push to put all their service underground. And so if you make a complaint, oh, I've got noise, it's wiping me out, and a supervisor looks at the list and says, oh, well, we're going to put that underground in 6 months. We're going to ignore that. You got to make a call there. Is 6 months of not operating HF, is that reasonable to you? It may or may not be. But if we can isolate down the exact problem, a pole or a transformer or an insulator or something, that's not a big expense to them. And yeah, sure, it'll go underground eventually. But, power companies not knowing it can be isolated that closely, they may want to procrastinate and say, well, it's all going underground anyway. We won't do anything about it. And we've seen that. We understand. Here's a form we have. Again, I want to acknowledge the ARRL. It's all the information that they ask for on their website. I just put a pretty picture on the top of it. And we put it on our website down on the Space Coast. It is a fill-in-the-blank kind of a form. You put in the text of all the things you think you need. There's a comment section on the second page. If you got comments or ideas, you put it all in there. And then it says where you mail this thing, and we get at it, and we contact the complainant. Here's some of the usual suspects. Right out front here is Dan, IF4GK. He's the chair of the RFI team down there in the Space Coast. We're sponsored by the Melbourne Club, which is called the Platinum Coast Amateur Radio Society. So we kind of are an offshoot of them. However, we intentionally downplay that connection, and we call ourselves Space Coast RFI team. The reason for that is we don't want to give hams the idea that you got to belong to the club or some club to get help for RFI issues. So we downplay that, even though behind the scenes, certainly we are sponsored by the Platinum Coast Amateur Radio Society. Again, there's some more of the usual suspects, and again, that was probably July, or I'm sorry, January or February, I don't remember when it was. Dan, you got a comment on that? Was that?
Well, we have, like Gary said, this is our original cast of characters that form the group, and these guys they kind of look like an F Troop bunch of guys, but we've got 1, 2, 3 guys there. The guy on the far left, the heavyset guy, he's got what, 60 some patents? Yeah. He's an antenna guy for a defense contractor, and he's
a scientist at Harris.
He is a senior scientist. Yeah. And so these guys are really brilliant. The guy, I point there, they can't see. Yeah, they can't see. The guy in the back is he's also a pretty smart guy, brilliant guy. So we have, I think we have on Space Coast, we've got several defense contractors, we've got aerospace companies, and a lot of those people are ham radio operators. So we have, we kind of have the pick of the litter of brain power behind this thing. So, it's a good group. One of the things that we try and do is like Gary said, we have contacts with the power company, and so we have phone numbers and email addresses that we've gotten over the years. We have a very good working relationship with the guys on the ground level at the power company, at Florida Power and Light. Can I say that? Yeah. And so all it takes is a phone call, and hey Paul, we've got this going on, and he'll come out and he'll take care of things. So we've gotten that kind of the workaround around the firewall, if you will, of getting into the company itself. He's not a ham, but he's very ham friendly. He loves hams. The investigator in the Daytona Beach area, which is just the next county north of us, is a ham. He just retired, so I'm not sure what they're going to do about filling his spot. But it's like Gary said, if we get to a point and we have a pretty good suspicion of where it is, we contact the ARL lab in Newington, and they have contact people for just about all the power companies. They have contact people for the solar power system companies. So he can pick up the phone or send a letter to, say, Generac, and say, hey, we've got a system, it's one of your systems, and it's over here and it's causing problems. And they can they'll get a hold of one of their local installers, and they'll send out some new equipment and get the problem fixed. So it's we've made, not just us, but in general, we've made good inroads to getting the stuff solved. So if you are plagued with what you think is power line noise or any kind of local RF interference, I would say contact, first of all, your local club and see if they have if they have anybody who's capable of going out. And I mean, you can do it yourself. You can go out and look for, for power line noise. But it's not necessarily going to be, the problem that you find is not necessarily going to be what's causing your interference. So, but it's not rocket science. Like Gary said, we started out with simple AM radio with a loop antenna. Gary's got a AM/FM shortwave radio with the loop antenna in it, and the antenna up there, it's a homemade. It's basically that, but It's another homemade version, and that's what we did. So it's not insurmountable. It's not the end of the world. You just have to be persistent with it. And again, try and find somebody at your local club. If you don't, then get a hold of the ARL. And if you need help in, I hate to hesitate to do this, but if you need help in getting a hold of somebody, you don't know where to go, the next slide is going to have our contact information. And you can contact me. It's my call sign, AI4GK@ARRL.net. Makes it real easy. Send me an email and say, hey, Dan, you know, I've got this problem. I can't seem to work around it. And so we'll get you in touch. You know, I mean, if you want to pay my airline ticket, we'll fly out there and and work on it. No problems there. I'm retired, and you know, the boss at home, she lets me travel to do stuff. So as long as it's not coming out of my pocket. So anyway.
Yeah, I wanted to mention, Dan, when you said we've got a good working relationship with the investigators, the field investigators with the power company, we have no control over their work assignments. That comes from their supervisors. However, the workers do have some latitude as to how they arrange their work and how they arrange their path to get to different jobs. And if we happen to contact a local investigator and say, you know, we worked with you before, can you check this out? At an unofficial level, it can usually get done fairly quickly. So again, we can't control his work schedule, but we can suggest a method of attack for some of the local fellows.
Yep. And he will, our local guy will say, all right, you know, go ahead, give me the information. I'll usually, you know, send him a copy of our form. Just give me the information, but it's up to the ham who's having the problem to make the initial contact with the power company. You know, I can't file your report for you. You've got to file it. And that's usually not real difficult. Although sometimes I know with our power company, and I won't mention the letters FPL, they have their form, if you want to call it that, you've got to go like the onion, you got to peel back the layers to find out where the form is. So to fill out, and you've got about 2 or 3 radio buttons and a couple of tick boxes, and you have a field about that long where you can maybe put some text in. So so that's where people like us come in handy, because I can get a hold of Paul or whichever other investigator. I can say, all right, this is what this guy or this gal is having, and you know, this is the problem, this is where they are, and that really helps them out.
Yeah, I think that's about it, Dan. I mean, we're trying to be a service to hams. We enjoy operating, and we see the pain that happens when interference occurs, and we're trying to put our expertise and heads together to see if we can help solve that. We're not 100% effective, but we're pretty good. You know, we're probably in the high 80s or 90s or something like that. We're pretty good. So I'm not saying, hey, we're great. I'm saying we want to be service to hams, and we want to help hams and not only enjoy the band, but be a service to amateur radio. So here's our final slide, and we've got a couple of pieces of equipment I want to show you real quick. We're not actually going to turn them on. I don't think we're demonstrating, but we want to show you what we were able to get with a grant from the ARDC that has really improved our efficiency there. So if you need to contact me, I am in the brochure. November, Quebec, Zero Victor at ARL.net. For whatever reason, Dan's information is not in there, but as he mentioned, it's AI4GK at ARRL.net. A copy of the presentation is on the Platinum Coast website at that link. Don't bother looking at the link. Just go look up Platinum Coast RFI and it'll pop up. So we want to share this information with hams to hope it'll benefit somebody. So I want to do just a quick show and tell, basically, and then we'll ask for questions here. So we'll start with this. Oh, okay.
Under the computers.
Okay, well, yeah, sure, we'll use that. We'll go for that. This particular piece of equipment is manufactured here in the United States, and it is a sophisticated form of a spectrum analyzer, and it's optimized for locating power line interference. This is the piece of equipment that the power companies will use, at least if they're well-funded or they're, dedicated in trying to find problems. This is the kind of piece of equipment they'll use. So you want to just kind of tilt it forward to them there. So it's got an LCD display and frequency knobs, and I think it goes from 500 kilohertz to about 2 or 3 gigahertz or something like that.
Basically an audio spectrum analyzer. Somehow we didn't turn it off the last time we used it, so oh, there it goes.
Oh, it makes a pretty picture. Makes a pretty picture. So, and going after power line interference, then the folks that design this thing know what they're looking for, 120 hertz spikes, and it is optimized to find those. However, it can find most other kinds of power line related noise, hiss or corona or anything like that. So we did purchase this through the ARDC grant. We want to thank ARDC for doing that. Because it has been a service to hams, and we like using it to help hams. So it's kind of a portable spectrum analyzer. And in this particular case, that spectrum analyzer did come with this small Yagi antenna here. They kind of came as a kit. This is kind of a nice, easy thing. You can't use that for satellite contacts because it's at 330 megahertz. I don't know why they picked 330 megahertz other than it makes a nice convenient antenna, and it's easy to point at what you think might be a problem. So it can't be a ham antenna, but it's at 330 megahertz, and that's a very, very typical frequency that most power companies will use close in to try to isolate out a problem. I'll hold this up next here. This is made by MFJ, or was made by MFJ, but it's just an ultrasonic ear. There's nothing real terribly sophisticated about it, other than the fact that through the middle of it, which is difficult to see from back there, but it has a focus hole in it. And you can actually zero in on a particular piece of equipment, meaning a single insulator or a single piece of hardware. The focus is so close on this thing that you can actually identify one individual component. A drawback to this that we've made aware of very quickly is that the source of the information has to be outside in the open. If the problem is inside a transformer or inside a piece of equipment or something, this hears nothing. It hears birds, it hears bugs, it does not hear interference. So the source of the interference has to be outside of a piece of equipment, and then this can be pressed into service to try to help isolate the issue.
Ultrasonic.
It's ultrasonic.
It's about 50 kilohertz.
Now, the people who made that device that we just showed also make a very similar device, and they probably charge what, about 10 times?
Yeah, 10 times.
Yeah, I would say 10 times of what you could got. It's a better quality piece, but it's like 10 times the amount. Now, this is an ICOM 705, and the nice thing about that is it is last gen. Power?
Yeah. Oh, there it is.
Power should be right there.
It should be charged up.
Yeah.
I'll get this.
There we go. It was last night. And the nice thing about that is it's it goes in AM mode. It goes multi-band. And if somebody has a problem that's not power line, okay, we do if we do the analysis that we showed you, and we determined it's a not power line, and we can tell a lot of times also just by listening to it, because power line noise, you end up being able to hear. So there's, like we have a gentleman in our county who is, he's got noise that's probably not power line, partly because all the power lines are buried in his neighborhood. And so we went out, we didn't have this with us, we went out and we think we narrowed it down to his neighbor's house. We're not 100% sure. So we're gonna go back out with the 705 and the flag antennas and see if we can, we're gonna listen on his frequencies that he hears it the worst on, and then we're gonna track it down that way. So that project is, it's a work in progress. Now, what else do we have? That's about it. It's about all we have for show and tell. Oh, we got the national radio. All right. You want to talk about it? Okay.
We'll make contact with
Now, this is a piece of equipment that one of our members had purchased, not this very same one, but he says, look, guys, he says, this is, I forgot what we paid for this, but it's not real expensive. But it's really handy. When Gary gets it all screwed together. Now, this is not coax cable. This is it's just a wire loop, and
Wire loop with a compass on it, kind of tell you which way to go. It has a preamp in it. It is tunable, so you can tune a particular frequency. I think the lowest it goes is 1 megahertz, and I think it goes up through almost 200 megahertz, depending on what loop you plug in here.
yeah,
So
it
the
comes
loops
with
are
a whole slew of loops too.
Yeah. Now, this thing by itself is not a receiver. It's just an antenna, but it has these great features where it's tunable, it's got high and low gain, and it also has attenuation that you can throw in here too. And there's a lot of times where the signal is so strong, you got to throw a lot of it away to be able to get a decent null or isolation on it. So there have been instances where this has been the right tool to go after something. But we have to have an external receiver of some sort, the ICOM, or even I've used a shortwave radio, an old Radio Shack shortwave radio that works a fair amount of the time. The ICOM is the ideal one though. So this was made by National Radio. There actually is a successor company to the original National Radio from the 1930s. And they don't make much anymore, but they still make this that helps hams out. So this is available online for a really low bucks.
It's just another tool for your toolbox.
That's all we've got.
Yep. Any questions? I think I'll do what they did earlier.
I'll hand you the mic.
Hand you the mic.
Yeah.
and
Yeah, that way we can all benefit from the question. You may not be able to benefit from no answer that we might not have, but
Yeah, one more thing. You guys might wonder about the yellow vest. One thing that we found out is that if you walk around town with a yellow vest and a hard hat and a clipboard, people leave you alone. Because
Oh, also if you got a radio talking to guys,
yeah.
you look
yeah.
real official that way.
So, yeah, we had one time before we had the vest, some lady, and good for her. We were in her neighborhood, and she drives up, she's in a minivan, and she goes, "What are you guys doing?" So we had to explain everything. So now we had, actually, I found a guy at Orlando Hamvention who does, T-shirts and hats, and he had a vest, and I said, "Can you do this and that?" So we have, radio interference team on the back. We have our Platinum Coast, our PCARS logo. So, this is who we are and what we're doing, and people tend to leave us alone.
Yeah,
Okay,
we don't raise suspicion when we're doing
yeah,
that.
if you got a question, come on up and you come on up.
I was just going to ask about the solar power. Is that only when it's connected to the grid, or?
No, some solar systems have battery backup and their battery chargers connected to that. So not only does the solar system charge the battery, which is a power supply, but then it extracts the power from the battery and delivers it to the grid or electric vehicle or whatever. So there's multiple power supplies involved with that. So the short answer is if it has a battery in it, it could be day or night.
Yeah, I've been chasing a bunch of power line noise problems down with Appalachia Power. I've got a cabin outside of Lynchburg, Virginia, having fits. But anyway, one thing that can be handy too in chasing noise down, or at least kind of giving you some ideas, if you have a mobile rig, dual band, some of them listen to air band, tune that down to like 136 megahertz, somewhere in that area. And just drive around, and if you pass poles that are really noisy, you'll hear the noise come up.
Yep, and the real key to that is the airband is AM.
Yes, and it's because it's in the AM mode, yes. But it's just a convenient way, and it's also close enough to the 2-meter frequency that the antenna is responding. So it's kind of a quick and easy way of kind of hearing a few noisy spots to give you a place to begin your search.
Another aspect to that is that if you're hearing interference on the aircraft band, I think the FAA is going to want to know about that. The FCC is going to jump on that. If you can report and you can say, hey, this is affecting the aircraft band, that'll raise a whole bunch of flags. And what you're saying also, we were going to mention it, and I don't think we did, is when we're going into a Ham's neighborhood, well, you did mention that, didn't you? We'll listen on an AM radio.
Yeah, AM radio in the
and
car.
we'll listen for noise as we're driving in. That kind of gives us an idea of where to start looking when we go on foot. Next.
Sometimes you get lucky. We've been lucky a few times with the AM radio trick in the car.
Okay. I guess kind of build off of his question. The solar systems you mentioned, like suppose you have one that's totally on private property, a closed system and that, do you have any recourse there, and do those cause any problems? Because we've got quite a few solar systems on houses in our neighborhood. Now, I don't think there are any problems with them that I know of, but I was just wondering, what do you do when you're dealing with something that's privately owned?
Well, there's the multiple layer approach of the onion. If you know your neighbor fairly well, you may be able to start very gently in that direction. If you don't know your neighbor or you do not wish to approach your neighbor, a couple of options are you could see if there was any building permit pulled, and that'll give you the name of the installer and the name of the equipment. I think the next stage beyond that would probably be contact the ARRL, and then they would try to find some local team or an expert that could come out and isolate out a particular solar system. We've had some solar systems repaired in very short order. Sadly, we've had one solar system that took over a year to get repaired because the homeowner was uncooperative. But ultimately, it got repaired. Dan,
And normally the solar companies they'll repair that or have that problem repaired at no cost. Sometimes the homeowners are going to go, well, you call the guys out and it's going to cost me another $10,000. No, it's free. They have to fix the problem.
Just a technical question regarding the loop that you showed at the beginning of your presentation. It showed the 600 ohm terminator. What was that other device on the other end of the loop, and what are the details on that? Transformer or something?
I'll let Gary talk about that.
The terminator where the null is a 680 ohm resistor. We're not quite sure how Don figured that out, but it does work, and we haven't monkeyed with it. On this end is simply a balun, a 4-to-1 balun. That's the guts of a CATV twin lead to coax converter is all this thing is. So it's not particularly sophisticated. It should be available. Now, it's not optimized necessarily for HF, but generally looking for power line noise, we got a lot of microvolts, and we can afford to throw a few away on a balun that's not optimized at HF. So, but that's all this is a 4-to-1 balun.
And
well, it's like a baby rhombic, yeah. But the fact that it is so very short compared to the wavelengths we use and the way it's terminated gives us that null that really makes this an ideal antenna for chasing stuff down. We really like it. It's not efficient, you're not going to have a lot of QSOs with it. In fact, 0 QSOs, you can't transmit into it. But for nulling out noise and chasing them down, it does the job.
Anybody else? Okay, John.
Well, thank you very much.
Okay, well, there's 15 minutes left. I got a 40-minute presentation I can try to shove in 15 minutes, or we could call it quits for now. Which, if you guys want to listen to it, I'll give it a shot. But I have a few yeses, so I'll give it a shot.
This is going to make a noise. Sorry. Another noise. I got it. You wanna, hold on.
Thanks again.
Okay, so this is something I started to put together as a starting point for solving ham RFI issues. There's some of this in there that their presentation was certainly better than mine, but I had to start somewhere. And I'd originally expected to have 20 minutes to do this, but I got 15, so we'll see how it goes. One of the things I always try to tell people is when it comes to RF, it's bidirectional. If it gets out, it also gets in. So you gotta worry about that it's bidirectional. And one of my favorite slides is this slide. It's, for one, it shows you how you can quickly turn a piece of coax into a usable antenna. But it's also, part of it is showing you the importance of controlling return current. What people don't realize is that the power that you're pushing down that wire, the center conductor, goes through the air, hits the shield, and comes back on the shield. So there's actually current flow through the air. And it's when you don't control that current flow, you have radiation. In a quarter wave pattern, you guys know what that looks like. Ohm's law can bite you. I mentioned that earlier. When it comes to RF, not only do you care about resistance, you also care about inductance. Is it near field or far field? Something that hams don't normally worry about is that when you're within, and depending upon who you talk to, it changes. Anywhere from 3 wavelengths to 1 wavelength is near field. The importance of that is you can have a signal that's near field that's, when you're against it, you're 50 dB over S9, you move out 1 wavelength and it goes away completely. Far field, if you move a wavelength out, you can calculate what the level is. Near field, you can't. If you're within the near field, you have capacitive coupling, inductive coupling, and so on. Where if you're in the far field, you're basically back to working with antennas. What are the FCC requirements? One of the things that in the FCC rules is that operation of an intentional, unintentional, or incidental radiator, which is all your, well, that includes everything. If it's subjected to conditions that has harmful interference being given to it, the device must accept that interference. Now, it must accept the interference from an authorized radio. The catch with this is that the FCC doesn't actually specify how you test it, how you confirm it, or anything else. It's just left up in the air. Europe actually defines it. The emission levels for the FCC is shown here. Here's what it looks like. The red is Class A, the B is Class B, and the reason why there's 2 levels is one's the levels if you test 3 meters away, and one's if you test 10 meters away. The Class B level at 40 dB microvolt is 20 dB over S9. So these levels really aren't all that great. And this slide shows you where you can see the formula where I said it was 20 dB over S9. Modern computers with having USB-C ports have USB-Cs that are capable of 20 gigabyte speeds And if they're the Thunderbolt capable, they're capable of over 80 gigabytes. And I understand that Thunderbolt 5 is even faster than 80. So anybody who's designing a motherboard for a modern computer that has USB-C on it, they're going to do a really good job of designing an RF quiet port, because their USB-C port's not going to work if they don't. They also probably have spread spectrum clocks in the system, and they cannot be turned off. If you go back 30 years ago, you could buy a motherboard, had spread spectrum on it, but it was your option whether you turned it on or off. Nowadays, it's turned on, you can't touch it. So here's a modern computer. I had a FCC lab, a company that does FCC testing, send me plots from a recent computer test. So this is what a typical computer looks like nowadays. And if I can turn this on. So down here, this down in here is probably due to the switching power supplies on the motherboard. The one motherboard I just bought has 27 switching power supplies on the computer board. Here's a plot of the frequencies from 1 gigahertz up. Here is what the conducted emissions report is from a TDK medical power supply. They had it posted on the web, so I grabbed it. The Thermulex Power was kind enough to send me plots from one of their power supplies. This is what the conducted line looks like from the line side of the power supply. And that's a chart of the levels. This is what the neutral side looked like, and the plot for that. And here's their radiated emissions, and they ran to the Class B at 3 meters, and as you can see, that's almost 10 dB of isolation of difference there. So their levels are pretty recent. Here's the same thing in plot form. You can see their margins: 7 dB, 8 dB, 13 dB, 11 dB. So they got reasonable margin. For production unit, I like to see 6 dB. Prototypes, I like to see 6 dB of margin. Production, I like to see 3 dB margin. So this power supply would meet my my normal requirements. Back when I used to do actually do certifications. Now, one of the things we talked about isobars earlier. Here's a picture of the inside of a triplite isobar, and you'll notice that it's got capacitors, it's got inductors. It's not just surge suppression; it's RFI filtering. It's anywhere from 40 to 80 dB of RF suppression, which is one of the other reasons I like it. Not only do they have lightning suppression, they've got RF suppression in it. Also, routing of power cables and signal cables and coax is important. You want to keep power cables and you want to keep your DC cables away from your coax. Your coax away. You want to keep all three separate. It's also important how you route them. I like to, on my radio desk, I got like 2.5 feet of separation between power and coax. But also, the one thing I wanted to point out, this picture of a power supply, these things over here are EM shields, they're not magnetic shields. Now, the reason why I cut this power supply apart was it was being used at a location that had 3 Kiwi SDRs, and they were having serious issues with noise. It was this power supply. So I cut it open just to see what it looked like inside. But one of the things you have to watch with these switching power supplies is right there is the switching coils. And in this particular case, there's a ground wire going across here. That ground wire is within the magnetic field of those coils. So those coils are driving switching noise onto the ground out both ends of the power supply. So that's why it was so noisy. So the point of that is when you're mounting if you're using a switching power supply, don't route wires on top of it. Don't like coil them up and toss them on top of the power supply. If you coil up some wires and throw it on top of that inductor, it's going to inject a significant amount of switching noise into those wires. So when you're using switching power supplies, you got to be careful about wire routing around them. I use switching power supplies. I don't have use problems with them, but I'm very, very careful about where I put my wires. The wire's external to it. There's no wires against it. The wires are always away from it. Okay, so for Europe, Europe has requirements for RF, not only the emissions like the FCC does, they also have RF susceptibility. You have to actually take products into anechoic chambers and test them to make sure they don't respond to RF fields. You have to test them for ESD. You have to test them for lightning surge and magnetics. So anything that's truly being sold in Europe is probably pretty good RF-wise. Medical equipment, there were some concerns about medical equipment. The FDA actually requires compliance with European standards, which requires a susceptibility test. One of the things I try to convince people when I'm reviewing boards and things like that is people like to put what they call moats in circuit boards. Well, the problem with that is when you do that, you end up creating an antenna. Here is this is how you can make an RF probe if you want to do RF diagnostics. You just break the ground on this loop and you got yourself basically an antenna. And this is a probe example. If you right there's no ground. All this is shielded, it's all grounded, and the center conductor is actually grounded right about there. But right here, there's no ground. It's a basic antenna. And that's how you can use to isolate noise on a circuit board. This particular one is from RF Explorer. It used to be available for $110 plus shipping. I got a suspicion they may not make it anymore. Another way you can make a probe is just take a piece of coax, RG58, and you can see the pictures here. You just cut it off, strip it back, bend it over, put some shrink tubing on it, and you got yourself what's called a bazooka antenna. I recently had a case to use one of these. We had at the site where they had the Kiwi SDRs. All of our search antennas, all of our diagnostic antennas had so much field to it, we couldn't isolate the source. So we switched to this, and we were able to get it down to a specific device. Here's another probe you can make. Let's see. My reason for watching for breaks and grounding is if you have a box like this, the two boxes that are connected together with a fully shielded cable, for all intents and purposes, you have one enclosure. So you always want to make sure your shields are 100% 360. It's no cutting corners. There's, for low-cost things, we're finding sources, HTs, nano SDR, you can use SDRs, dipoles, look for the nulls and not peaks. Ken Britton is usually out there in the flea market. He sells circuit board antennas for cheap and typically in spot 8121. Frequencies to worry about for local interference, you got frequency references, 10 megahertz Ethernet's 50 megahertz increments, USB's 12 megahertz increments, and VGA's got a ton of them. And most computers have got spread spectrum and have clocks in the gigabit range. Don't use cheap cables. Cheap cables are not made well. Use only C2G, Triplite, HP, Dell cables. The cheap cables, you're going to be forever sorry. Don't use cheap coax cable. Inside the shack, I basically use like LMR 240, LMR 400, sometimes RG220, RG 400, RG 142. Outside, you can use the cheap stuff. Inside, don't. Don't buy cheap devices or computers. If you're buying something on Amazon, a lot of that stuff doesn't have safety certifications. It doesn't have valid FCC tests. That's why they're cheap. Today, if you want to get an FCC test done, they're about $8,000 to $9,000, something in that range. If it's got transmitters in it, it could go even more. The last product I had quoted before I retired was $900,000 to get it certified worldwide. So if you're buying something for a few dollars on eBay or on Amazon, they haven't been tested. You're buying an unknown, and it's most likely an RF source. I call ground loops, I'd call it antique misnomer, and this slide goes, I'm basically out of time here, so I'm going to bounce to the last slide. If you take a picture of this, you can download the presentation. And if by some chance it doesn't work, just send me an email at my call sign at arl.net, and I will get it to you. But it's 5, I've run out of time. And you can send me questions offline, and I'll answer them too.
Thank you for pitching in when you couldn't do that, and even though it was a short presentation, it was very useful. Sir, what did you have to say about ground loops? That was the good part. What? Ground loops. What did you have to say about it?
It's a term that came out of when we had vacuum tubes. We had no grounding, and it was used to describe a common non-resistance. It's basically a current you shouldn't have, flowing through a resistance you shouldn't have, creating a voltage difference you shouldn't have. Me calling it ground loop makes sense. But in the 1970s, the NEC put in the requirement for wire ground. Safety standards started putting in requirements for how big caps you could have on the AC and limit the amount of current going into the ground wire.
And a bleeding.
Yep. Yeah, so there's all kinds of requirements to get rid of those currents that should never have been there in the first place. So to me, it leads people down the wrong path. Current you shouldn't have, since you shouldn't have, voltage you shouldn't have.
We have all our radios and our computers kind of connected together. Our ham shack with the audio mixes. So we get a ground loop from them all being connected to the power grounds, and then they're all connected to this audio mixer. So we get the ground. Transduce here, and that's
if you, like in the first presentation, work solar presentation on the report, you get all that stuff bonded together in one common bond, that'll go away.
Oh, so we did that, and actually,
Bars, what are those? They're AC outlets, and they've got line solar pins, surge suppression, and so they have some overhead in them. But they're like their typical isobars like $90, where a normal overhead strip's like $10. So they're expensive, but the reason they're expensive is they got a lot of stuff in there that'll.
and you can do 10 amps. A lot of these certain